Hi everyone! My name is Julia and welcome to EmberConf 2021. If you were unable to attend yesterday's pre-conference, be sure to log in to the Ember Discord server and join the discussion. I'll be posting fun facts about the speakers there throughout the day. We also have a companion app that you can access at meet.ps/EmberConf. There you can find relevant materials for each of the talks, ask questions, participate in polls, and upload photos from home. We have a terrific lineup of speakers and a schedule full of incredible content today. So let's jump right in.
Hello EmberConf 2021. This is the second virtual EmberConf, hopefully the last one. It really has been 10 years since we shipped Ember.js and then a week later renamed it to Ember.js. And when we started, we used to say Ember was going to be a framework for 10 years. Now, we didn't have any idea what 10 years from 2011 was going to look like. At the time, Bower was really popular. ES modules hadn't landed yet. Transpilers were still a pipe dream. All we knew was that things were going to change a lot over the next 10 years. And we knew that we wanted to build apps that could last for a while with our framework. And we also had lived through a lot of breaking changes in the past with other frameworks. And we also lived through a lot of apps that ended up doing rewrites for not very good reasons. And we really didn't like that. We really hated that. And we figured there must be other people who share our view that shipping apps is the most important thing. We should stop worrying about all this other stuff. And maybe we could build a community out of that. So how do we do? Well, my own app, Skylight, started on Ember before 1.0, and it's on Ember 3.25 today. And it's not just on Ember 3.25 because Ember is compatible. We migrated to native classes in 2019, we migrated to TypeScript in 2020, and you should definitely check out Kristen's talk about how we migrated to Ember and how we migrated to TypeScript, and how you can use TypeScript to become a more confident developer. In general, if you look at our code base today, it really looks like an Ember 3.25 app, which looks pretty modern. So here's an example. This is a component that was in the repository in 2014, which is the first commit with a README. And yeah, that really is what Ember used to look like. _super, this.get, define property, all that stuff. And this is the same component today, minus some comments. And it really looks like a component that you could write in today, 2021. Uses knowledge coalescing, uses TypeScript. And there's not really any good reason why we had to keep updating this component. It's just a feature flag component, it's quite small. But just because we kept upgrading Ember and just because people occasionally look at this, it got updated. And I think the really cool thing is that, again, even though this is such a simple component, we even migrated to use name blocks when they became useful. So I think this is pretty good evidence that an app that started way back when was able to use Ember to continuously ship features and eventually end up on something that looks really modern. But it's not just Skylight. It's not just because I work on Skylight that made that true. Heroku, Intercom, Square, and LinkedIn all started their apps on early versions of Ember, and they all kept shipping their features through all the things that happened over the intervening years. Intercom started using Ember in 2013, and Gavin loves showing this graph of what happened to their productivity. And they kept up with Ember over the years, and the fact that they did that really powered their ability to keep that going. I really love that graph. And it's not just high-profile companies. Really small companies also got the benefits of this. This whole spectrum shows that our plan of building a framework that we could use to build apps for 10 years really did work. When people compare frameworks, they almost always evaluate frameworks frozen in time. And they rarely examine a framework's philosophy for adapting to change. And they rarely ask how applications should adapt to change. The truth is that a framework can only be understood by evaluating how it adapts to change. By the time we're done today, I hope that I will be able to convince you that Ember's approach to change is the reason that so many apps that started nearly a decade ago with Ember are still going strong today. And if you take a look at those apps, they look like they were started yesterday. They look like they were started in 2021. Our story starts in 2011. At the time, I was a web app developer who had a full-time job working on Rails 3, and I was a core contributor to jQuery. And you know, I learned a lot about open source from John Resig. He taught me my pinned tweet. John's opinion about breaking changes was that they were bad. Breaking changes disrupt the ecosystem. They kill momentum. If people get left behind, then the benefit of going forward is slower because there's less people. Plus, you end up having to spend a ton of time on supporting people who can't upgrade. And this is all true, but when jQuery started, we did all this work to make mouse enter work, even though it wasn't supported on all browsers. But jQuery today still doesn't come with tap events. And the plugin model is based on manipulating a global prototype. Like, what? And you might want to use arrow functions, but oh well, jQuery's API is based on this. And this stuff adds up. Rails, on the other hand, had a pretty different perspective. We cherish progress over stability. I worked on Rails 3. I had pretty big goals for Rails 3, so I was pretty on board at first. But then I eventually realized that framing software development as a battle between progress and stability forced us to make a bad choice. Of course you would prefer to deal with regular breakage if the alternative is failing, but these aren't the only options. The truth is that progress and stability are two sides of a coin, and people force themselves into zero-sum thinking here. People get really annoyed at cruft in their code bases, and it becomes really easy to come up with a rationalization for making a big break. And you just have to get people whipped up for a little bit of time to make it happen. So you hear things like, we just have to rip the band-aid off. At the moment, these decisions sound reasonable. If you read the Python 3 blog post, it sounds perfectly reasonable. But here's the thing. Their perspective is on the extreme end of the spectrum. It's just that we have better language for talking about things that are on the extreme end of the spectrum than balance. For as long as I can remember, I've been haunted by the unfinished work of Jamie Zawinski, one of the original founders of Mozilla. After a year without shipping, he gave up. For him, shipping was the thing. But on his way out, he said it wasn't obvious to him that his goals were impossible. When he quit Mozilla, he left an open question. He left unfinished business. Was it possible to build an open source project owned by a community that prioritized shipping continuously? I was unsatisfied with the answers I had learned from jQuery and Rails. To avoid disruption, jQuery had accepted stagnation as a fact of life. And to avoid stagnation, Rails had accepted disruption as a fact of life. What this meant was that the status quo in open source was that you would get breaking changes every few years, and you'd end up rewriting your app every few years. Both disruption and stagnation are enemies of shipping. So if we want to find a solution for shipping continuously, we need to find a way to balance them. After wrapping up Rails, I found myself adrift. DHH hated client-side JavaScript, and the JavaScript community hated Rails. I really wanted something better in JavaScript, but basically all I really knew about JavaScript at the time was that jQuery turned into spaghetti once your app got big enough. I really wanted HTML and CSS to be central to the way I did client-side web development going forward. So I wrote Handlebars, a templating engine with an eye towards auto-updating, but I didn't really have any idea how to do auto-updating. Luck was on my side. Charles Jolly had built the MobileMe suite of web applications for Apple, and he was leaving Apple to invest in open client-side tooling. Charles had a reactivity system, and I had a templating engine. I was in. I joined his new company, Strobe. Charles introduced me to Tom Dale. At the time, Tom still worked on MobileMe, and we convinced Tom to join our team. This is how I imagine it went down. Charles taught me what he learned at Apple. Unfortunately, Strobe ran out of money before we managed to ship our product, an HTML5 deployment platform. When we were thinking about what a framework for 10 years meant in the early days, what we thought was that apps after 10 years should still look idiomatic for 10 years in the future. jQuery didn't pull that off, and even though Rails prioritized progress over stability, even Rails didn't pull it off. If we were going to build a framework for 10 years, we needed to figure out how to roll in innovation on a regular schedule. A framework for 10 years was an aspiration. What that meant is that shipping apps is the North Star. Disruption and stagnation are enemies of shipping, so we needed a solution that minimized both of those things. I want to give you a glimpse into what software looked like back then. We're going to take a look at the Firefox 3 release schedule, but this is pretty representative. It reminds me a lot of other software projects I worked on at the time. What you're looking at is a table that I got from the Firefox 3 planning wiki. Let's check in February. Whoops! Okay, let's check it in again in May. Whoops. These tables are full of references to code freezes. So let's check in again in July. The beta date from the previous schedule. Nope, didn't make it either. What about milestone 9 scheduled for October? What are these question marks? Okay, I'll put us out of our misery and jump ahead to March 2008. Well, we got some betas going, so that's great. And at this point, they'd kind of given up on trying to predict anything, and the table is just a list of releases that already happened. They ultimately shipped in June 2008, over a year after the original plan. You could tell the system wasn't really working by how much people had to beg you to follow the rules. We eventually reached a point where we wanted to commit to stability, and so we announced a pre-1.0 to start fleshing out what that looked like. In the meantime, Chrome had come out, and in their opening blog post they said something is wrong with the conventional wisdom. They said shipping faster means higher quality. It was counterintuitive at the time, to me at least, but it was intriguing. The thing is, it was aspirational. The thing that Chrome announced when they first shipped didn't work in the first year. There's a really good presentation by Anthony LaForge, who was Chrome's project manager at the time, that said basically that deadlines are bad. You don't want engineers to have to rush to avoid missing the train, and when that happens, releases get delayed anyway. And so they announced a two-part solution. It's not just about changing the timeline, although that matters a lot. Just going faster stresses people out, so you would need some new rules. So it comes down to two basic rules. Always iterate on the development branch, and always make sure the development branch is ready to ship. This all looked great to us. It was finally a way of thinking about development that didn't introduce all these moments that triggered disruptions. We announced that we would follow the Chrome release model, with a release every 6 weeks. A week later, we announced the details of the plan. It looks a lot like the Chrome model. We wanted to make sure it was super easy for our users to follow, so we invested in illustrations and diagrams. Our initial plan included all the elements that Chrome and Firefox had identified as essential. We would develop Ember on the master branch. New features landed behind feature flags, which avoids disruption. We would use overlapping channels, named exactly like Chrome. We would branch every 6 weeks. And importantly, we formed a release team to handle the automation. To ship a feature, all we had to do was change the feature in features.json to enabled. And then the next time we reached the branch point, the feature would be enabled in beta and eventually release. If I'm being honest, Robert Jackson is really the secret sauce in our automation system. So our aspiration was release every 6 weeks, no deadlines for features, no code freezes, and if somebody feels pressure to ship a feature by a given date, there's always another train. So we had the first part of our evolution strategy, a strategy to evolve Ember predictably, smoothly, and with minimal disruption over 10 years. How are we going to add brand new features? Release channels. The strategy was release channels. The next challenge came in our planning for 2014. Ember 1.0 had shipped with globals. Not just Ember as a global, but you stuck all of your application code into an application global, and people really wanted modules. So this raised two new questions for our evolution strategy. First, how should we roll out transitions from one idiom to another? And second of all, how should we future-proof idioms? We could do some migrations from time to time, but we wanted to avoid having it happen all the time. The situation back then was a mess. Forcing applications to pick module systems was a ticking time bomb to costly migration, exactly what we were trying to avoid. Things were so bleak that people seriously considered UMD this monstrosity. And the build tool ecosystem wasn't in better shape. Bower was the package manager for the front end at the time. Gulp, Grunt, and Brunch were popular, but they were primitive. This was a real challenge. We're not going to ask Ember users to wait it out until things settle down. It's not okay for Ember apps to be stuck on globals for years after everyone realizes it's a dead end. But on the other hand, rolling your own is also not okay. It's not okay for Ember applications to have to manage their own transition off of Bower, or off of Grunt, or off of whatever. But why couldn't we just say that this problem was out of scope? That it was something that Ember was just not going to handle? Migrating off of Bower was going to be disruptive to applications whether we caused it or not. We were looking for a solution that would allow Ember applications to use modules in 2014 without just kicking the can down the road to a costly migration in the future. This became something of a mantra to me. Narrowly focusing on Semver is a recipe for bad decisions. Semver is a means to avoid disruption. It is not an end in and of itself. Ultimately, we went with JavaScript modules. This was in 2013, but what we realized is that static analysis is really helpful for making adaptations over time. And static analysis was not easy with CommonJS and was not easy with AMD. But at the time, nothing supported standard modules. They weren't standard yet. If our goal was that everybody in the Ember community would use modules as the way of writing code, we needed a standardized build system. And the build system had to be part of our evolution story. What it means for something to be part of our evolution story is that it rides the train. What that would mean is that upgrading Ember updated your build tools. Evolving away from Bower or AMD could be managed through tooling updates. And because deprecations are an important migration tool, this allowed us to deprecate tooling changes. It allowed us to deprecate idioms. We had a solution for transitioning idioms over time, Ember CLI. But what about future-proofing? We want a solution to our problem that doesn't just recreate the same issue a year later. I don't mean that the solution is going to work forever, but rather that we've put some thought into the solution and that it has some properties that minimize future disruption. This part of the Ember 2014 blog post is a really good summary of why this worked out. The highlighted sentence, the lingua franca module format in Ember as ES6 modules, is still true today. But the second one is barely recognizable. It's a fossil from a bygone era. We ended up with a principle. When we're faced with a choice between today's popular solution and an equally expressive declarative solution, we pick the declarative solution. It's really hard to understand this principle from a single moment in time. At every moment in time, people say, why not just go with the popular thing? But when you look at this from the perspective of multiple points in time, over multiple years, the popular thing changes over time. That doesn't mean you should over-abstract just to future-proof. The declarative solution has to basically be as good as the popular solution, if not better, and there has to be a meaningful explanation for why we expect change to happen in the medium term. Modules were a pretty good fit for this philosophy. I'm not going to mark this as checked off because I think that there are other aspects to future-proofing other than declarative, but this is a pretty good lead, and it actually served us pretty well over the years. But what about removing features? When we first started, we cargo called to jQuery's defer readiness concept in a bunch of our APIs. But then promises happened. And so we needed a way to remove those APIs entirely, something we hadn't done before. And so we designed our first deprecation system. Of course, you can only remove something in major versions, that's what Semver is all about. But you first have to deprecate features. This is something that Semver doesn't actually say anything about. Additionally, we said that features can only be deprecated in Ember if a replacement is already available and enabled. That would mean that by the time something's deprecated, it's always possible for people to move on to the next thing. Only the first of these bullets has anything to do with Semver at all. But the point of Semver is to minimize disruption, and so our policy for removing features was focused on minimizing disruption, not just Semver. We lived through our first feature removal and added a new tactic to our evolution strategy: deprecation and Semver. Ember's first templating engine was a variation of Handlebars' normal string-based story, but that had some serious limitations. These solutions were reasonable compromises when we got started, but it was really time to do something about them. Here's the good news. Our evolution strategy that we'd been building so far was a really good fit for what we were trying to accomplish here. First, the new HTML compiler takes advantage of the declarative handlebar syntax to swap out the implementation entirely. Second of all, we had already created an Ember CLI HTML add-on to precompile templates. Because we did that, the Ember CLI HTML add-on can be updated as part of an Ember upgrade. Third of all, the work is definitely going to take more than 6 weeks, and we can stage it using feature flags. We can roll it out to release channels when it's ready. And actually, it's a good thing we did that, because we found the problem in 1.9 and we had to back it out. All we had to do was flip a flag in features.json, and everything else happened automatically. I think it's worth taking a step back here and think about what we accomplished. At first glance, it might look like all we did was work on process for a year. But all the process that we spent time on allowed us to do something pretty epic. We were able to take a string-based templating engine, which was aging out, and replace it with a much better strategy without breaking changes. We were able to evolve Ember without disrupting our users. This is what it means to focus on stability without stagnation. Stability is the means by which we deliver new features and adapt to changes without disrupting users. In a short amount of time, we were able to fully replace a string-based templating engine with a DOM-based templating engine and solve a whole bunch of real problems for our users without disruption. And that's a big deal. We got a lot done in the 1X era. It was all compatible, so it's hard to remember if you were around back then, but some of these things were really important. I got a standing ovation for killing metamorph tags and binatter twice. And if you look at this screen, there's just a whole bunch of stuff here that really matters. We made pretty massive changes. We added Ember CLI, we added HTML bars, we landed modules. And nevertheless, people were sticking close to the latest release. We were successfully cranking out new features. We were successfully bringing in the best ideas from the ecosystem to Ember. We were successfully avoiding disruption. EmberConf 2014 was great. At the time, Ryan Florence was in the Ember community, and I gotta say, on top of it just always being a morale boost for me to go to EmberConf and see all the awesome things everyone's doing, I always love our commitment to good illustrations and art. It always makes me feel good to go back to 2014 and see that our art was awesome even back then. We covered how to add features to Ember, how to migrate idioms, how to remove features, but what about designing Ember? If members of the core team have special status, that means that you can get disrupted out of the blue with no chance to weigh in. Also, members of the core team don't hold a special monopoly on understanding. Active contributors can often be just as productive as core team members in discussions. Community members have special expertise that can come up when you least expect it. And honestly, sometimes people just want to weigh in on stuff. Letting people weigh in on stuff without having to be an expert in the code lets more people participate. We added an RFC process to Ember before the stages process. And here are the rules. To add a new API that would require a feature flag, first you need an RFC. Removing an API that already landed unstable needs an RFC. And RFCs have to be merged before its feature flag can be enabled. And those rules apply to the core team, to contributors, and anyone who wants to participate in Ember's design. The solution for evolving the design of Ember's APIs, and also a lot of other things including actual design like the website, is going to be RFCs. But things don't stand still. In 2011, nobody was really doing client-side web frameworks other than things like Dojo, Sproutcore, and Cappuccino. But by 2014, other frameworks had become popular. Angular was hugely popular. Directives were like jQuery plugins you could use as attributes. And React wasn't yet the 800-pound gorilla we know and love. It had shaken up front-end for good reason. Basically everyone had cargo-culted two-way bindings from desktop frameworks. React showed that it's better to use functions to calculate values than just have data flying around. React also showed that diffing output is better than diffing data. And coarse-grained updates can perform better than ultra-fine-grained updates when considering initial render. And you really should consider initial render. All this made sense to us, but it wasn't going to be the last time there was a revelation in the front end. And we didn't think that people should just change frameworks every time someone comes up with a good idea. We got an additional sense of urgency when Ryan Florence, who had since moved on to the React community, showed Ember being embarrassingly slow in his talk at ReactConf. He said Ember made him say no when he wanted to say yes to things. He couldn't ship, so he switched to React. And that makes sense. Our commitment to continuous shipping doesn't matter if you can't ship what you want. But here's the good news, we thought. We've been building a system for doing evolution, and this is what we've been building up to. So Tom and I set to work on a rethink of our rendering engine. We got one-way data flow, we got coarse-grained updating, and the results were competitive. But there was a problem. We hacked and slashed to make it compatible with 112, and we couldn't wait to get rid of the code. And we thought, that's what breaking changes are for, right? Time to rip the band-aid off. We didn't actually say that, I'm just foreshadowing. This is like the Titanic. If you're from the Ember community, you already know the end of the story. And what's really strange is that we focused a lot on stability without stagnation during this period. We had done a ton of work to define a process for evolving Ember smoothly, and things were working really, really well. Angular had recently said that because the web was changing a lot, we needed a full break, and we didn't think that was true. When we got the results of the 2015 Ember survey, it was confidence inspiring. The plan was definitely working. We thought we had our bases covered, so we talked about it. We can do pretty phenomenal things like introduce a brand new rendering engine that brings your apps neck and neck, and in some informal benchmarks actually faster than React. I think that's a really powerful thing, and I think we need more of that in the JavaScript community. This is more foreshadowing. We thought we're going to make really good use of the strategies we defined. We have release channels. We have RFCs. We made a road to Ember RFC. We have deprecation. We're definitely going to make sure we deprecate everything we're going to remove. We felt really good about all of this. But then it all went to hell. You see, we had made a critical mistake. We thought deprecations and removals are now part of our process, so we can do a lot of them. After we landed 2.0, it started out really rocky. When we took a step back, we realized that our technical strategy worked. It let us stage features without disruption in 1x, and this is important. By following our deprecation process, we were able to land new features in 1.13 that were needed for the transition. So in 1.13, you were able to do all the migrations that you needed to do to get to 2.0. 2.0 just removed the features that were no longer being used. So that all worked, that all made sense, but we just did too many breaking changes. It felt like a failure. The thing is, evolution is not just about Semver. Semver helps us achieve the goal of shipping. If you use Semver to violate this goal, it's not worth much. There was a bright spot. A lot of apps did migrate. As best as we can tell, the apps that were stuck on 1.13 were just a minority of Ember apps. And our careful strategy worked for a lot of people. What we did was a meaningfully better path than just breaking everything. And the add-on ecosystem was making the jump. And as always, our community was amazing. Every time I go to EmberConf, it makes me feel better. So I wasn't ready to just pack it in. But honestly, the miscalibration really hurt. We figured out a lot in the 1x era, but our first shot at breaking changes got a lot of people stuck. If our evolution strategy was going to mean anything, we needed to rescue as many of the 1.13 apps as possible. The first order of business was making 2.x a nice landing place. When we took a look at the situation, we realized we only had one kind of deprecation. So the first thing we did was change the policy on deprecations to require that deprecations have a structured ID and a structured point in which they will be removed. And we also added an API so people could write tools for dealing with them one at a time. On top of that, the 6-week release cycle wasn't working for everybody. Some people could migrate to a new version of Ember every 6 weeks, but some people just couldn't ship continuously if they had to upgrade every 6 weeks for various reasons. And if people couldn't upgrade, then the entire strategy fell apart. Let's take a look at the 1.0 series. It goes from canary to beta and then finally to stable. And the same thing happens with 1.1, the same thing happens with 1.2, etc. We added a new channel called LTS. Let's take a look at the highlighted version again. We would add a new LTS version every 4 versions. All it really does is extend the cycle. The nice thing about this is that all of our automation works the same. All of the mental model works the same. It's just another channel. The RFC was approved in October, 2 months after Ember 2.0. So what did it do to our process? First of all, it changed the release channel rules to add one more branch point. And we also made a small tweak to intimate APIs. Despite 1.13, it felt like we were making progress. Our system was firming up. And then the 2016 survey came in. We already knew about the problems, but we didn't know exactly how bad it was. And it was pretty bad. 36% of our users were stuck on 1.13. On the bright side, people who made it to 2x looked a lot like the 1x survey from 2015. But the thing is, we were supposed to find balance between stability and stagnation. And to be honest, 1.13 just really hurt. So it was time to restore balance. We thought, let's try to do this stability without stagnation thing again. The process worked on 1x, so let's do it. Embereños, assemble. So for the first half of the 2x series, we basically repeated the process, plus improvements to the release process. We added subteams based on the Rust team's experience. We added a new mascot in Zoe. We landed LTS releases. We got some features done. And we just did a whole bunch of quality of life improvements. And the thing is, it worked. The community was able to build on a stable foundation. Things were trending in the right direction. But we had one more problem. We landed Glimmer in 1.13 to address a performance problem. But we created a new one. Component creation performance had gotten really slow. And this not only affected 1.13, but it also affected all of 2x. On top of all of that, Glimmer was better than the old rendering engine, but it was still not competitive with React, especially for first render, especially with a lot of components. I had a lot of ideas for how to make things better, but we knew we couldn't break everything again. We thought back to the 1x series and we realized that we had done HTML bars compatibly. The mistake that we made was just breaking too many things all at once. At this point, Tom had moved on to LinkedIn, so I did the work with Godfrey. We're going to do a drop-in replacement by leveraging our declarative syntax. We have release channels. Release channels are going to let us stage the work. It's definitely going to take more than 6 weeks again. We have Ember CLI to distribute the compiler change. And it's a drop-in replacement, so we don't really need an RFC. And we're going to try really hard not to deprecate things for no reason. We shot for the moon. We made a new benchmark that stress-tested component creation. Every one of those boxes on that benchmark is a separate component. And it worked. Glimmer 1 was much slower than React, but Glimmer 2 was twice as fast as React. So we talked about it at EmberConf. By 2.4, we had the new codebase integrated behind the flag. But unlike Glimmer, we wanted to commit to a drop-in replacement. Before we announced anything at EmberConf, we got Skylight working, at least as a proof of concept. But we had a problem. If we wanted to commit to compatibility, Ember's tests were going to get in the way. They were pretty coupled to the old implementation, and that was going to be a ton of work. We had hundreds of tests that were coupled to old implementation details. We needed all of our tests to be abstract enough to test both Glimmer 1 and Glimmer 2 at the same time. And that's easier said than done. And it wasn't a very mechanical problem. This required real engineering. But what we realized is that people always underestimate non-contributors in their communities. A lot of people would love to help, but they just don't know how. So Godfrey took a day and wrote a long and detailed description of the plan for migrating our tests. 45 different areas of the test suite needed to be updated. It was time to call the Ember community to action. Let's do this. And people did it. A community formed around it. The people who did the first implementations helped the people after that. When all was said and done, this became a key way that we think about solving problems going forward. Quest issues. We've used it ever since. It works. But here's the thing. The more you commit to writing instructions, the better it works. You have to take a leap of faith. You have to spend time writing instructions on the belief that people will show up. And in my experience, they always do. After porting, we had a new problem. Porting the tests made them run on Glimmer 1 and Glimmer 2, but sometimes the ported tests failed on Glimmer 2. Obviously, that was the point. So we had to make them pass. And what we did was we repeated the process. We did another quest issue. We made a big list of failing tests and encouraged people to help us fix them. Again, quest issues worked. Eventually, we got all the tests to pass. And it was time to get the community to test out Glimmer 2. At every opportunity, we made it clear that it was a drop-in replacement. If an existing app didn't work, we wanted to know. We wanted the release to be a drop-in replacement, no excuses. And things had really firmed up at this point. We had gotten back to the momentum that we were used to in the 1X series, and we didn't want to risk that. So after squashing all the bugs we could find in the alpha, we enabled the feature flag in the Ember 2.9 beta. At this point, the system had gotten really rote. Of course we're going to use release channels. Of course that's going to be how we roll things out. The betas started really well. People reported great success. But then a slow trickle of issues started coming in. They were mostly edge cases like block parameters named component, obscure issues with positional params, using string.length in a template even though it's not data bindable. We could have easily justified moving forward on grounds that these were edge cases, and honestly, if we hadn't had the 113 experience, I think that's probably what we would have done. We would have said, these issues are all about behavior that is not in the public API. It's beyond the scope of Semver. But as always, it's not just Semver. We needed to prove that we could do this as a drop-in replacement. On the bright side, our channels made it really easy to do this mechanically. Instead of leaving the feature on in features.json when we branched to stable, we turned it off. Automation handled the rest. And there were pretty high stakes. If we could get this done as a drop-in replacement, it would mean that we could make other major changes in the future inside of a major version. But if we couldn't, it wasn't clear that we would be able to adapt to future changes in the ecosystem fast enough. Major versions just don't come around quickly enough, and what we learned from 1X is that we can't pile in a bunch of breaking changes. So the stakes were really high. Deferring Glimmer 2 for an extra release was disappointing, but it was the right decision. We could always make the next train. We needed to find out if we could do this. Once we made the decision, the implementation was straightforward. Crank those gears. After 2.9, we burned down the rest of the issues, and we released Glimmer 2 with Ember 2.10. Glimmer 2 was in a stable version of Ember. Again, once we made the decision to land the feature in the stable version of Ember, we cranked the gears. And I think it's really important to take a step back and think about this. Because we landed Glimmer 2, a complete rewrite of our entire rendering engine behind a feature flag, We were able to make fine-grained decisions in real time about whether or not we should include it in any particular release. This allowed us to keep moving. It allowed us to work on other features. It allowed us to reduce disruption. It really worked. Once it landed in 2.10, people were psyched. They saw massive reductions in bundle sizes. And these tweets actually understate how important it was. The old templates were compiled JavaScript. The new templates were JSON. Not only were app bundles half the size, but all of the JavaScript parsing time for all the old templates is gone. It's a huge win. And I knew that something like this would happen intellectually, but we couldn't actually tell without trying it in real apps. And the fact that it was drop-in meant that tons and tons of real apps could use it. And when they used it, they saw huge wins. When you let yourself get seduced by the dark side and give in to temptation to rip the band-aid off, sure, you might be able to land something like Glimmer 2, but nobody will be able to use it. By following the process that we established, by cranking the gears, we were able to land Glimmer 2 in a way that everyone could use. We started out by saying that our goal was to let people ship consistently over time, without disruption, without rewrites, and we just faced our most serious challenge. After failing with Glimmer 1, our process had allowed us to swap the rendering engine in place, compatibly, without disruption, and all Ember users were able to use it. Glimmer has landed. Yay! We had learned how to make changes as radical as Glimmer 2 without disruption. What that meant is that we were going to be able to do it again. We had a process for making huge changes to the framework without breaking changes, while bringing people along. And then we got the 2017 survey results, and there was good news. By staying the course and giving people a good landing place in 2.x, people finally did migrate off of 1.13. People who were stuck on 1.12 for performance reasons also got off of 1.13. And here's the best part. We don't see a repetition of the 1.13 problem in 2.9. Another huge win? The LTS process was working. People were clustered around LTSs. Our improvements were really making a difference. At that year's EmberConf, we reflected. I just want to say bluntly, from now on, the process that we use for engines, for FastBoot, for Glimmer is how we're doing it from now on. We're not going to lean on breaking changes. We're not going to lean on big upfront design. We're going to instead lean on small primitives and compatibility as our main mantra for how we do new feature design. Eventually, it was becoming clear that we needed to do another major version. Honestly, the biggest impetus is that IE9 didn't have weak maps, and we really wanted weak maps. Reflecting on the 1.13 release, we realized that it affected the master branch a lot. You're not supposed to care about releases in the channel model, so something went wrong. We couldn't lean on experience from browsers and Rust here because browsers and Rust don't have breaking changes, so there was nothing to copy directly. But the release channel system is not that complicated. It's based on a small number of axioms, and so once you're bought in and you really believe in it, you can work out what you gotta do. Just like feature flags let us take a piece of work that takes longer than 6 weeks and stage it and then present it to the user all at once, deprecations let us take a removal, stage it, and present it to the user all at once. So deprecations are kind of like reverse feature flags. For 3.0, we decided that we didn't want to introduce any deprecations at the last minute. So we said, there's going to be a deadline for deprecations. No new deprecations after the deadline. But wait, did I just say deadline? Did I just say code freeze? Actually, no. We can add new deprecations whenever we want after the quote-unquote deadline, but we just can't target 3.0. So if you want to add a deprecation, you add it. It's totally fine. You're not stopped from adding a deprecation just because the deadline passed, but the number you put next to it is 4.0, not 3.0. It felt pretty different this time. When we were doing 2.0, we were kind of making it up as we went along. It's not really that surprising that things didn't work as well as we hoped. But when we were working on 3.0, all of our process gave us direction. Almost every problem that we had a pretty clear answer in our process. So we were pretty confident that it would work. And this adds another change to our process. I want to call something out here. This sentence only really makes sense on top of everything else that we did so far. We started out by saying that what we wanted to do was prioritize continuous shipping and minimizing disruption. And the thing is, this is what it looks like. It looks like focusing on this stuff. And it's worth pointing out that all of these changes were in service of shipping things. They were in service of landing things. They didn't slow us down. They didn't make it hard for us to land new stuff. They helped us land stuff faster. They gave us a rule book to follow whenever we wanted to land something. And most of the time, almost all the time, we can find a way of doing it faster than a major release, faster than a breaking change. Now that we've fleshed out so much of the system, we had a realization. The key tactic of release channels is staging. And by staging, I mean taking work that's longer than 6 weeks and still letting it happen on master. That's a pretty big deal. It lets all dev work happen in one place, but still reliably ship every 6 weeks. So what's a staging problem? A staging problem is a part of the process that forces work that could be done incrementally to become atomic. In this case, the mistake was thinking that features should only become stable when they are also ready to be recommended. But fundamentally, a feature is ready to become stable when the team is ready to make Semver commitments. By saying that features shouldn't land unstable until we're ready to recommend them, we're blocking features from landing unstable that are ready for Semver commitments. One major consequence of this is that add-on authors who could take advantage of the feature becoming stable to start doing migration work have to wait until we're ready to recommend the feature to the whole community before they can start. If you think about it, that's kind of a deadlock. Another major consequence is that it prevents people from using an in-progress but stable feature, even if they're willing to accept the confusion and churn. So we normally solve this sort of problem with release channels. A release channel clearly communicates what level of risk the user is taking. We have a similar problem here. Most people don't want to have to deal with features that aren't ready yet. They might want docs. They might want migration tools. They might care about other features that are part of the same feature suite. But that's not the same thing as canary. So what's the solution to the problem? Basically a new channel. This lets us incrementally stabilize features and have a separate mechanism for letting the ecosystem know when it's ready to use. Now, if a way to stage stable work sounds like a contradiction in terms, I think that's because we're assuming that stability is definitionally the end of a feature's development process. But as we've been saying all along, stability and Semver are not the whole story. Thinking of stability as the end of a feature's development process shortchanges all the other things that go into making a feature ready to use. So we have a solution to the coherence problem: additions. Additions solve the coherence problem by uncoupling stability in the Semver sense from recommended. We finally have a way of describing everything that goes into our evolution strategy that goes beyond Semver. Now that Ember and Rust did our first edition, we know that they're a big deal. But when we first announced them, and looking at this list, it's hard to put your finger on it. And again, I think the deal is, people are so used to thinking about everything in terms of stability in Semver that it's really hard to think about the fact that things like a coordinated change to idioms, or a product-wide refresh, or a marketing event should matter. So the dominant reaction that we got and the dominant reaction that Russ got was, what's the point of this? For me, the key takeaway is that there's so much about what it takes to build an ecosystem that can support continuous shipping, that can migrate, that can evolve, that has nothing to do with Semver at all. But those things matter. They're the difference between applications that can start on Ember 1.0 and land on Ember 3.25 using TypeScript, and applications that have to rewrite themselves multiple times over the years to accommodate ecosystem change. It's exactly the set of things that aren't captured by Semver that make all the difference. And in my mind, that's really the lesson of all this. By the way, we ultimately realized that additions are unnecessarily coarse-grained. The problem we were trying to solve is that we needed a way to take a feature and stabilize pieces of it incrementally. We want add-ons to be able to start taking advantage of stability, and we want users who really need the feature to be able to use it as soon as we can commit to stability. But we also wanted to find an endpoint for a feature that's more polished than what we normally require for landing it in the first place. The thing that's great about the recommended stage is that it gives us a clear definition of readiness that can be determined by the framework team and therefore can be understood by users. It lets us say features land on stable when we're ready to commit to Semver, and then we have quality control requirements that are necessary before a feature goes into the recommended stage. So let's make one final tweak to our evolution strategy. Instead of additions, the solution to the coherence problem is the recommended stage. So what's the whole picture now? First of all, we have stability stages. A feature starts out as an idea and becomes an RFC. When it's accepted by the team, it can be implemented behind a feature flag. When the team decides that they're ready to make a Semver commitment to it, they flip the flag and it makes it into the beta channel. After a 6-week shakedown cruise, it makes it into the release channel, and then we call it stable. Stable means the feature has Semver guarantees. Then we have a readiness stage. This has nothing to do with semantic versioning. This has to do with readiness. A feature makes it into the recommended stage when the team believes that it meets the quality control requirements. And from this perspective, an addition is just a collection of features that have made it into the recommended stage. LTS is not really a stage at all. LTS is there to help apps in the ecosystem synchronize cadence. Deprecated features have to be replaced with a documented migration path to a recommended feature. When we first added this policy, we wanted to make sure that deprecated features could be replaced with something that was ready to use, but we had no way of describing that. With the recommended stage, it's really easy to explain. A deprecated feature can only be replaced with a documented migration path to a recommended feature. And finally, we prefer a primitives-first approach to new feature development wherever possible. As a bonus, now that we have the recommended stage, we can crisply define the pit of incoherence. The pit of incoherence is that point in time last year that motivated additions. From this perspective, the pit of incoherence is just the time between stable and recommended. The long and short of it is that staging is now the core way that we understand feature evolution. And there are two new RFCs, RFC 617 for adding features and 649 for deprecating features, that describe the staging process in detail. And our toolkit is now filled out. After years of using it, I think we can safely say that it works. Now, I'm pretty sure we're not done here, but this system works. It works really well. I'm glad we stuck it out long enough to figure it out.
Hi everyone, thank you so much for joining us for this morning's keynote at EmberConf 2021. My name is Leah Silver. I'm on the Ember core team and I'm one of the producers behind EmberConf. I have a few little logistics announcements that I want to share with everybody and then we will get you on your way. So first of all, if you have a ticket to the conference, you should have received an email with access information for our companion app, which lives at meet.ps/EmberConf. And your unique code will give you access to the app, which will include lots of relevant links throughout the day, like slides and transcripts and other things per session that will pop up as you get into those sessions. It'll include surveys, giveaways, a neat little selfie feature so you can all just send pictures of your workstations and your day and your pets and whatever you're up to. And you should all be joining us in the virtual EmberConf channels in the Ember Discord. There's a hallway track for chit chat, and then there is a channel for each individual talk that will open at the beginning of the talk and then close at the end of the talk, just so we sort of move the chatter along to the right topical next channel. Each channel, the speaker will be in there. They'll be trying to answer questions during their sessions as much as possible, as well as after, even once permissions for everybody else has been turned off. If there's still questions, they'll keep communicating with you all that way. If you have little ones joining us, we have some kids content for them at emberconf.com/kids. We worked with 2 lovely local children's content producers here in Portland, Kayla over at Music Together, and then the gentleman behind Red Yarn, who are both celebrated kitty famous performers on some original EmberConf content. There are also some instructions on that page for activities they could do on their own. The kids content is async, so you can use it as it's helpful to help make your kids feel a little bit part of your day and this big time-sucking thing that's going to take you away from them for the next, 8 or so hours. Speaking of 8 or so hours, there is a lot of content. As you may have heard from various things we've said online before, we were pleasantly shocked by how many wonderful proposals came in this year through our public call for papers. And even after jam-packing Monday with sessions as well, Tuesday is still just a really long day. We've baked in a couple of breaks, but there was just so much to put out there. So you might want to look at the agenda and decide in advance, I'm going to sit this one out or that one out. You have a healthy lunch break, but the big bulk of content after the lunch break is going to be a bit much. So pick and choose what you want to step away for and what you want to come back for. Definitely come back for Ed's closing keynote and for whichever talks are your favorite. There are going to be breaks sprinkled throughout the day between talks, some 5 minutes, some 10 minutes. And some of those breaks will have a little other content in them, but stuff you can run to a quick bio breakthrough or whatnot. We're going to have some sponsor ads. We're going to have some community spotlight videos. Basically, we've done a bunch of stuff to try and recapture the hallway track, seeing and meeting a stranger outside a conference feel that we all miss so much. This is our second virtual EmberConf, and hopefully our last. It went really well last year. I'm optimistic it's going to go really well this year, but I miss seeing 1,000 of my closest friends every year here in not so sunny Portland. So hopefully we'll be able to see all of you here next year. If you need any help during the conference itself, myself and other volunteer administrators will be in the EC-Mods channel in the Discord for tech support throughout the day, like I can't get access to this channel, or I'm missing this link, or whatever else you might need while sessions are going on. I'm sure we'll get a lot of requests there and via email, so be patient with us as we try and get back to everybody as fast as we possibly can. A final thank you to all of our sponsors. We couldn't possibly do this without them. That's always true. It's even more true this year when we were able to thankfully use that funding to really dramatically lower the ticket price to make the conference much more accessible to anybody and everybody who wants to come. So we had unlimited sponsorships and scholarships and tickets for anyone who was unemployed or laid off this year. It's been a tough year all around. And because of that revenue, we were also able to make the live stream available free on emberconf.com to anyone. So for those of you who have tickets, please make sure that you interact with our speakers, our staff, each other in Discord. And for those of you who don't, thanks for joining us anyway. It's been an amazing last 10 years working on Ember and having all these EmberConfs, as Yehuda talked about. And I'm looking forward to the second part of the keynote, and we'll all hear what Godfrey has to say next. Thank you, everybody, so much, and have a great jam-packed day.
Hello, I'm Godfrey from the Framework Core team. Welcome to the second half of the keynote where I'll walk you through everything that happened this year and how they might affect you as an Ember developer. I'd like to begin with announcing some personnel changes to the core team. This is not the whole core team, by the way. Many years ago, we used to be able to fit everyone on one slide, but we're way past that point now. You can find a full list of Ember core team members on the website, but for now, this is what changed this year. Isaac and Jared joined the learning team, and Scott joined the Ember data team. Gnibolo, as well as Matthew from the framework core team, joined the steering committee. And meanwhile, Melanie is alumnizing from the learning team and steering committee to focus her duties on the framework team. Likewise, Tom is now a steering committee alumni but is staying on the framework core team, and Jan alumnized from the framework team to focus on the learning team responsibilities. Finally, Kratty and Alex from the CLI team, as well as Shiva Kumar from the learning team, have alumnized as well. On behalf of the community and the entire core team, I would like to extend a warm welcome to all the new team members, and a big thank you to the alumni for the continued contributions over the years. Okay, so this is all for the core team changes, and we have a lot of ground to cover today, so I'm just going to jump right in and talk about the changes in the framework. Now, as always, a lot of the work went into behind the scenes things like maintaining the framework, and this year is no exception. These bug fixes and small improvements don't usually get talked about as much as the big features, but they are no less important in maintaining a healthy framework and a productive workflow for us developers. So I'd like to take a few moments to talk about some of them briefly. The first set of changes are post-release improvements to Octane. With the wide release of Octane and more usages in the wild, there were some occasional bug reports for the new auto tracking system, especially in edge cases involving other legacy features. A decent amount of work went into debugging and fixing these issues and putting in place a better infrastructure so we can provide more helpful information when errors do occur. Also, as of the current beta, all the built-in components like link to and input have been completely rewritten using the new Octane paradigms internally. We also made a lot of improvements to the linter, to the template linter in particular. There's now a new to-do system that makes it easier to adopt new lint rules and migrate your code base gradually. A lot of the new lint rules also have auto-fixers that could apply suggestions automatically. Outside the framework itself, we also made a lot of quality of life improvements to the tools and workflows you use on a day-to-day basis. Notably, we integrated Prettier into the default stack so you can stop worrying about formatting your code and focus more on writing it and avoiding the subsequent bite shed with your team during code review. There are also some improvements to accessibility this year. The default blueprint now includes the Ember page title add-on, which encourages you to provide meaningful and descriptive title for your pages. And there's also a lang flag to the Ember new command, which explicitly sets the human language for your app's content. These changes together will help provide a better experience to users of screen readers and other assistive technologies. Finally, we also made some internal changes to the Ember source package. In the past, when you install an Ember source package from npm, what you get is essentially a pre-built file that you can run directly in the browser as a script tag all the way down to i11. With this change, the Ember source packages now just lose ES modules without being transpiled first for a particular browser. And your app is responsible for building it according to your own browser target that you have configured. There are a number of advantages to this. For one thing, even though the Ember 3.x series officially supports down to i11, most of you probably don't care for it. So by deferring the building of Ember source to your app's own build pipeline, you can skip transpiling those features like native classes if your browser targets otherwise support them natively. This can result in some wins in byte size and even some performance improvements in some cases. Another benefit is that we're now able to compile your templates differently depending on whether you're building for development or production. This allows us to leave a lot more debug information in your template without worrying about inflating your final bundle size in production. So all of these are just a few examples of what we worked on behind the scenes this year. And I would like to thank everyone who were involved in making these awesome improvements to the framework. Okay, so as much as it was a year for improvements, it was also a year of cleaning things up. Here are some of the deprecations we landed into the framework this year, and hopefully you won't actually run into that many of them in practice because a lot of them are targeting very old legacy features that are rarely used these days. Nevertheless, I won't go into too much details about them, and you can read about the deprecations on the deprecation guide. However, I would like to point out two things real quick. Number one, we have deprecated the pre-Octane configurations, also known as the Classic Edition. This means that after 4.0, all Ember apps using 4.0 and above will automatically be Octane apps, and the difference doesn't matter anymore. And second, the latest, the last batch of deprecations targeting 4.0 have landed into 3.27, which is currently in beta. If everything goes according to plan, then next release after that would be 3.28, and that release will have no more additional deprecations for 4.0. And 6 weeks after the release of 3.28, we will release version 4.0, dropping support for IE11 among other things. You'll soon hear about more of the 4.0 plans on the Ember blog soon, but that's the gist of it. Okay, so that's all for improvements and deprecations. Up next, I would like to highlight 3 major areas that we worked on over the last year. But before that, let's go back to this slide from EmberConf 2019. Here, Tom was describing how when individual features are developed and released incrementally, things might actually start to feel incoherent for a while. Over time, as more of the companion features are released, and as the documentation, tooling, and ecosystem start to catch up, then things will start to really come together. The idea of an edition is to declare that we have reached those peak moments of stability and big picture coherence, and that the features are ready for community-wide adoption. Now, with Octane release last year, we are starting to work towards the next edition called Polaris. And so naturally, we find ourselves iterating toward that pit of incoherence again, which is, again, perfectly normal. As I walk through these new features, just keep that in mind. It's not that the features themselves are particularly buggy, but you might find that, for example, the guides and the Ember Inspector are lagging behind in covering these features. And it might be a little bit harder to get answers on Discord just because of how new these features are. So with that in mind, if you and your team are not prepared to be an early adopter, that's totally okay. Just treat this part as a sneak peek into the future, and when we're ready to wrap up the next edition, I'm sure you'll hear about it from us again. But on the other hand, if you're eager to help shape the future of Ember, this is your time to shine. As the features are still being designed and experimented on, your early feedback are going to be really important in terms of influencing the direction that we're headed. And if you're looking for opportunities to contribute, then there are no shortages of things that you can help with right now. So with that out of the way, let's get to these highlights. It shouldn't be a surprise, but the first thing on my list is Embroider. By now, you've probably heard about it many times, but in case you skipped the first part of the keynote, here is a quick summary. Now, historically, the Ember build pipeline looks something like this. We take your app plus the add-ons you use plus Ember itself, run it through this custom black box, and the end result is something that you can run in the browser. Basically a script tag that you can drop in. Because the build pipeline in the middle is completely custom, and because the apps and your app and the add-ons you use can customize this build pipeline in numerous ways, over time, Ember apps became quite coupled to this particular build pipeline, and it's almost impossible to swap it out with something else. In the meantime, the wider ecosystem have converged on some de facto standards around how modern JavaScript codes should be structured and published. And a lot of modern tools have been written that play nicely with each other as long as these ecosystem conventions are followed. Now, we could duplicate these efforts and re-implement these tools and features inside our own build pipeline, but a lot of these problems are pretty low level and not particularly specific to Ember apps, and we would honestly much rather focus our energy on somewhere else that's like more core to our mission as a framework. This is where Embroider comes into play. It isn't really a single tool or as an end-to-end replacement for our build pipeline, but rather it started as a holistic rethink on how we can reorient ourselves into aligning better with the wider JavaScript ecosystem conventions so that we can let these existing tools do most of the heavy lifting for us and we can benefit from these shared efforts for free. With that in mind, Embroider is a bridge that tries to take the collection of things that make up an Ember app, but instead of building it directly for the browser, it just transformed them into the de facto standard that is understood by most of the modern tools. And from there, you can you can use any off-the-shelf tools such as Webpack to finish the job. Now, in this example, I've shown using Webpack to build for the browser, which is going to be the default when Embroider is enabled for new Ember apps. However, Embroider itself is not dependent or coupled to Webpack per se. Its job is just to build things into the standard format, and in fact, in the future, as browsers start to implement native support for these standards, like native support for loading ES modules, you might not even need that final step, and you might be able to just take that standard output and run it in the browser directly without further processing. On the other hand, you are not limited to building for the browser either, because the output of Embroider is the de facto standard JavaScript code. You can also take that and feed it into other tools that understand those conventions, such as a dependency analyzer or maybe a documentation generator. As long as they follow the same ecosystem-wide non-Ember specific conventions, it will work. Now, if you want to read more about how it actually works beyond this very high-level overview, I recommend checking out the README on the Embroider repository on GitHub. And finally, I would like to give you a rough sense of where we are at with this initiative. Over the past year, we have merged the RFC that underpins the whole project called the add-on v2 format. We have also tested Embroider compatibility layer against a number of open source and closed source Ember apps, and along the way we fixed many issues that popped up in many popular community add-ons. Starting in Ember CLI 3.27, which again currently in beta, there will be a command line flag for generating a new apps using the Embroider blueprint. At this point, we are also nearly ready to release 1.0 of the Embroider package itself. If it all goes well, we might be able to make Embroider the default for new apps starting as soon as Ember CLI 3.28, which would be the release after this one. Therefore, if you're an add-on author, this would be a really good time to add Embroider to your CI config and make sure your add-on can actually build on it without issues. You can find the instructions linked from the README that I mentioned before. And if you're eager to test building your app with Embroider, you can also find the instructions in the README as well. At this stage, the top priority is compatibility and a seamless transition, so we're likely going to stick with the more conservative, more compatible configurations. However, as more of the add-on ecosystem have adjusted to comply with the stricter settings on Embroider, you will start to see more and more benefits and better results from optimizations such as tree shaking, which remove the unused part of the dependencies from your final bundle. So in summary, I think we're pretty much ready for prime time, and it's a long time coming, and I'm really excited about the future that it unlocks for us. Okay, that's all for Embroider. And up next on my list, I have a feature called name blocks. For this, let let us look at an example scenario. Let's say you're tasked with implementing this fancy drop-down component at work. It's pretty similar to your standard HTML select element, except it supports richer HTML for the options, like you can have images and stuff inside the drop-down menu. So after staring at it for a while, this is what you came up with. All right, so let's walk through this together. First, you have a button on top that toggles opening and closing the drop-down menu, and then that's the markup for the drop-down menu itself. The component takes an add items argument, and there's a each loop to go through every item in the array. It then renders each of them inside the drop-down menu, and so that's how you get the results on the right. This is all great, the component works, but there's one problem. Currently, this drop-down component hard codes the markup for the menu items, which means that it will only work for this exact scenario, like these exact objects, and you cannot reuse this in another place where you want the menu items to look slightly different. Perhaps you want an image on the right, perhaps you want no images at all. It would be great if this drop-down component does not have any opinion on that and would be able to just render the items however you want at that particular location. Fortunately, you know exactly what to do here. Now, after this refactor, the component now takes a block. The block is called once in each iteration of the loop, and the item in question is yielded to the component, yielded to the block via block param. Instead of hardcoding how the item should be displayed inside a component, the markup now lives on the caller side inside the block. Now, the component doesn't care what the items are anymore, and you are free to display them however you want. All it does is takes care of the basic functionality of a drop-down menu and defer the rest to the caller to customize using a block. This is pretty awesome. So just when you are ready to celebrate and take an early lunch, a challenger has appeared. Turns out it was your PM. It turned out that he spotted a problem. Sometimes the list of items could be empty, in which case he wanted you to render a nice message with an explanation instead of just rendering an empty dropdown. Seems pretty reasonable, and in and of itself it's not that hard to implement. In fact, you can probably just implement it right away. You just need to add an else block to the each loop, right? That's pretty straightforward. Now the problem is though, this basically rolled back the work you did earlier to make the component reusable. You see, the component once again is hard-coded to this exact scenario thanks to the markup in that else block. If it were just a simple message, perhaps you can get away with taking it as an argument, but since this requires some non-trivial HTML, that doesn't really work. Oh well, maybe you have a better idea after lunch. Just when you're ready to take your lunch, your PM pinged you again, and it turns out he just had a meeting with another PM and he showed off your work on the dropdown. The other PM loved it, and in fact they loved it so much that they wanted to use the space above your dropdown to show an ad. That's unfortunate, but oh well. Eat first, think later. Lunch time. So yeah, you took your lunch break and you had a generous portion of mashed potatoes. If that doesn't solve your problem, then probably nothing will. Okay, back from lunch, get stash, start over. Just before the food coma kicked in, you remember hearing about name blocks at the EmberConf keynote, and the presenter told a story that was oddly similar to your situation right now. So you decided to check that out. After looking at the documentation, realized name blocks is the perfect solution to your problem. It's like they were made for this exact purpose. This is what you came up with. Let's break it down. First, you define a name block for the ad call it the banner block. And on the caller side, you can pass the name block with the colon banner syntax. It looks like a regular HTML element, except it starts with a colon. That's how you know it's a name block. Inside the dropdown component, you can yield to this name block using the same yield syntax from earlier, but with the additional 2 argument set to banner, which is the name of the block. Down below, you have the item block, which is exactly the same content as before. Just like before, the block is still being called once per item and has access to the item in question as a block param, which is provided by the component by passing it to the yield keyword. Finally, you have a third block for the empty state, so the component doesn't have to hardcode anything there as well. Just like that, you have learned to use the name blocks feature, and in summary, it's just like normal blocks. You can yield and take block params as with normal blocks, and the only difference is that now there can be multiple blocks and each identified with a unique name. So when yielding, you would also have to specify the name of the block that you're yielding to. If you're already used to how blocks work in Ember, hopefully this would feel pretty straightforward and feels like a natural extension to that paradigm. Now that we've covered the basic use cases for the feature, let me walk you through a cheat sheet for the feature. First of all, this feature is only available for angle bracket invocations. There is currently no name block syntax for curly invocations. So if you want to use name blocks, you have to use angle bracket invocation for now at least. Next, while you can pass multiple blocks in the same invocation, as we saw in the earlier example, each of them must have a unique name, so you cannot pass the same block multiple times. Also, name blocks can only appear immediately inside an angle bracket component invocation, so you cannot have a name block just chilling out at the top level. And on the other hand, if you're going to pass name blocks, you cannot also have other content inside the invocation tag. Likewise, because you can only have name blocks immediately inside a component tag, you cannot pass name blocks conditionally. However, you can make the content inside of name blocks conditional as shown on the left here. On the flip side, inside a component, you can detect whether a particular block is passed to you using the hasBlock keyword. This allows you to make a name block optional for your consumers and provide some useful default content if the block is not passed. We already saw this story earlier, but just as a regular block, your component can yield as many or as little block params to a name block as you would like. On the passing side, you can name them whatever you want, and they'll become local variables that are accessible within and only within the block. Not that you should ever write the thing on the right, but the anonymous block syntax that you're used to is actually a shorthand for the default name block. So again, there's generally no reason to do it that way, but knowing this might be useful in some tricky interop and backwards compatibility situation that you might run into. Likewise, the 2 blocks that you can pass with curly invocations is actually correspond to the default and the else name blocks. This might come into handy when there is a component that takes an else block, but you otherwise want to use the angle bracket notation to invoke it. So this allows you to do just that. And along the same lines, on the yielding side, the default yield syntax is the same as explicitly yielding to the default block. Again, there's no good reason to write it out like that, but knowing this might help you design a backwards compatible component that can be used with or without the name blocks feature. So that's all I have for the name blocks feature, and we have already started using this in a few places in our app at work, and I would certainly have designed some of our components differently if this feature were available earlier. Even though the feature is pretty simple to use, it unlocks some pretty powerful patterns for components, and I can't wait to see what the add-on community comes up with. Okay, so moving on, the third and final feature I want to highlight doesn't really have a name, so let's just call it template value semantics for now. It is definitely a more advanced set of features, so please bear with me. So here I have a hypothetical form component library and a form implemented using that library on the screen. The form component takes a block and yields a block param, which we named f. Inside the block, you have access to the form controls provided by the component using the f block param. You can invoke them like f.input, f.text area, and so on. You have probably seen something like this in an add-on before, but maybe not everyone knows exactly how that is implemented under the hood, so let's take a look at that. Now, if you open up the source code of this component's template, it will probably look something like this. The block param it yielded is actually a hash, and each item in the hash corresponds to one of the form controls that you have access to inside the form component. It uses the component helper, which allows you to refer to and look up a component in your app or your add-on by name. In this case, it's the actual definition of the f.text area component we saw earlier actually lived in a file called myform/text area. In addition to letting you refer to a component by name, the component helper also serves a second purpose, which is to allow you to pre-configure the component by pre-applying some arguments. In this case, we specified an argument called form and assigned the value to this. That means whenever someone invokes the f.text area component, it will automatically pass this extra argument to the component as if the caller had specified it in the invocation tag, even though they didn't. This pattern that we're seeing here is called contextual components, where you can use the component keyword to gather a bunch of your components, pre-configure them, and yield them out to the caller. Usually these components you're yielding aren't meant to be used standalone, and they only really make sense in a specific context. In this case, the form controls are only meant to be used inside the context of a form component, and that's why the pattern is called contextual components. And by the way, even though the pattern is usually done by grouping all the related contextual components into a hash, there's nothing intrinsically special or requires the hash keyword. You could have done the same thing by yielding the contextual components as positional block params, and as you can see, this still works without the hash keyword. However, by yielding the component one by one, the caller would have to remember to bind all the block params in that exact order that you yielded them. That's why usually it's better to yield a single object that has everything in there keyed by the appropriate names. Still, the hash keyword here is not special or required. You could have made a POJO in JavaScript and yielded that out instead, and it would work all the same. Okay, so since we just talked about name blocks, you might notice that there are some superficial similarities between name blocks and contextual components. In fact, because we didn't have name blocks in the past, until very recently at least, some of the roles that would have otherwise been more naturally filled by name blocks were sometimes historically implemented using contextual components because we don't have anything else. However, now that we have both, they actually serve pretty different purposes, and it's not like one is replacing the other. On the one hand, when using a name block design, the component author has total control. You can decide exactly when to call which of the blocks, and you can call block 0 times, 20 times, completely up to you. You can choose to pass additional data to the block in the form of block params, and on the other hand, when using a contextual component pattern, you are giving the control to the caller of the component instead. You can yield as many contextual components as you like, but there's no guarantee that the caller will call them at all or in any particular order. So, and also instead of you passing data to the caller will be passing data to your components instead by passing arguments. In other words, the difference is I call you versus you call me. And in the drop-down example, there can only be one banner, for instance, and it has to appear exactly at the top of the drop-down menu, so it wouldn't really make sense for that to be contextual components, because otherwise you can call it in any place, you can call it many times, that wouldn't make any sense. On the other hand, in the form example, you want the consumer to be able to design your form by mixing and matching your form controls arbitrarily in any order or combination. So the contextual component approach makes total sense there. Okay, so even though it's pretty advanced, contextual components are actually a pretty old feature of Ember dating back to Ember 2.3. So why are we talking about this right now? Well, until now, you can only have contextual components, but as of 3.27, which again is currently in beta, you can also have contextual helpers and modifiers, thanks to the new modifier and helper keywords. This works exactly the same way as the component keyword by taking the name of the modifier or the helper as a string and returning a value representing that modifier or helper. As with components, the most common thing you want to do with it is probably to yield them out in a contextual fashion. But because it's just a regular value, you can actually do whatever you want with it. You can, for example, pass it to another component as an argument if the component accepts a helper or modifier for one of its arguments. And just like the component keyword, you can use the modifier and the helper keyword to pre-configure things by pre-applying certain arguments to them. These arguments will then be baked into the value returned by the keyword so that when someone tries to invoke it later, the modifier or the helper will automatically receive those extra arguments as if the caller had provided them. Again, this works exactly the same way as the component keyword. On the other hand, this is what it will look like to invoke one of these values, very similar to the example before. Now, this feature opens up the possibility for a completely new category of component composition patterns. For example, in the hypothetical form library, we can yield an auto-resize modifier that you can attach to any of the text input and have them automatically grow and shrink as the user types in them. It can also yield a collection of helpers for declaring validation rules right inside the form template instead of having to do it in JavaScript. And yeah, contextual components are probably one of the most powerful template features in Ember. And when it became available, it opened the floodgate of a lot of interesting component designs. And I'm hoping that this will be the same. And again, I'm really looking forward to seeing how you put this feature to use. Okay, so that's pretty exciting, but that's not it. In addition to the keywords to create a value referencing a component, a modifier, or a helper, we also overhauled the rendering engine to accept them as values in a lot more places than it used to. For example, here we imported a component, a modifier, and a helper from an add-on, and we assigned them as class fields. This allows us to access these imported values from within the template, and if we tried to invoke them, this didn't used to work, but now it does. Everything just works as you would expect. Again, all you did was importing a component or a helper or a modifier, and if you have access to them in the template somehow, then you can invoke them all the same. As you can see, in this case, you don't even need the component keyword anymore, or the helper keyword or the modifier keyword. Of course, you can still choose to use those keywords to attach additional arguments to your imported values if that's what you want to do. This works exactly as you would expect as well. That opens up some pretty interesting possibilities. For example, you can define a helper function in the module scope of a component JavaScript file, attach it to a class field, and that allows you to create a truly private one-off helper specific to this component without having to registering it and leaking it into the global namespace. You can even dynamically create one-off modifiers that capture tracked instance state inside a getter, and as always, the getter will be automatically rerun and therefore returning a new modifier, replacing the old one whenever any of the track state changes. These patterns are pretty powerful, and I think they will open up a lot more use cases that are previously either very cumbersome or even impossible. I know I've said this a bunch already, but I'm really looking forward to seeing what the next generation of Ember add-ons will look like. Before we close off on this topic, there's an elephant in the room that I need to address. Going back to this example that we saw earlier, it's pretty cool that you can do this, I guess, but having to import the values into JavaScript and then make a class and then assign them to fields just so you can have access to them inside a template, that feels like a lot of boilerplate. Especially when you otherwise wouldn't have needed a JavaScript class, and like if you would have been able to get away with a template-only component, this seems like a lot of work. Wouldn't it be great if you can just import those values and use them in the template directly? Well, good news, template imports allow you to do just that. And it's exactly the direction that we're iterating towards. This example doesn't work yet, and this is probably not going to be the exact syntax that you would type in its final form anyway, but it's a good enough stand-in to show the direction that we're headed towards. The idea is that you would have to import everything that you use in the template just like you would in JavaScript, instead of having everything magically become available in the global scope. While this adds a little bit of a boilerplate, it makes it a lot easier and a lot clearer where your components, modifiers, and helpers are actually coming from. Not only would that help humans navigate an unfamiliar Ember code base, it will also make it easier for VS Code and other IDEs to provide tools like autocomplete, jump to definition, that kind of stuff. Plus, it will also help Embroider to see what you're actually using and not using in your app, so it can remove any unneeded code from your final bundle in the tree shaking step. The design for template import syntax haven't been finalized yet, so that's why the feature have not been implemented yet. However, we're doing things a little bit differently this time. Instead of waiting to finalize the user level syntax, we designed and implemented the underlying low-level primitive that is needed to provide the functionality. That primitive have already landed in recent versions of Ember, so thanks to that, we are currently able to experiment with different syntax ideas in an add-on called Ember Template Imports. If your app is running on Ember 3.25 or above, you can install the add-on today and start getting a feel of what the future would look like or feel like. One of the current design exploration is to see if we can find a good syntax for embedding the template into JavaScript files directly. And the template would have access to any values that are available in the outer JavaScript scope. This would make it much easier to do the one-off private helpers kind of thing that I showed earlier, but there are still a lot of open questions to answer. Would this be ergonomic? Is this going to feel awkward? Is it possible to get good syntax highlighting and editor support? And what should the file extension be for this kind of hybrid files? These questions would have been quite difficult to answer without being able to experiment with the feature hands-on. And thankfully, the experimental add-on allows us to do just that. As I said in the beginning, we are approaching the pit of incoherence. A lot of things are still in flux, but that also means that right now you have a lot of influence on how these things shapes up in the next edition. So if you want to hear more about template imports, there was a bonus conf talk on that topic yesterday, which should be available on YouTube soon. Follow the EmberConf Twitter account so you won't miss it. Okay. So that was it for the highlights, and before we wrap up, here are some of the new primitives that we have landed in the past year. Because these are primitives, you're not expected to have to know about them, and it's unlikely that you will use them in your app directly, so I'm not going to go through them. However, if you're an add-on author or an experimenter, these are the RFCs to read. For instance, RFC number 496, strict mode templates, is the underlying primitive that was used by the template imports experimental add-on that I showed earlier. So with that said, we also made some process changes this year. Let's see. RFC 627, for instance, revamped the RFC process itself with the goals of making the process more agile. 649 aims to make the deprecation rollout process more gradual and incremental. 685 defined the browser support policy for Ember 4.0 onwards, notably dropping IE 11. The polyfills and the code mods are also now more of an official part of our process. We have centralized GitHub orgs for each, and we strive to provide them like for any new features and deprecations that we release whenever possible. The accessibility track team also graduated into the accessibility working group, which is a more like, and they have a more permanent mandate. You can thank them for spearheading the accessibility efforts, such as the page title and length flag that I mentioned in the beginning, and they have more work in flight, so stay tuned for that. And meanwhile, we have also formed a TypeScript Strike team to shepherd the effort of official TypeScript support. Right now, you can already use TypeScript with Ember, and it works pretty great. We use it at work. It's perfect. It's great. The community did a really good job supporting that effort. But by making this more official, we hope to provide a more seamless and more stable experience for all the TypeScript users that along the same lines that you would come to expect with the Ember project. Finally, with things like template imports on the horizon, we would need to ramp up our tooling effort. And to that end, there's a new Dev Ember tooling channel on Discord. If you're excited about template imports, for instance, and want to help build a polished developer experience, that would be a great place to start. Finally, that brings us to my last point. From testing out Embroider, trying out Polaris features, and providing early feedback for all of these, helping build the tooling support for template imports, to filing bug reports and answering questions on Discord, I hope I have inspired you to find some avenue to get involved in the community. And hopefully we'll be able to meet in person again soon enough. But until then, enjoy your virtual EmberConf experience and see you on Discord. Thank you.
Hey everyone, my name is Max Fierke. I'm one of the maintainers of Ember concurrency. One of the bright notes in 2020 is that we were able to ship version 2.0, and we're looking forward to building on that and doing more with structured concurrency in Ember in 2021.
Hi, I'm Jen Weber. I'm a senior software engineer at a nonprofit called ActBlue Technical Services. I'm also a member of the Ember Learning Core team. Today, I'd like to tell you a little bit about why I think HTML first apps are the future and how that should impact your day-to-day work. You're going to get a short history lesson about how HTML came to be. Together, we'll critique some Ember templates as if we're doing a little mini PR review. You'll learn some useful patterns in Ember apps. We'll learn how to critique other frameworks and how they treat HTML, and we'll talk about what the future holds. I'd like to invite you to think for a moment about your own history of using HTML. What was the first HTML that you ever tried to write or edit? What was the feeling that that gave you? My first HTML was trying to edit a Tumblr theme. I was in my first year of college. Some other friends of mine had Tumblrs, and I noticed that their themes had this thing called a following list or a blog roll. I really wanted to add it to my app. I copied and pasted some things from another template, adjusted some styles, and it had become my own. Now, anyone who followed me could find even more angsty teenager poetry and essays. I asked around on Twitter a couple weeks back to see what other people's first HTML was, and a theme emerged. Abby Milberg says it was Neopets, followed momentarily by GeoCities. Both were resplendent with marquee and blink tags. Brian, aka, had an Angel Fire website with their stepbrother, where they'd write weekly stories in chapters together. Edward Faulkner, EAF4, says, my Eagle Scout project was making web pages for local nonprofits and teaching other scouts how to do this. The hardest part was convincing people that they wanted a web page in 1997. T.S. McDonald made a fan site for the TI-86 graphing calculator, which they made when they were 10 for extra credit in math class. Many people built something with an emphasis on community, something that linked them together. HTML is a great tool for bringing people together and building successful businesses. But HTML is more than you think. HTML is the key to building apps for devices that I have never seen or cannot even imagine. Back when people were building apps on GeoCities, I didn't know that I'd be looking at the web on my phone today. As I was researching this talk, I looked at websites from the 1990s using my laptop and phone. The authors didn't build with my use case in mind, but their sites worked. Maybe the apps you build today will be shown on a watch, a touch screen as big as a wall, a heads-up display of some smart glasses. Maybe I'll ask a voice assistant to help me use what you have built. Are you ready for that? I think we're going to need a lot more than a bunch of nested divs in order to get there. If we think about the future, how does it change the way that we build apps today? For inspiration and understanding, let's look at the history of HTML to see what we can learn about how the early visionaries successfully built for today's world. For this part of the talk, I had to do a lot of new research. I became a web developer about 5 years ago, and I knew almost nothing about how the web came to be. My favorite article that I found comes from w3.org. It was written in 1998 by Addison Wesley Longman, and what I love about it is that this article has a little bit of attitude. It gave me a sense of just how much sharing, communication, debate, and conflict went into the tools that we use today. Let's start in the 1940s. The idea of annotating text into The idea of annotating text to indicate its layout into paragraphs and headings has been around for a really long time. It was well established in academia in the 1940s. The 1980s brought ways to link files on a computer's own file system, but a computer on the other side of the world was still out of the question. In 1989, Tim Berners-Lee wrote the first proposal for the World Wide Web. Berners-Lee, a researcher at the European Organization for Nuclear Research, had worked out how to make files available globally. They needed to be transmitted of hypertext links. 1990 was the year of the first website and web server running on a computer at Berners-Lee's lab. This is the URL of that first web page. In June of 1993, the first formal proposal was published with a minimal set of tags. Many of the things that I use daily were not in there. No inputs, no buttons, not even span. It was more about lists, headings, and paragraphs. Along the way, other computer scientists and researchers started to take notice and come up with their own renditions and opinions. For example, Dave Raggett studied printed media like newspapers and magazines in order to compose a richer set of tags, which he called HTML+. A proposal for HTML+ was published later in 1993, and that proposal included things such as inputs and tables. A lot of the work that was done done in the open. This was cool because a lot of people could follow along and participate, but some things also got kind of sticky. Design and discussion passed through many, many different groups. We talk a lot about individual inventors such as Tim Berners-Lee, but you can see from this list just how many people must have been involved. These committees and working groups rose and fall. They changed and evolved over time. As the web grew in popularity, so did the communication burdens and the debates. Longman writes, "The HTML working group was an excellent idea in theory, but in practice, things did not go quite as expected. The group was notably slow in coming to a consensus on a given HTML feature, and commercial organizations were hardly going to sit around having tea, pleasantly conversing on the weather whilst waiting for the results of debates, and they did not." Following this, business pressures pushed browser vendors to create their own smaller structured groups with an interest in speed, getting things done quickly. In the early 2000s, this became known as the browser wars as vendors battled for the attention of users. Some interesting facts that I learned along the way while researching this: the Internet Engineering Task Force had a theme song, and it's about as good as your high school's alma mater. HTML ERB is the name of the group that killed the marquee and blink tags. This was part of a negotiation between browser vendors. Netscape would only agree to let go of Blink if Microsoft would give up Marquee. I also learned about computer scientists like Dr. T.V. Raman, who helped to make sure that HTML could be used in other ways than just viewing it on a screen. Raman is the inventor of Emacspeak, which is a free text-to-speech tool released in 1995. Raman was part of early HTML discussions, helping to make sure that the web was accessible to people who were blind or had partial sight, such as him. In more recent history, 2004 saw the beginning of the Web Hypertext Application Technology Working Group, or WHATWG. In 2011, WHATWG announced that there would be a living standard for the HTML5 specification. A living standard is something that's improved over time and never complete. New features can be added, but functionality was not going to be removed. In 2014, HTML5 became recommended. It included many new semantic tags such as navs, headers, form controls for emails, dates, and times. In 2019, we saw an end to competing standards that had occurred between W3 and WHATWG. Now, today, WHATWG is the main authority on what HTML5 specification is. Today, HTML is about iteration. There are no plans for an HTML6. Tim Berners-Lee is the director of the World Wide Web Consortium, aka W3C. Dr. T.V. Raman is working on voice interfaces for Google. A lot of his research and philosophy focuses on the idea that information on the web should be agnostic about the way that it is presented. Browser vendors are not totally in harmony. The work of creating, maintaining, and implementing web standards continues every day. Browsers are creating their own proprietary APIs, and that continues to be a source of conflict, risk, and innovation. Overall, HTML is the result of millions of hours of debate, design, research, and implementation work by thousands and thousands of people. It also includes billions of hours of user experience that informed its current shape. The considerations that went into it are more numerous than any one of us could know. Every single tag has a purpose, and it's connected to the browser features that we may never see. For example, on the W3 website, there's this totally massive table that shows how semantic HTML elements such as nav and button map to different roles and features in the browser. You can check this table out by looking for the accessibility API mappings on w3.org. This mapping is what makes up our daily experience of the web. Things like when your password manager fills in your login information, being able to press to paste on mobile browsers, it gives you keyboard navigation of forms, and it provides cutting-edge capabilities to cutting-edge critical accessibility technology and assistive technology such as screen readers. These features and their connections are more than any of us could learn, but you get it for free when you use semantic HTML correctly. Semantic HTML is a way to automatically get all of the roles and mappings that make these features possible. When everything is divs, you miss out on some of the most powerful programming tools in history. Semantic HTML goes far beyond what your template markup looks like. This is something that I wish I knew at the start of my career, because so much of what we talk about as best practices for the web make a lot more sense in this context. Today, I understand that semantic HTML needs to be part of my areas of expertise so that I can help other developers close their own knowledge gap. We can make apps that work for everyone, including our future selves. So we've talked a lot about HTML, but I don't know about you, most of my work doesn't take place directly in HTML files. So it's time to talk about where single page apps fit into this story. When single page apps came on the scene, I'm talking about frameworks such as jQuery, Ember, React, Angular, Vue, all of these, they faced some unique challenges. In a purely HTML-based app, every time you went to a new URL, the whole page was refreshing, and a lot of other technologies were relying on that behavior. An example is URL history, so that you could do things like click the back button. Another is search engine optimization. Crawlers for like search engines such as Google assumed that the DOM had all of its content ready right when it was reading the page, whereas we know that a lot of our content today is populated through JavaScript code. There were also issues with accessibility, since you weren't changing the URL, since you weren't refreshing the whole page, screen readers didn't know that the context has changed. There's fixes that have been in place for all of these different issues. Today in browsers, we have things like push state and replace state that help with managing the URL history. The crawlers that are being used have evolved, and in cases of the frameworks themselves, we have tools that help with pre-rendering and provide that pre-rendered content to the search engines so that you don't have to choose between having good search and having a really snappy user experience. And then lastly, with accessibility, in the Ember community and in other developer communities, there are tools for helping to manage your routing transitions through the app and make them available to people who are browsing the web in different ways. So what does it mean to put HTML first? It means that whenever we're working on apps, we want to write valid semantic HTML by default. We want to follow HTML-like patterns in non-HTML so that there's not as many new things to learn. We want to emphasize readability of templates over their dryness. Dry stands for don't repeat yourself. I've also been introduced to an acronym called DAMP, which is Descriptive and Meaningful Phrases. DAMP places an emphasis on being able to quickly skim code or markup with the idea in mind that we spend most of our time reading code as opposed to writing it. And then lastly, it means to test for mistakes in your HTML. These are things that you can do as an individual developer, but they're also things that can come as part of the features of the framework that you've chosen to use. When you choose to build an app with Ember, you get some benefits of an HTML first approach with little or no work and prior research needed by you. In this next section, I'm going to show you how things used to be done in some older versions of Ember and compare with how they look in Ember Octane. Things are continually evolving and improving, and this is the best way for you to be able to see it. In older versions of Ember, when you generated a route, you would get something like this, which has an outlet in it. Today, when you generate a new route, when you're using Ember Octane, it comes with this page title helper. The page title is an important part of accessibility and SEO. This is the title that's used in things like up at the top on your browser when you see the name of the page in your tabs. It's used in the search engine results. It's used for helping people know where they are as they're navigating through your app. In older Ember, we used to show things like input examples all by themselves. This isn't valid HTML because every input needs to have a label. In today's docs, we show more full-fledged examples that include labels. This is something that It will hopefully help others fill in their gaps of knowledge, and it matches more what we see in real world apps. In older versions of Ember, there was this thing called the application wrapper. It's an optional thing that you can still have present in today's apps, but when you generate new apps, it's not there anymore. What the application wrapper did was it put a div just inside the body. This had some problems because some landmark roles such as header, main, footer work best when they are direct descendants inside of the body, not wrapped one layer deeper in a div. So today, if you generate a fresh app using the latest version of Ember, you won't see that wrapper anymore. In older Ember, we used curly braces around components. This worked well, but it isn't necessarily following some of the same patterns that we see in HTML. Namely, it was difficult to tell whether what you were looking at was a helper or if it was something that was going to render new HTML elements. Today, when we look at Ember templates, they look an awful lot more like HTML, and some of the features of the components that you use in Octane are more closely aligned with HTML attributes and properties. So, armed with this knowledge, what can we do to review our own code and make improvements to it? I'm going to show you a few different code samples. And as you're looking at them, I want you to think about what could be improved, but also how you would communicate those improvements to somebody else in a way that is empathetic and about sharing knowledge instead of blame. Some of the things you can look for are whether the template uses semantic HTML, if those semantics are readable so that they can be easily maintained. We want to know that our template linters are passing. We want to have accessibility tests and see those pass as well. And we want to write our apps in a way that makes room for non-JavaScript developers. So, for example, if a CSS specialist joins a team, is it possible for them to work within an Ember app without learning all of the ins and outs of Ember? Could they be productive on day one? That's a question to ask yourself whenever you're looking at these templates. All right, so take a look at this example and think about what could be improved. If you'd like, you could, and you're watching this video later, you could pause it and study it for a little bit. The main issue with this component is that it's attaching a click action on something that isn't supposed to be clickable. It's attaching it to a div, not a button. The problem with this is that by using a div instead of the semantic button, we've lost a whole bunch of automatic behavior, such as being able to tab to this and interact with it by keyboard, to press enter and have it click the button for us. So to fix this, turn it into a button. In an Ember app, your linter should tell you that something is wrong here. So I use VS Code. I have the language server installed, and when I do that, I get this little squiggly line that warns me, hey, you're making a mistake here. I can also run my linter from the command line, and it's all there installed for me from the moment that I first create my app. All right, what's wrong with this example? This example works, but it has a little bit of a problem with understandability. Someone needs to know a little bit about JavaScript and Ember in order to understand what text is going to be rendered here when. Is it going to say save? Is it going to say cancel? And furthermore, this pattern of using modes, it's not so bad if you have just one mode or two, but they can start to proliferate, and the result can be that your templates grow in complexity to a point where it's hard to read and know what the actual HTML output is going to be. So this could be improved by passing in the text using a block style component instead, or maybe breaking this out into two different components. This example has some similar issues as the previous in that it is a bit difficult to read. The let helper can be something that greatly improves your readability of your templates, but it can also be something that adds complexity. Additionally, anytime you're adding things, classes to your components, in such a way that you can't just search the project to find where those class names are used, you might be in trouble. This also is a barrier for anyone who's come to work just on the CSS of an app. This component might be a little bit brittle because they might search for something like example-button, not see that text anywhere in the app except for in the CSS, and think that that rule is okay to remove. I also want to mention date pickers really quickly. A lot of them have major challenges with accessibility. Semantic HTML, the inputs provide a way for us to add choose dates and times with more of a guarantee that it's going to work across all devices, that it's going to work for lots of different types of users, and things like assistive technology. So consider replacing custom date pickers with native date pickers. So next, let's review some other stuff. Let's take a quick look at how we could evaluate other tools in the wider JavaScript community for what they're doing well or not when it comes to an HTML first approach. And again, keep in mind, how would you communicate this in a way that is constructive and helpful and uplifting? In the open source communities, people put a lot of effort into these types of tools, and it's kind of up to all of us to share and grow together. So some things to look for in any framework that you're evaluating. Are they using semantic HTML in their examples? Is the markup that developers write readable? Are there things such as template linters that help you catch problems like the one that we just saw a little bit ago with the click action? Are there accessibility testing tools? How much work is it to put them in place? How much needs to be custom in order for you to have some additional assurance that you're building the right thing? And then lastly, does that framework make room for non-JavaScript developers to participate in the experience, as well as I like to think of people who are just learning how to be web developers. There's a lot to learn, and a smaller overhead can make a big difference. So this is an example from React. We saw earlier that you can write the same sort of thing in Ember, and clicking on that div would work. But we know that that's not great for accessibility. We know that that's not great for keyboard controls. And the difference here is that if I use a tool such as Create React App, there's nothing here that warns me that I've made this mistake. Another major issue can be readability. So this is, again, an example from React, and experienced React developers would tell you that there's a lot of ways to clean this up, to make it easier to maintain, to prevent having a whole bunch of Git conflicts if people are working in the same file. But again, it's something that you can do, whereas it's a little bit difficult to create a similar sort of complexity using Ember templates. So why is HTML first the future? I don't know everything about what users need even right now. When I'm working on my computer, it's really different than what everybody else is going to be using my app on. Our technological future must be creative, inclusive, and empathetic. And using semantic HTML is the easiest way to be ready for whatever that future holds. You can find some more examples of how semantic HTML is an important part of Ember and how you can build it into your own development process by going to my GitHub repo at jenweber/HTML first demos. You can also find a link to my slides, which has all of my sources for today's talk. Special thanks to Yehuda Katz, Melanie Sumner, Edward Faulkner, and Chris Manson for educating me on a lot of these topics. I'd also like to thank everyone who worked to bring these amazing features to life in Ember, especially Robert Jackson and the people who contributed to the Ember template linting project. Thanks so much for watching.
Hello, Ember Conference. My name is Clark, and I'm a technical recruiter here at LinkedIn. I wanted to quickly pitch some of the front-end roles that we have available, and there are lots of them. If you want to use Ember and create economic opportunity for every member of the global workforce, LinkedIn is the place to be. We need people like you to make the site more delightful, secure, performant, and accessible to our more than 750 million members. We currently have openings across all levels and business lines, and we would love to have you join us. Please reach out to me, Clark Fox, on LinkedIn to have a chat. I look forward to talking to you. All right, bye.
Before we start, I have a question. Do you like road trips? I hope the answer is yes. If you do, what do you think makes a road trip successful? While you're thinking about it, let me invite you to take a journey with me. Along the way, we'll make a few stops to check if our foundation is well equipped for the adventure. We'll wake up in Moscow, speak different languages, sandboard in Colorado, and drive through a pandemic. All that to find an answer to the question, what does it really take to launch an enterprise product at scale during the COVID-19 pandemic? Here's our destination. We are building, from scratch, enterprise sales software for LinkedIn, a place where sales leaders can uncover new opportunities and develop a better sales strategy by leveraging the LinkedIn economic graph, the digital representation of the global economy. We'll welcome our users with a single sign-on and offer multiple licenses as a starter. Our main Ember UI menu will include external dependencies, multidimensional taxonomies, custom personas, interactive charts, and so much more. But this is where we start. 2019, the year I joined LinkedIn. Back then we had a massive UI team, 2 UI engineers, and I was the second one. No, I had no prior Ember experience. There's one thing you should know about me. I'm addicted to adventures. While working in tech for more than 8 years, I tried on different hats, worked in both the front and backyards of engineering. I already invaded worlds of video games, ads, car racing, freight shipping, investment, and cryptocurrency. So growing a complex enterprise product on unknown to me Ember soil was an adventure I couldn't miss. I knew it would involve new challenges, and I was right. Let's take a closer look. Like any other product, we have must-haves like graceful degradation, A/B testing, etc. But on top of that, we need to account for enterprise-specific processes and challenges that come with scale. Every feature we build has to consider multiple microservices, external dependencies, sign-offs from other teams, etc. All that combined makes the final list of requirements quite overwhelming. And you're probably thinking, that's why enterprise development is slow. I know, I've heard this many times. And while it is true that we can't afford to move fast and break things, we can't afford inaction either. That's why our approach follows the core principle of stability without stagnation. As a team, we decided to invest heavily in the foundation, automate and reuse as much as we can. As brilliant as this sounds, the implementation of this principle wasn't always straightforward. It wasn't a straight line nor a curve. For me, it was a journey. The journey through two intertwined roads, personal and professional, where lessons from one echoed into the other. Maybe they aren't so different after all. Let's find out this by driving to our first checkpoint, St. Petersburg. My friend and I planned a trip to Moscow. We discussed the plan, agreed on the dates. But out of sudden, he showed up a week early, wondering why I still wasn't ready. Shocked, I quickly packed my bag, and 1 hour later, we were on our way to Moscow. It ended up to be a very fun trip, although later he confessed that it was a prank that turned into a real adventure only because I accepted it. I wish all unexpected changes to our plans ended so well. Unfortunately, that's not the case, especially in the world of UI and API agreements. How it usually happens. The UI and API team sign an API contract by defining a schema. UI kickoffs local development using mocked endpoints in Ember CLI Mirage. Then API developer introduces some changes. UI engineering might be not aware of these updates, so they continue to build the UI with outdated assumptions. The discrepancy can cause bad regressions. This problem is what makes validation one of the crucial components of client-server interaction. Our solution to this problem isn't open source, but I'll explain the overall idea that you can apply to your own Mirage setup in Ember. Let's look at the schema. In green are the typical components of Mirage workflow. The key difference is in serialization process. Each mocked endpoint is mapped to a corresponding API schema. Schemas are treated as dependency packages. To upgrade API version of your local mocks, you just need to change the package version. Then custom Mirage serializer comes into play. It takes those schemas from your repo, validates each requested query param, and generates mock data, but only for the fields defined in that schema. If you try to trick the system by introducing custom fields in Mirage Factory, it will throw an error. This solution proved to be effective in surfacing missing required properties, declining outdated request params, and preventing any schema pranks. Now let's jump back to our engineering car. We are going to Colorado to perform our first accessibility audit. I promise no more secrets. All the other technologies I'll be mentioning are open source. Sand Dunes National Park, sandboarding paradise. I always loved the idea of sandboarding. I heard it was similar to snowboarding, so I got excited and went all in without any further research. Long story short, it was a disaster. Unlike snow, sand demands waxing every few meters. Instead of shredding the sand, I spent the most of my time waxing the board and blaming myself for not doing proper research. Coincidentally, that was also the time where our first accessibility audit was taking place. One thing to keep in mind, accessibility support isn't the choice for us, it's a must-have requirement. However, since our product wasn't released globally yet and we had other priorities, by the time we performed our first accessibility audit, we already had an impressive amount of features. Still, I wasn't too concerned about it. On the contrary, it was a new experience and I was excited about accessibility audit process in general. So here I am, exhausted after a long day in dunes, looking at the result of the accessibility audit. 100. The team reported close to 100 issues. I experienced the backslash. For the second time a day, the universe was telling me that unrealistic optimism can be very painful. 30% of those issues could have been easily avoided. How? by leveraging Ember accessibility testing. It's easy to adopt and straightforward to use. Built on top of Xcore, it gives you access to all the rules and options. My personal favorite bonus of this library are error messages. Not only do they tell you what went wrong, but also why it went wrong and how to fix the problem. So don't neglect easy wins. Please do your research before shredding the sand. My next story is about dangerous regressions. Once upon a time, I decided to try work and travel program. Our goal was to build a floating staircase. Yes, we did it, but that's not what this story is about. It's about how the entire innovation project has started. Apparently, the owner of this house didn't like one of the walls in his living room, so he removed it. Yeah, that was a load-bearing wall, so he put the entire construction of the house at risk. Coming back to our UI world, we can consider page markup as one of the load-bearing walls of front-end construction. Uncontrolled CSS changes aren't threatening web existence, but can easily damage visual integrity and endanger overall user experience. In projects like ours, with hundreds of components, the only way to prevent visual regressions is to use automated testing. After evaluating existing solutions like Percy and Phantom, we adopted Ember Backstop. It's a visual test helper that generates and compares screenshots with a reference from baseline commit. You'll also need to consider other aspects like freezing mock data, but let's save these topics for the future. What we'll focus instead is how can we leverage the same exact setup for localization. As of now, we support 7 languages. Localization is a multi-step process that involves collaboration between multiple teams. Verification is one of the steps. We need to ensure that all our components look as intended in all supported languages. How can we do that? Screenshots. Indeed, if you can generate screenshots for one language, why can't you do it for another 6? By triggering your test for different language, you can use the same exact backstop assertions, but in reference-only mode. The result? One tool that covers 2 requirements. Okay, that was a lot of information. Let's make a pit stop. We established trust in client-server communication and performed accessibility audit. Introduced visual regression and localization. On the background, our team covered all other requirements and even addressed accessibility bugs. By investing in strong tech foundation, automation, and creativity, we achieved stability without stagnation. Our team was moving full speed, preparing for global launch. Then the world turned upside down. Along with drastic changes that came to our day-to-day lives with remote work, we started seeing decline in engagement from customers. Roadmap items no longer seemed relevant. A third of our engineering bandwidth was borrowed by another team. The launch was postponed. All that endangered our team culture, which we cherish a lot. Our PMs tirelessly worked on uplifting team morale. We had virtual happy hours, watched zombie movies, cooked meatballs, played trivia, and even cross-stitched. Nonetheless, life wasn't the same. Day by day, I was submitting less and less code. Bugs started crawling over from all over, and I fell into self-blame trap and developed impostor syndrome. Longer working hours didn't help. Hiking, running, even closed Apple rings, nothing was working. And then I asked myself, in the engineering world, what do we usually do when we hit barriers in development? Right, we apply problem-solving strategies, one of which is root cause analysis. So I cleared my whiteboard and started brainstorming. List of problems and never-ending chain of why questions uncovered that even though I used the right tools, I was fighting side effects, ignoring the core issue. Denial. I denied importance of the crisis, tried to prove that we can recreate almost anything, as long as we have enough of willpower and perseverance. This is an airstream from Mill Valley, 4 miles away from my apartment. At that time, campings were closed, so I rented it to recreate camping experience. But even with the wildest imagination, that airstream couldn't leave the backyard, and no, it wasn't camping. A few days later, I came back disappointed. It's still an original and unique experience, you might think. And you are absolutely right. You see, I couldn't appreciate that airstream for what it was, because I had an inadequate set of expectations, because I was applying the right tools to the wrong problem. The same way I was boosting my work performance while ignoring the most important questions. Did I still want to invest my life in this product, knowing it might never be released? What was my definition of a successful journey? To answer these questions, I came back to my fundamental engineering values. I love using technology as a tool for solving challenging real-life problems with like-minded people who share the same passion. So for me, success was an intersection of those 3 pillars. And I had all 3 of them. No, I couldn't guarantee a prosperous future for our product, but I knew what I could do to increase the chances. Investing in resilient technical foundation, contributing to integrity of our team culture, and putting our members first. This realization helped me to reestablish my engineering purpose. Luckily for us, soon after that, we started seeing the rise of virtual selling. Increased demand in high-quality data and insights put our product at spotlight for many prospect customers. We entered a new life cycle, doubled down on our roadmap. We had to act fast. And that is where our previous investment in foundation, localization tools, accessibility testing, etc. really paid off. Last month, we launched Sales Insight globally. Wow, what an adventure we had here. Thank you for trusting me as the driver, and thank you for sharing your precious time with me. I wish you all to have many, many insightful journeys. Cheers.
Hi, my name is Kiki. I'm a software developer from Nairobi, Kenya at Tunapanda, and I want to introduce our Ember project, WeConnect. How would you like us to proceed? WeConnect seeks to bridge the digital divide. At Tunapanda, we think that learning's cool. We're running training programs and building learning tools so you can teach, build, or even stop and learn. Welcome to a community. We invite you with open arms. The Ember way, 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 the Ember way.
It's time to take a break for lunch. If you haven't yet had a chance, be sure to join the discussion on the Ember Discord server and check out the companion app at meet.ps/EmberConf. Bonus points to whoever posts a photo showcasing their favorite Ember swag. Welcome back from lunch, everyone. Every year, the speakers are sent a short survey with fun questions. This year, one of the questions was, what advice would you give yourself as a developer starting with Ember? And the answers were remarkably similar. The top response across all speakers was, join the community and don't be afraid to ask questions. Also, and I quote, don't believe anyone who says that controllers are dead.
Hello everyone and welcome. I hope you're enjoying EmberConf so far, and thank you for joining me today. We're going to be talking about how you can build a Pinterest-like masonry layout using technologies such as modifiers and CSS Grid. But first, a quick introduction. My name is Jordan Hawker. I am the staff front-end engineer at LinkedIn and tech lead for developer experience within my organization. This is my dog Cooper. He's an Australian cattle dog. He's 5 years old and I love him dearly. And he's going to be helping us out with our talk today, so keep an eye out. He might be playing a little peekaboo today. Now, I work for the LinkedIn Talent Solutions UI infrastructure team, and we enable our teams to ship applications faster with enterprise-grade quality by providing them with the tools they need to work more efficiently and productively. We support 3 Ember applications and nearly 60 internal add-ons, and we're focused on a number of areas, including application platform, developer experience, testing infrastructure, and operational excellence. Now, let's talk a little bit about masonry layouts, which you may know as the Pinterest layout. Now, a masonry layout is similar to a strict grid layout, where one axis does have that very strict grid setup, but the other axis, the masonry axis, eliminates any space between items, so instead of sticking to that strict grid. Usually this is vertical space so that you have that nice layout where no matter how tall each item is, the next item below it is going to come up right underneath it without any major gaps. Now, why did I care about solving this particular problem? Well, last year I was working on a side project where I wanted to build a sort of vintage newspaper layout. So I wanted a multi-column layout where these articles would finish at any unknown length, and then the next article would begin below it right where the article finished. So in any given column, as articles had different lengths, I wouldn't necessarily know where that article would end and where the next one would begin. So I started exploring ways to build this sort of masonry layout to eliminate the gaps between articles and have this nice newspaper look to it. So let's think about how we might implement a masonry layout. Many of you may know about the Masonry JavaScript library found on GitHub at Desandro/Masonry. It was first released in 2010, and it's one of the most popular JavaScript solutions for masonry layouts today. In fact, it has over 400,000 downloads a month on NPM, and part of its popularity came from a strong integration with jQuery over the last 10 years. However, the library itself is 2,500 lines of code unminified, whereas the solution I'm going to show you today takes less than 150 lines of code to implement in Ember. Additionally, the Masonry JS library was last released in 2018, so it hasn't received any modern updates to its implementation. Now, let's look at a website called christianhammerstad.com, which uses the Masonry JS library to implement a grid layout. Now, as you can see from this recording, as you resize the page, the content in the grid does get shifted around as the number of columns change, and the library recalculates where things need to be positioned. However, you can also see that this recalculation takes some time, And so content gets squished together, or you get a lot of blank space between the items until the library catches up and shifts the content into its new locations. So how can we build something a little bit more lightweight? Now, you may have seen a lot of demos on the internet of trying to accomplish a masonry layout using only CSS and HTML. And a lot of these demos look great, and they get you really close to the masonry solution that we're looking for. However, there's a number of assumptions that get built into these approaches. Often a fixed number of columns, or the utilization of media queries to adjust the number of columns based on specific known breakpoints in the container size. Additionally, you can use Flexbox to implement this sort of solution. And the way you would do that is to set the flex direction to be vertical along the columns rather than along the rows. The problem here is that that makes the ordering of items difficult, because the items themselves would actually flow down the column instead of flowing horizontally the way you would expect them to. So your content may not be in the order that you would expect with this sort of solution. So what is it that we're actually trying to accomplish with a perfect masonry layout? Well, first of all, we want to be able to account for a dynamic number of columns. So no matter what size the container of our grid is, we want to be able to fill that space with the correct number of columns based on the width of our content in each column. We also want to make sure that we're eliminating any unused space between items along the masonry axis. And we want this solution to be fully responsive with a performant and efficient reflow of content as the size of the container is changed. So let's look at Pinterest itself. Now, I'm sure many of you are familiar with this product, and it's probably the most popular and well-known instance of a masonry layout on the internet today. Now, if you look at this recording, you do see that the content is getting shifted around, and the relative order is more or less staying the same as it shifts things from more columns to less columns and moves them down. However, you can also tell that you get into situations where there's some horizontal scrolling involved as you make the page smaller. And as you make the page larger, there's a lot of white space around it until they recalculate where everything needs to go and then re-render the page. So let's look under the hood and understand a little bit more how they're accomplishing this. Now, Pinterest does their grid layout via explicit CSS transforms. So they look at the height and width of each item in their grid, and then they look at the overall height and width of the container for the entire grid, and they use JavaScript to calculate the exact position that each item in the grid needs to be. And you can see here that they've set explicit transforms to translate each item by a number of pixels along the X and Y axis so that everything gets laid out nicely on the grid. Now, where this comes up short is that they have noticeable delays in the way that the content gets reflowed, because they have to recalculate the position of every element in the grid every time the page resizes in order to update those transforms. Now, this is a computationally heavy approach because JavaScript is slow compared to native HTML and CSS features. However, in the case of Pinterest as a product, it's possible that resize performance is not a priority for them. If this isn't something that their users do often, resizing the homepage, they may not have had a reason to prioritize that performance in their solution. However, if we're thinking about a more generic approach to a masonry layout that could be used across any sort of product situations, we should care about the performance of the reflow, because we can't predict whether the users of somebody trying to implement this solution are going to be the kind of users that are going to resize the page, if it's a product that's going to be resized often, that sort of thing. So CSS Grid comes onto the scene and really helps us get very close to solving this problem. First of all, it provides us with fully responsive content reflow that is highly configurable. So CSS Grid as a browser feature allows us to set the width of columns, it allows us to set the height of rows, it allows us to set the gap between the columns and rows, and you can even set individual pieces of content to span multiple columns or multiple rows, which is going to be very important to our solution today. Because it's a native browser feature, it has great performance and there's no expensive calculations that need to happen in JavaScript. However, CSS Grid doesn't yet support Masonry. It expects consistent content sizes that align to the set heights of each row and the width of each column. So we're not quite there with being able to just do Masonry with CSS Grid. However, there is a property of CSS Grid called Masonry that is being worked on. It's part of the CSS Grid 3 specification, which is currently in editor's draft. However, you can see from this grid here that the feature is still experimental and it's not fully implemented in any of the major browsers, so you wouldn't want to use it in production. But can we still try to build some sort of performant Masonry layout today? The answer is what I've been working on. So I have a project that I've been working on since last year called Ember Photo Gallery. And you can actually check out this demo live today at ember-photo-gallery.jhawk.co. And as you can see from this recording, what I've been able to build here will actually efficiently reflow the content in the grid as you resize the page. It adjusts the number of columns and it is able to shift the content around without any noticeable delays in terms of deciding where everything needs to be positioned. So let's dive in a little bit to understand how I thought about approaching this problem and what some of this implementation looks like. So the first thing I wanted to do was design a Masonry grid component that provided a generic API for exposing this feature to any sort of consumers. And I did that utilizing CSS Grid and Ember modifiers. So here's what the architecture of my Ember Photo Gallery demo looks like. At the top level, we have a component called Masonry Grid, and that component has a modifier called Masonry Columns that it wraps around the user content that's getting passed in. Now, it then yields out a component called Masonry Item, which has its own modifier, Masonry Rows, that wraps around the individual pieces of content passed in by the consumer. And that's where my specific demo comes into play, because I've built a component called Unsplash Photo, which just lays out the content for each photo in my grid, and it hooks up to an API service, and then it has its own modifier internally called onLoad that handles the asynchronous nature of loading images in the browser so that we're able to calculate the correct layout at the right time once the images have fully loaded. So let's look at what the external API of our Masonry Grid component looks like. Now, first of all, we have arguments that allow us to essentially configure the CSS grid. And then we also yield out this grid.item, which is the Masonry item component that the consumer can then use to wrap any sort of arbitrary content that's going into the grid. So Masonry Grid allows you to configure the number of columns, the width of the columns, the space between the columns, also known as the column gap, and the row gap as well, so the distance between each row in our grid. It also yields out the Masonry item component, which the consumer will use to wrap its content. And the main goal that I wanted to have here was giving the consumer the full flexibility of configuring this Masonry grid. So I wanted to expose a number of the features of CSS Grid to be dynamically set by the consumer, and I wanted to make sure that I yielded this out in a block content API that gave the consumer the ability to define how their content would look in a way that felt ergonomic and followed best practices for Ember. So internally, within our Masonry grid template, we have the Masonry columns modifier, which gets passed a number of our arguments. It gets passed the number of columns or the string auto if we want it to auto adjust as the container resizes. It gets past the width of the column, and it gets past the gap between columns. And then we yield out a hash that contains our Masonry item component, and then we pass the row gap argument to the Masonry item component right away. So before we dive more into the implementation, I want to take a step back and just briefly talk about the concept of modifiers. So for this demo, I'm using Ember Modifier, which is an add-on that provides an ergonomic API for DOM interactions in Ember apps. Modifiers can be applied directly to elements in the template, and you can use them to mutate DOM nodes or generate state from the DOM. So our very first modifier here is Masonry columns. And Masonry columns is going to dynamically adjust the number of columns in our grid. It's also going to account for the width of columns and the size of the gap between columns when it calculates how many columns are available. And it's going to update the number of columns automatically using resize observer, which is a more accurate approach than static media queries, which have preset breakpoints in the size of your app. Let's look a little bit closer at the implementation of our modifier. Now, as you can see, this is a class-based modifier. It has a number of getters that set the grid width and the number of columns. And you can see I've just quickly circled the calculation that takes place to determine the number of columns. All we're doing here is looking at the width of the container itself, and we're dividing it by the width of the column plus the gap between columns to figure out how many times that space can be repeated within the container before we exceed the size of the container itself. Then in the constructor, you can see that we're setting up a resize observer, which is going to go ahead and run the calculations that we need when the container gets resized. One thing I do want to note here is that if you want a performant resize observer, you can actually create one centralized within your application and reuse it for all resize behavior that you need, because any number of elements can be observed by a single resize observer. However, for the purposes of simplicity within this demo, I've just gone ahead and made a new resize observer within the modifier itself. And then at the bottom here, in our organized grid columns method, which gets called by the resize observer, you can see that we're setting two styles on the element. The first one is the most important because that's our grid template columns style, which tells us how many columns that we have and what the width of each column is. And then also our grid column gap, which configures the gap between columns. So these are properties of CSS grid that we're setting within the modifier, which allows us to interact with the DOM. So let's look at our Masonry item component, which is really just a simple wrapper around the user's content. It applies a modifier to that wrapper, and it also handles some async behavior, which we'll come back to. So the template, again, is very simple. It applies this Masonry rows modifier on our wrapper div. We pass the row gap in, and then we pass it a promise, which handles the async behavior. And then we're going to yield out an action to the consumer that also will get used for the async behavior that we'll cover later. Let's look a little bit closer at Masonry rows, because this is really where the magic of our Masonry implementation takes place. It's going to do a number of things. First, it's going to calculate the number of rows that each content element spans, accounting for the gap between the elements as well. And what we're going to do here is we're going to set the row size to 1 pixel so that we get a pixel perfect grid layout. So let me show you what I mean by that. In our CSS, we set grid auto rows to 1 pixel. And what this does is it tells CSS grid that the height of each row is exactly 1 pixel. So every single row in the grid is 1 pixel tall. And that may seem counterintuitive, but that's what allows us to make this masonry layout work. Because as you can see in the modifier implementation itself, what we're going to do is calculate the height of the element in pixels, add the row gap to it, and then set the number of rows equal to the height plus gap in pixels. So for example, if you had a piece of content that was 200 pixels tall and your row gap was set to say 5 pixels, then we would set the grid row and style to span 205 rows. And since we have set a row to be 1 pixel tall, then we know that we can span 205 rows. So let's add some data to our masonry grid on the consumer side. I've used the Unsplash API, which allows me to retrieve up to 30 images at once. And for this demo, I went ahead and queried on the keyword Ember, because why not? I'm also going to load the images asynchronously. So even though the API itself is of course asynchronous, we're also going to have to account for the fact that once we set the URL on the image elements, there is asynchronous loading of the image itself in the browser. So there's not a lot you need to care about in this data service. This is pretty much just interfacing with the Unsplash API. I built a method that retrieves random photos and then returns the response from the API to our content that we're having set up here. So the masonry item template, I want to come back to this again. We touched on it briefly, but there's 2 things that I want to note here. One is that the masonry rows modifier is being passed this.onload, which is a promise we are going to define in the masonry item component. We have also passed an action and yielded it out to the consumer. And this action allows us to, as a consumer, to pass a promise back to our wrapper component. Now, if you look closer at the component class, we have this.onload being set in the constructor. And this is just a standard promise where we're capturing the resolve part of the promise. And when we get the promise from the consumer via the action, we're going to chain the resolution of that promise to the resolution of our internal promise. And what this does is when the consumer tells us that their async behavior is concluded and resolves their promise, then we're going to resolve our promise, which we passed to the masonry rows modifier. And the masonry rows modifier is going to wait for that to calculate the height of the content so that you ensure that the calculation happens at the right time and doesn't happen too early. If you were to not handle the async behavior there, then there's a possibility that your grid would end up squished vertically because you wouldn't have the correct calculations of the height if there was any sort of asynchronous delay in the loading of the content that would change the height of the actual elements. So let's look a little closer at Unsplash Photo, which is our content component. This is just a very simple container for the photo and its metadata, but it also handles the async image loading that we were just talking about. So on the left here, we have our class, which just handles the action that was passed in, and this action gets passed to an onload modifier, which, as you can see, is being used on the image element itself. So the onload modifier is what handles our load events for images. And as you can see in here, all it does is create a promise that then gets passed back out to the Unsplash Photo component. And that promise resolves when the load event on the element gets fired. So we're going to add an event listener onto our image element, and we're waiting for the load event, which tells us that the image is fully loaded in the browser. When that happens, we're resolving this promise, which then allows the entire promise chain to resolve and allows us to correctly calculate the height of our content. And that's it. We've done everything we needed to build Masonry Grid and to consume it for the demo. So a quick review of the way our architecture is laid out. we have the Masonry grid component, which exposes the main API for configuring the grid itself. We have Masonry columns as a modifier, which configures the columns of our CSS grid. And this gets wrapped around the entire content. And then we have our Masonry item component, which gets yielded out to the consumer. And it applies a Masonry rows modifier around each item in the grid. And the Masonry rows modifier calculates the height of the content in order to make that Masonry layout work. Now, we have the Unsplash photo component, which is the consumer side content, and it hooks up to a data service for API. And then we have the onload modifier, which just handles the async loading of the image in the browser and kicks off the resolution of that promise chain, which goes up to the Masonry item component and then back down to the Masonry rows modifier and lets the Masonry rows modifier know that it can now safely calculate the height of the content in order to set up that layout. So let's take another look at the final product here, which again, you can check out for yourself at emberphotogallery.jhawk.co. I'm not going to show the resizing behavior here, but what I want to really show you is that as you refresh the page and load in different image content, the grid is quickly laying out in whatever order it needs to in order to fill this full Masonry layout quickly. So no matter how tall each of the individual images are, this is able to performantly lay out the content because we're mostly leveraging the native CSS grid feature in order to keep it performant. The only calculations we do on the JavaScript side are a one-time calculation of the height of the content when the content first loads, and we set that as the CSS property telling us how many rows are spanned by each individual piece of content. Everything else is handled by CSS Grid itself, which keeps the solution performant and allows us to ensure that all of the content reflow is very efficient, no matter how often we're resizing the content or how often we're changing the content in the grid itself. Let's talk a little bit about what your takeaways should be from today. Now, there's a number of technologies that we've used that you can take back to your product development at home and at work and utilize in your everyday development process. First of all, CSS Grid is a great feature for modern grid layouts in the browser. It allows you to configure any number of aspects of the grid, including the size of the columns and rows, the gaps between each column or each row, as well as whether any individual element spans one or more columns or one or more rows, which, as you saw, was important for solving the Masonry layout today. Now, CSS Grid 3 is coming soon, which is great because once that lands, it's going to include a specification for native Masonry property on CSS Grid, and that will actually eliminate a lot of the work that we had to do today to make our Masonry layout work, because now Masonry layout will work natively in the browser. But until that lands and becomes a feature that is available in all of the major browsers, we can still implement that today using modifiers. Now, modifiers are great because you can attach them to any element in a template and easily make DOM modifications or generate state from the DOM. One of the things I love about modifiers is that they give you a nice barrier between the two-way nature of browser event bindings and the one-way nature of Ember's state flow. So that's an important concept to use modifiers to make sure that the logic of your Ember application stays very clear and that the state flow is very easy to understand while still enabling you to interface with native browser features. Now, if you'd like to check out the code from today's talk, you can go to elwayman02/ember-photo-gallery, and you can also check out the demo of that code at ember-photo-gallery.jhawk.co. And that's everything I have for you today. I want to thank you all for coming to my talk. If you'd like to connect with me online, you can find me on Twitter at Axel Hellfire or on GitHub at Elwayman02. And if you'd like to check out the slides from this talk, you can go to jhawk.co/EmberConf21. Thank you all. I hope you enjoyed the talk, and I hope you enjoy the rest of the conference.
Hi, my name is Alex and I run UX at CrowdStrike, and we are probably the biggest company that you've never heard of in the Ember ecosystem. We're a cybersecurity organization and we have a very straightforward mission: we stop breaches. Our customers range from some of the world's largest tech firms and banks through to startup R&D labs and human rights NGOs, and we protect them from everything from run-of-the-mill malware to highly targeted attacks by foreign intelligence agencies. And we are very, very good at what we do. The reason that I'm telling you all this is that we are growing, and we are growing fast. And we're looking to hire a whole cohort of engineers to help us build out our ability to protect every facet of a customer's environment. And what we're looking for is people that are really excited to dig into the needs of our users and to collaborate on building the best tools that we can. We believe that building great software is a team sport. And we structure our UX teams to be tightly knit groups of researchers, engineers, designers, writers, and QA. We've been remote first not since March 2020, but March 2012, and coincidentally that's how long we've been building on Ember as well. We're spread around the globe from Tel Aviv to Los Angeles, and the processes and the culture that make that work here aren't something that we've bolted on, but they're ingrained in our DNA. We're an inclusive and welcoming environment with a really strong one-team culture. We don't care whether you're a mid-career change bootcamp grad, a dyed-in-the-wool computer science major, or a self-taught developer. What we care about is your ability and desire to work as part of the team to create tools that help our customers and us stay ahead of the adversary. So if you're looking for something new, where you can be proud of using your skills to genuinely help make everybody safer, I'd really encourage you to take a look at some of the roles that we've got on offer. And please don't take my word for it. We've got 3 fantastic speakers from the team at EmberConf over the next couple of days, and many, many more CrowdStrikers are attending. So if you're interested, I'd encourage you to reach out to any of them with any questions that you may have. Thank you very much for your time today, and have a fantastic EmberConf.
Today, I'm going to start by telling you a story in 3 parts. 1. When I started my first job out of college, with a physics degree and some really terrible Fortran as my only experience, my new boss handed me 2 books. One was Kernighan and Ritchie's The C Programming Language, because I was going to be writing C, and the other was Steve McConnell's Code Complete 2. Both great books, but for today we're going to focus on Code Complete 2. And specifically, we're going to focus on one of the many good ideas McConnell had there, which is when you have a function which is going to do something, say, compute a total from a maximum and minimum by summing over the range between them. Then instead of declaring all your variables at the top of that function, from the total to the min and the max to even the loop index, declare them where they'll be used. Max and min, declare and initialize for each computation, total right before the function, and if your language supports it, index the loop inside the loop. McConnell notes that this has a lot of really lovely knock-on effects for how you structure and think about your program. It forces you to think about the scope that each variable should have. And this not only makes it easier to understand your code when you read it, it also makes it easier to make changes to your code. For example, if we wanted to refactor this by extracting total into a standalone function that does the loop itself, we can do that. And it's basically trivial because we've made those changes to our code. If we had left things as they were at the beginning, it would have been much more difficult to see how to make that refactor. This is a trivial function. It's way worse if your function is more complicated. Shrinking variable scope helps us understand and make changes to our code. For the second part of my story, in 2015, I met my favorite programming language, Rust. I'd spent most of my career up to that point writing a mix of C and Fortran and C++, so Rust's speed guarantees were going to be just as fast as those, were very attractive. So were some of its type system niceties, which I had recently come to appreciate from learning languages like Haskell and Elm. We'll come back to that in a minute. But my favorite part, then and now, is Rust's ownership system. Ownership in Rust, which is built on its type system, which uses an advanced type theory idea called affine types, means that with just a couple fairly conceptually simple ideas, we can get a high-level language that mostly feels like you're writing C# or JavaScript while getting that C or C++ level performance. Again, 2 simple rules. 1, every piece of data in the system has an owner, and exactly and only one owner. And 2, there's no shared mutable state in the system. So, we can have sharing or we can have mutability, but not both. We can share the data around as long as it's only readable, and the data owner is in charge of this. Or we can write to it as long as there's only one thing which has access to it. From those 2 rules, which, yes, you have to work a bit to understand sometimes, fighting with the borrow checker is a thing, but you get that nice blend of high-level ergonomics and low-level performance. There's a reason it remains my favorite programming language. It's because we isolated mutability, and now we have control over mutability in the system. We've shrunk the places where data can change in our system from anywhere we have access to the data to only the places that the owner says it can be changed. Part 3 of my story. As I mentioned a minute ago, when I started learning Rust, I had also recently been learning Haskell and Elm, which are purely functional programming languages. And purely functional programming is when we build our whole system out of pure functions. A pure function is a function which has 2 properties. First, it only has access to its arguments, which is to say it doesn't have access to any global state, and it doesn't have any access to any global functions. It only has access to its own arguments, which might be functions, and indeed its return values might be functions, but none of them access anything outside of its arguments. Secondly, we embrace immutability. There is no mutation in the system. So those arguments that we hand in, and that are the only things we have access to, we can't change them. To produce a new result, we may need to make a copy, and then hand back that copy with the transformation applied. And of course, we don't have access to global state, so we can't mutate that. But also, we can't mutate anything. This gives us purity in the sense of like a chemical solution, where we want to control the outcome, so we carefully control the ingredients that can go in. We want to pour in exactly and only the things we want and not mix it with anything else out there in the world. And that's the same kind of benefit we get from pure functional programming. If we have the same inputs, we have the same outputs every single time. And we can be assured of that because there aren't any other invisible inputs to a function, just its arguments. We also get the elimination of any kinds of bugs or even just confusion that comes from mutability. If I hand this function an argument, is it going to change that argument from under me? No, because it can't. There's no mutability. It can just hand me back a copy with the transformation applied. And finally, the combination of those things gives us a lovely property, referential transparency, which is a slightly opaque name for the idea that we can just substitute the results of evaluating a function for the function itself. You can think of this like math. If I have an equation that includes the term 2 plus 5, then it doesn't matter whether I have 2 plus 5 or 7 there. They're the same thing. And in fact, if I have an equation which has a sub-equation which does that, I can still just substitute it. It's the same value. Pure functions, because they only have access to their arguments and their arguments are immutable, have referential transparency. The net of this is, when I look at a pure function, this function only needs to understand itself to get its job done. And I only need to understand the arguments and the outputs of this function to figure out whether it does the right thing or not, to figure out how to improve on it, etc. In a language like Haskell or Idris or Elm, where every function in your program has those properties, every function in the program gives you the ability to look at this function and not have to worry about that function over there to understand it. Now, there are other complications that come along with this, and these languages have solved them, like how do I do a console log if I don't have access to a global console.log function? But for today, I want to keep focused in on our ability to think about this function right here without reference to that function over there, and vice versa. Pure functional programming enthusiasts will often describe this as pure functional programming giving you the ability to reason about your code better. But what does reasoning about your code mean? The term gets thrown around a lot, so let's try to dig in on it a little. I think that reasoning about your code is the ability to understand your code. What will it do? How will it do it? And there are a lot of things we want to understand about our code. Some of those are classical computer science kinds of reasoning. For example, what's the algorithmic complexity of this implementation? How will it scale up or down speed-wise as we have to traverse more data? And the same thing for space usage. How much memory will this data structure use as it grows, as we put more and more data into it? We also want to be able to reason about things like changing our code. What code do I have to change and where in my program to fix a bug? Or to improve the performance of my program, whether that's along computer science reasoning terms or along terms of cache locality or things like that. Where do I have to go if I want to add a new feature to my program or remove a feature from my program? What do I have to change? And then the last one of these I'll call out, though I think there are more. This one's the big one, right? Does my code work? Does it do what it should? Does it solve the business problem I'm setting out to solve with in the first place? Sad to say, I have read a lot of code, and even sadder to say, I have written a fair bit of code where it's actually really hard to understand the answer to this question. Ugh. Now, as a result of the importance of reasoning about these things, of understanding our code, we've built up a lot of tools and techniques over the years to try to get a better handle on them. But, and this is my thesis for the day, I think the key to all of those in many ways, or at least a key ingredient of all of them, is the ability to reason locally, to understand this piece of code without having to go understand other pieces of code in the system. Or, as my wife put it when I introduced this idea to her, we want to shrink the radius of what we have to think about to understand our system. So, going back to our first three examples, Code Complete 2's variable scoping guidelines from Steve McConnell, those helped us improve our ability to reason locally about variables and variable scope. And that improved our ability to work with that code over time because we could now understand it better and make changes to it, extract that loop into its own function. For Rust, control over mutability gave us the ability, again, to understand our system better. We know where data change can happen and can't happen. For refactoring, because the compiler will have our backs when we go to try to make a change. If we say, I want to write this now, and it's not writable, it's in read-only mode, the compiler will tell us. And by dint of that same compiler telling us, we get rid of a whole bunch of bugs. We get memory safety and a high-level programming language together by decreasing the scope, shrinking the radius of what we have to think about in terms of data mutation. And pure functional programming, similarly, combined purity with immutability to give us referential transparency, which lets us understand this function without reference to that function, which allows us refactor that function and know it won't break this function, and also gets rid of tons and tons of bugs for us by doing that. All of these improve our ability to reason about our code, to understand it, and therefore to work with it by improving our ability to reason locally about it. They let us shrink the radius of what we have to think about. Now, at this point, you might be thinking, but is that really so general a principle? you could have just cherry-picked these examples because they fit well with your thesis. I did not. In fact, I'm going to work through a series of case studies here, and I will show you that this is the Holy Grail. It is a significant piece, at least, of innovations we have been building and ideas we have been chasing for the last half century. Let's start by digging into Edgar Dijkstra's famous 1968 paper, 53 years ago, Go-To Statement Considered Harmful. Dijkstra's thesis. Our intellectual powers are rather geared to master static relations, and our powers to visualize processes evolving in time are relatively poorly developed. For that reason, we should do, as wise programmers aware of our limitations, our utmost to shorten the conceptual gap between the static program and the dynamic process, to make the correspondence between the program spread out in text space and the process spread out in time as trivial as possible. This is about local reasoning. Dijkstra wants us to shorten the conceptual gap between the static program and the dynamic process, between the program in text space and the process in time. Now, Dijkstra over the rest of the paper teases this out in terms of coordinate systems. Those can be textual, like line numbers, or they can be things like the index of a while loop. If you have goto in your system, Dijkstra tells us, it doesn't matter what else you've done to make your system comprehensible. Control flow constructs? Ha! Functions? Ha ha! Variable names? None of these will help you. While loop index. What does it mean? What does I mean here? Well, there's a goto in your program, so who knows, because that goto could drop you right in the middle of that while loop, and then it's a function of how the while loop happened to end last time, and maybe other things too. By contrast, if you get rid of the goto statements in your program, that while loop is comprehensible to you. And the reason is that goto requires global reasoning. You have to get the whole world in your head, because you have to read the whole program to know what might land you in the middle of that while loop. By contrast, when you embrace structured programming, you get the ability to reason about just that while loop, to reason locally. Because if there are no gotos in your program, then you can't accidentally end up in the middle of that while loop somehow. It's improved our ability to reason locally about control flow. Now, I wish I could say this is a purely hypothetical thing, but remember how I said I spent the first chunk of my career working with Fortran and C and C++? Those programs were riddled with goto. It was a bad, bad time. I literally had to understand the whole flow of the program anytime I wanted to make any changes. And so the only way to actually make progress there was to work to eliminate every single goto statement in the program, to turn it into a function, to turn it into a structured while loop, whatever the case may be. And that did pay off. In the end, I could reason about the code because I had gotten the ability to actually have meaningful control flow. But it was painful. Goto murders our ability to reason locally. Structured programming gives us the ability to reason locally. And that goes for one of the other pieces of structured programming advice we've probably all internalized, which is to avoid global mutable state. So in the same way that a goto causes us to reason globally when it comes to control flow, global mutable state, if I have some object out there that any function can touch and change, that makes me reason globally about data change in my program, because any piece of my program can change it arbitrarily at any time. Whereas, while it's a little more work to thread it through to just the functions that actually need to read it and actually need to change it, at least that way I can reason about, these are the places in my program that actually can change the code. Those same goto riddled programs had a lot of global mutable state. I spent a lot of time threading them through. But when I was done, I could actually understand where the changes were, and therefore where any bugs were, or where performance improvements could be made. Structured programming gave us a big leg up, but we kept looking. Object-oriented programming gave us a bigger leg up here, and encapsulation specifically keeps us on the theme of reasoning about data change. When we had that shared mutable data in our system, even if it's not global anymore, When we pass it around through the system, we have to reason about any function we pass it into, because any of them could make arbitrary changes to our data. If we encapsulate our data and wrap it up inside an object which has a few public methods on it, then we've gained the ability to reason not just about any function which touches it, but instead about this class's methods. No matter what function we pass this object into, the only ways that this object's private data can change are through those methods. So we can test it, we can refactor it, we can make changes to it, and those other functions we passed it into won't get broken along the way. This actually goes for the solid principles too, though in this case we're now talking about interfaces, the contracts between objects. So here we can start with the single responsibility principle. This one's pretty straightforward. If this object has a single responsibility, and that object has a single responsibility, then when I'm thinking about this object, I don't have to think about the responsibilities of that object. If we design our system that way, we've shrunk the radius of what we have to think about when thinking about any given object. The same thing goes for the open-closed principle. We should design our objects so that they're open for extension, but closed for modification. And what that means is that when I'm working on the internals here, well, if I've designed my object this way, who cares how I've been extended? None of those extensions can muck with my internals, and vice versa. I've shrunk the radius of thought to either extension or the internals, but not both at the same time. The Liskov substitution principle says that you should be able to use a subtype anywhere you use the supertype. So if you have an animal, you should be able to use a cat or a dog or a goose. This requires us to think only about animals, and therefore it lets us think only about animals, and not about the details of cats or dogs or geese. The interface segregation principle says have lots of small interfaces instead of one big one, because that way, whatever is consuming that interface, whatever is a client of that interface, can think about just its own responsibilities, instead of having to think about all the responsibilities in the system. This is powerful for shrinking the radius of thought because it means this client only has to know what this client has to know. It doesn't need to know anything about other kinds of entities in the system. Finally, the dependency inversion principle says depend on abstract things instead of concrete things. And what we really mean there is an interface instead of a specific class, whether that's a formal interface like in C# or TypeScript, or a duck-typed interface like in JavaScript or Ruby. The big idea is if we depend on an interface, then we can swap out the implementation. We can change the details on the other side of the implementation. We use this all the time to make testing possible, for example. All of these let us shrink the radius of what we have to think about in terms of interfaces. And this generalizes beyond structured or object-oriented programming too. The actor model, best known in the context of Erlang, which runs the telephone systems in the United States, helps us to reason locally about resilience or fault tolerance. In a traditional monolithic system, we have system-wide failure and recovery. If an exception gets thrown and isn't handled somewhere in your system, the whole thing goes down. In an actor model, instead, we have a bunch of small pieces of our system, which can talk to each other by sending messages, but they can fail without other pieces of the system failing. So you can say, I know this is a fatal condition for this piece of my program, and I can just let it die. And the supervisor can say, hey, come back up in a healthy state, please. And the rest of the system is stable against that. We have independent failure and recovery. This has improved our ability to reason locally about fault tolerance and about resilience. It goes for types too, and how we use them in our program. This is closely related to some of those OO principles, but it's just as applicable in functional programming. Let's imagine we have a user class. This has a name and an age and an email address and a state of residence. We'll say this is a United States user. And we want to describe that user. Well, we can do that by having a function which accepts a user and returns a string which pulls the username and age together. Chris is 33 years old. There's a problem here, though. We're actually coupled to all the details of the user. When I call describe, I don't have any way to know whether in fact describe is using the email address and the state. It's not, but I don't know that. I can't make changes to those without checking the implementation of describe. And even inside describe, this is a simple function, but if it were a little more complicated, I could accidentally end up coupled to the email address when I didn't originally mean to. It makes data coupling hard to reason about. By contrast, if I say, hey, this describe function takes any object which has a name and an age, which are a string and a number respectively, now I've eliminated that data coupling. As a caller, I can say, here's a user, because I know that it doesn't depend on the email or the state of residence or anything else. And internally, I'm now protected against accidentally depending on details I didn't mean to. In sum, we've moved from reasoning about a whole class to reasoning about structured data, from the user to just those particular things we care about. We've improved our ability to reason locally about data coupling. Last but not least, let's talk about auto tracking. It seems like a good way to wrap things up at EmberConf. In Ember Octane, with auto tracking, there's only one way to have reactivity in our system, with tracked and the primitives it's built on. That's huge because in Ember Classic, and in fact in any observable-based system, reactivity is actually a function of the consumer of our data. So with Ember Classic, for example, classic computed properties would use the computed decorator to determine what things we wanted to listen for changes on. And then, as long as we used this.set and this.get to create changes and read changes, that property is reactive. Anyone, anywhere in the system could do that if they had access to the data. And because we had one-way binding, two-way binding, when we passed data through our system, all of it was available for this kind of access. This meant that if you wanted to understand the reactivity of any given piece of data in your system, you had to read every place that used it or anything derived from it, because the caller is in, the consumer is in control of the data. They get to say, haha, this is reactive now. And I would say this is about the worst thing I can imagine in terms of defeating our ability to reason locally about reactivity, except the second part is even worse. The second part is that we also had observers and observer-like lifecycle methods. These chain on top of that original problem and allow us to create arbitrary further pushes of reactivity into the system. So I watched that property. I've made it reactive by marking it as a dependent key and using this.set to push into it. And now whenever it changes, I can trigger further this.sets. If you want to understand, therefore, the full reactive flow of data through an Ember Classic system or anything that looks like this, you have to track all of the data that is involved all the way through the system. No matter how implicit that transition is, no matter if it goes through a did receive adders and therefore you don't even have a computed property key to check, you have to follow it. This, infamously, could get us into infinite loops because you could set a property over here, call it did receive adders here, which sets a property there, which triggers an observer there, which sets the original property again. Oh no. This was terrible, to be perfectly honest. I liked a lot of things about Ember Classic, but this was terrible. And that's why we've moved to auto tracking, because it puts the owner of the data in control of reactivity. And this is huge. When we mark a piece of root state as reactive with tracked, that is what makes it reactive. Nothing else in the system can make it reactive. We no longer have this kind of arbitrary reactivity where consumers are in control. The owner of the data is in control of the data. Second, because we've got real one-way data flow, because Glimmer components don't have two-way binding of their arguments, and because we've gotten rid of observers and observer-style lifecycle hooks, we now have a situation where we can be confident that there are also no arbitrary pushes of reactivity further into the system. We've improved our ability to reason locally about reactivity. Reactivity happens where things are tracked, and that's it. Thinking back to Rust, this should sound familiar. Rust gave us control over mutability, and that let us reason about the rest of our system because we knew where data could change. That's true here of reactivity. Now we know where data can change in reactive ways that matter to the rest of our system. Or pure functional programming, We embraced purity and immutability because they gave us referential transparency everywhere else. We could reason about this function without having to think about that one. Control over reactivity does something very similar. By isolating reactivity to tracked properties, we've made it so that everything downstream of those is a pure function, is referentially transparent. And to bridge into the parts of the world that aren't, we have constructs that explicitly bridge into going and doing something with the DOM or handling events coming from the DOM. We've gotten basically referential transparency all the way throughout our system because we've isolated reactivity. We've shrunk the radius of what we have to think about when it comes to reactive data. So to sum up, it's really important to be able to reason about our code. We need to be able to understand what our code does and how it does it. But to do that, we have to be able to reason locally. We have to shrink the radius of what we are trying to understand for us to be able to comprehend it and therefore to work with it, to make changes to it. So from affine types to the actor model, from structured programming through object-oriented programming, all the way up through auto tracking and the kind of pure functional programming model that it lets us embrace in an Ember Octane app, local reasoning is key. Our big takeaway should be that we need to keep leaning in on local reasoning. We need to shrink the radius of thought. We need to keep it local. Thank you.
Hey everybody, it's Ava, a Gaiety, and we're back again for EmberConf, another virtual one. I have been to EmberConf several times, and last one, well, that was a surprise for everyone, as little things happen, but we all went virtual, and it was my first time giving a conference level talk. Gosh, I was so anxious to be up on stage, and then we just recorded it at home, and it was great. But now we have a little bit more time to plan for everything, and I think it's going to be really nice to connect with the community through this online event, coordinating through workshops, listening to talks simultaneously online, and just talking on Discord. Discord and the Ember community and all my friends and loved ones, they've been helping me get through this rather hard year. I've been through one job change already and just many different ways to grow for not just myself, but everybody I know. So we've been through some tough times. We're about to gather here again, and it's just really nice to be here again with all of you. So have a lovely rest of your EmberConf. I know I'm excited for a lot of different things that are going to be happening this week. And catch you all on Discord. Chat with me. I'm Gaiety on Discord. Thanks.
Hey there, my name is Lenora, and today I'll be talking to you about how to learn Ember in 2021. This is based on my journey of learning Ember as a designer in 2020, and might I add, during a global pandemic. Learning during a global pandemic is so hard. However, without the help of the Ember community, my mentors, and pure willpower, I don't know if I could have gotten through it. Do you want to know more about how I did it? Keep on watching. I'll just pour some tea while I'm at it, you know? So, let's set the scene. So it is 2018. I, Lenora, just accepted her first Silicon Valley role, right? That's like groundbreaking if you're from any other place outside of Silicon Valley. Just accepted my first Silicon Valley role at Heroku as a senior product designer. Before all of this, I was a 9th grade math teacher teaching Algebra 1 to students in my hometown, Miami, Florida. I guess I just didn't see how that opportunity would have shaped my entire future going forward, but it really did. To go back into time and see, boom, now I'm a senior product designer for a Silicon Valley top-notch company, working for some of the best designers I've ever been around in my life. I'm like, who would have thought? As I started to work and started to get acquainted with the Heroku design system and what Heroku needed feature-wise, I started seeing more opportunities to be able to contribute to our design system via coding. So I wanted to take the leap. I wanted to take the leap because I was very passionate about that gap. And I'm still passionate about it. I'm passionate about filling the gap between design and engineering. I'm passionate about being able to fill the gap between design and engineering communication. I'm, very passionate about making sure that the designers and the engineering team is aligned, they have parity, they talk, they communicate. I'm all about that piece, that gap. And the more I just started to work with the team, I'm like, I think I want to fill that gap. I'm more comfortable in that gap. Please give me that gap. An opportunity arose, and I took it. Now, the opportunity wasn't presented to me in a, hey, here is a gap title. The opportunity was presented in a way of, here's a software engineering title. Now you have to learn Ember. And I'm like, oh wait, I didn't ask for all that. But at the same time, I'm like, this is a good challenge. I love challenges. Let's go, right? So my trajectory into learning Ember, yes, it was a little nuanced, but at the same time, I feel like as a total beginner, I jumped into Ember without any knowledge of it, and now I can call myself a learner or a novice or a person who can actually do things using Ember. Because of the pandemic, I've had to revise my learning plan a ton. I couldn't go to the conferences I wanted to go to. I couldn't meet the folks I really wanted to meet. I couldn't hug the people I wanted to hug. So a lot of my time was spent cultivating relationships via social media. And honestly, I think I did it. So what I wanted to show you today was, how those learnings happened. I went through failures. I went through success. I went through, I don't know this, I'm defeated, I'm tired, I don't want to do this anymore. I went through all of those things. And I've gotten out on a, to me, much better space when it comes to Ember. If you are a new learner, this talk is for you. If you are a mentor, this talk is for you. If you are someone who believes in the phrase, always be a beginner, this talk is definitely for you. Let's get started. So, I'm going to bring my computer up just so that I can follow along with you all. So what will we talk about today? Number one, the mindset of a beginner. This is the foundational work. You need to do this part just so you can cultivate your mind and get prepared for this journey. This journey is a long journey, and you need to be in the right mindset for this type of growth. Number two, pre-curriculum prep work. This is where you do some research on yourself. You figure out, how do you learn? How long do you want to learn? Are you better in the mornings? Are you better at night? Are you better during the day? How best can you maximize your learning? Number 3, we're going to focus on creating your learning curriculum. From here, this is more of a structured guide. Okay, 30 days, this is what we're going to be doing. Here's your goals. Here's what you're going to be learning. Here are your weekly to-dos. Here's your daily to-dos. This is where we break down our actual learning goals. Number 4, we're going to be talking about this method. It's called try, fail, learn, and repeat. This is one of my favorite pieces of the entire presentation, to be honest with you. It talks about my entire journey, when I failed, how I got back up, what trying looked like for me, what practice looks like for me. This is the actual practice, hustle, grind part of it. So yeah, let's go. Mindset of a beginner, preparing yourself. Like I said, foundational pieces. This is what we all need to prepare our minds. Preparing for a new learning journey. Your mindset can make or break your learning journey. I get it. I mean, who wants to be the incompetent one or the one with the least knowledge in the room? Everyone wants to be able to contribute to their team, to contribute to themselves and their future. However, we cannot be that rigid with ourselves. We have to give ourselves grace. We have to give ourselves some kind of flexibility. In my opinion, to me, the best way to cultivate a growth mindset or a forever learner mindset is to accept and own your curiosity. I know that children, we forgot that. We forgot that. We no longer do it. But when we get to the mindset and the place of owning our curiosity, it would open up so many doors. I mean, it would be a place where we could imagine endless possibilities. We could, stop all limiting beliefs. We can go from failure to failure without losing enthusiasm. That part, the last part, without losing enthusiasm. That one's hard. That one is very hard. However, you have to get to that curiosity where you don't even care if you fail. That's strong curiosity. That's the kind of curiosity that will never waver. That's what you need. So I'm just going to say it one more time. To create and cultivate a really good beginner mindset, you need to own and accept your curious mind. With that being said, do you remember how being curious made you feel? Do you remember your first time being curious? Well, if not, allow me to reintroduce you to your curious mind. We're going to be watching a scene from my favorite movie, Up. Give me 1 second.
Adventure. Unlimited. And you're the weather in the logbook! Oh, there's something down there! I will bring it back for science. Oh, it's a puppy! Ah! No time! A star! Lightning! Hail! What are you doing? Ah! Don't you know this is an exclusive club? Only explorers get in here. Not just any kid off the street with a helmet and a pair of goggles. Do you think you got what it takes? Well, do you? Yeah. All right, you're in. Welcome aboard.
Did you notice how curious Carl was? I mean, he was so curious that he risked walking into an abandoned house. Like, whoa. That's how curious you need to be. That's how open to curiosity and open to adventure that you'll need to be when you embark on a new learning journey. Let's put on our jetpacks and move on to our next point, and that is the pre-curriculum stage, the pre-work. How long will this even take? Research says it takes 10,000 hours to learn a new skill. That was quoted in the book The Outliers by Malcolm Gladwell. And he also cited it from a journal article in 1983 by someone named Anders Ericsson. And Anders studied what it took to be the best in a particular field like sports, medicine, music, etc. So he studied these people until he realized, oh, these people take around 10,000 hours to be masters at their craft. So I wanted to do the math. I'm like, okay, let's put this in perspective of a 40-hour work week. So you have 40 hours times 52. That's 52 weeks in a year. So you get 2,080 hours. 2,080 hours, to me, covers your entire year, approximately. 10,000 hours divided by 2,080 hours, that gives you 4.8 years. If that's the case, it takes you about 5 years to become a master at your craft. Now remember I said master. Anders Ericsson debunked what was going on in the Outliers book and let everyone know that is not what I said. What I said was it takes you 10,000 hours to master, not to learn a skill. It does not take you that long to learn a skill. Later on, Jacob Kaufman of the first 20 hours, he theorized that it takes 20 hours to learn a skill. 20 hours is pretty doable. So now that we understand how long it will take, let's move on to our second point, and that is, what's your learning style? When it comes to learning styles, I can never choose one. I'm literally all of them. But it all depends on how familiar I am with the topic. So if it's my first time learning particular skills, or if it's my first time using Ember, then I'm more of a visual learner. I could watch a tutorial and not do it. I could look at pictures and illustrations through the guides, but I will not actually put those things in context. I just want to visualize it, get a sense of it. As time goes on and I become a little bit more familiar with it, I'm more of an auditory learner. At this point, I can turn on an audiobook, I can turn on a podcast, I can turn on some kind of like screen reader to listen to a blog post. I can do that because now I can visualize it. I don't need to see it. I can visualize what they're talking about. So number 3, I may know of the subject, but I'm not proficient in it. When it comes to that, I am totally a hands-on learner. I need tutorials. I need to actually put my hands to the actual code. I need to study. I need to pair with other people. I need to rubber duck. I need all that. I need all the hands-on training I can get. And then the last one, if I'm not proficient in it yet, but I can do enough to be dangerous, I think it's time for me to teach. I think you don't know what you don't know until you teach someone else. That means teaching your parents, teaching via social media, learning out loud, which is what I usually do when I want to really learn something, but I also want the accountability piece. I will learn out loud. Hence, I did a few things while I was learning. Every morning at 5 a.m., I would learn out loud via Twitch, and people would watch me learn. So what I'm going to do right now is just show you exactly what I mean by that. I've broken down my resources based on my learning style. So you have your visual. These are all of the tutorials that I watched. They're very small, easy to digest. Then I move on to my auditory learning. These are the podcasts. These are, the weekly newsletters. Then I move on to hands-on learning. Hands-on learning are the actual tutorials. Mike North was probably one of my faves. Gavin Joyce, chef kiss, loved it. Then I moved on to teaching opportunities. Teaching opportunities were me going on Twitch and learning out loud. EmberConf, I'm right here. Beginner's Mind Week at work, where I did a mob pairing session with all of the developers on my team. And a few of the Instagram posts that I created around Ember, just showing, highlighting what I've been learning and some of the tutorials that I've completed. Lastly, I put reading. I don't like reading, but I do like it once I'm familiar with the subject and I'm curious about it. I can read all day then. But I have to train my mind to want it. So reading, I have all the books that I read, like Belit Erdy's book, Rock and Roll with Ember. I have the newsletters. I have Pro Ember Data. That's one of the books that I recently bought, so I can understand data better. But yeah, you get the point. Then I have my social media accounts. I feel like this is one of the underutilized areas. You have to get surrounded and embedded in the community. Without the people that's a part of the community, you won't really know what's going on. So get embedded, join into a community.
And then of course I have your open source projects that you can contribute to. This is another easy method of learning. So I created this compiled list just so I can always go back and visit it and see what I need and what I can grab from. So let's move on to our next piece, and that is creating your first curriculum. In the spirit of the first 20 hours book, I decided to plan out my first 30 days. 20 hours is usually 1 hour for 2 weeks, but I thought if I expand it, what's 30 days? That won't hurt. So I spanned it for a month, and I planned out my 30-day learning curriculum. I write out my goals. Where do I want to level up? This particular example, I discussed that I wanted to level up in all Ember core concepts. I make a plan. So Monday through Friday, I do tutorials and learning, and that will be at 5 a.m., 1 hour a day, a minimum of 1 hour. If I go over that, that's fine, but a minimum of 1 hour a day is totally fine. And on weekends, I take my breaks. Always make room for breaks. Always give your brain rest. So third, we have proficiency metrics. And with proficiency metrics, I basically wrote down all the topics that I really want to understand. So if anyone ever asks me, hey, Lenora, what's a model? I'll know exactly how to answer them without hesitation. Number 4, preferred learning resource. I picked one learning resource for those 30 days, especially the first 30 days. I do not want to mix my learning. I used Blint Erdy's Rock and Roll with Ember, and that's just what I stuck with. The last thing is weekly study plan. So with my weekly study plan, I would literally write out week 1, do these things. Week 2, read chapters 3 through 6 and do these things. I had a very structured learning. So let's move on to our weekly daily plan. With my weekly plan, it was more like it was notes. It wasn't really like rehashing what I'm going to do. It's mostly notes. So each week, I'll read ahead to look at what topics will be covered, and I'll categorize them by what I already know, the areas that I kind of know, and then the completely new areas that I have no idea what they are. I've even added a section called phrases brought up at work. Now let me explain why I did that. So one day, my mentor, he talked about Ember concurrency, and I'm like, oh, let me write that down. And I started researching and learning about it. The next day, I'm like, yeah, I'm struggling with Ember concurrency. He's like, Lenora, what are you doing? That's not why I talked about that. I was working on that, but that's not something you need to worry about. You need to focus on the foundational pieces, like not Ember concurrency. So I would definitely say, save those phrases for later. It will definitely come back, and it'll definitely help you out later in the future. That's for your future self. But for your now self, you just focus on your foundational pieces, but write down when you hear different things that you like to explore later. In an effort to learn out loud, I would basically post my notes via social media. Now let's move on to part 3, mentors, coaches, and community. This is one of my favorite parts. These are all of the amazing folks who've helped me cultivate my career, who've helped me learn Ember. I would like to point out 2 people, Jamie and Micah. Jamie and Micah did an amazing job at cultivating a relationship with me early on, so that when it was time to coach me or mentor me, it was like butter. Jamie was more of the coach where he was a lot more hands-on. He's like, hey, let's actually do the work. You drive, I watch. If you run into issues, I'm here, but you go ahead. Michael was more of the, no, tell me what you know about models. Tell me what you know about template files. Explain to me what you think you know. He was more of the, I have to talk to you about it. Honestly, everyone's teaching style worked out perfectly for me. It helped me keep track of things. And yeah, if you have time to build up your mentorship and your coach tribe, please do that early on. There are so many communities available, especially within the Ember community, that will help you ramp up and will help you get the coaching you need. And yeah, I don't think there is an actual coaching program, but everyone's so helpful that you indirectly get the coaching. Like for instance, I have people that's there's friends in the community. I don't talk to them every day, but whenever I send a PR in, they send me feedback, they allow me to understand what I did wrong, and they help me learn how to do it better. So that's still coaching within itself. So how did this all work out for me? For real. With that said, I would like to move on to a scene from the movie Up. Yep, it's back.
There it is. Well, go ahead. Go on.
If Crash and Burn was a person, it'll be me. I promise you all, trying to learn Ember, I mean, it wasn't like it was hard. It was just, you really needed to pace yourself. And in my perspective, without a coach or without deliberate practice with someone guiding me saying, yeah, you may not want to do that yet, do this instead. Without a coach, I probably wouldn't have gotten as far as I have gotten. You can plan out your learning, you can structure your day, you can do all of these things, but there's nothing like having deliberate practice via a guided resource and consistency that will really pull you along the path. There's plenty of times where I'm like, all right, cool, I'm gonna practice, I'm gonna do this thing, I'm gonna learn, and I couldn't get through a small little Pomodoro. It's like, come on now, you're talking about you're gonna learn, but you're not even doing your due diligence. So I would tell you all, if you feel like giving up, that is a natural feeling. If you ever feel like giving up, own it. Own it when it comes time to take a break. If it's time for your break, listen to your body. Listen to your body when it tells you to stop. Listen when it tells you to go to the beach. Listen when it tells you, hey, that was nice, you tried. But let's give our brain a rest, because right now we're trying to reconstruct those new neural pathways and you're interrupting. So let us help you. Please rest. Listen to it and take your rest. So I do want to let you all know that when it comes to this journey, you will need to take rest. And sometimes that can last 2 weeks, sometimes that can last a month. Take your breaks. There is a quote that I found on Instagram not too long ago. It said, passion lights the way, while discipline paves the road, and hope is the fuel. Not sure who created it. I tried to Google, couldn't find it. I thought I would change it up a bit. I think it should be passion lights the way, while discipline paves the road, and making it personal is the fuel. Now, during those moments that I just talked about where you feel defeated, where you feel like, oh my gosh, this is it, I can't do it anymore, I'm done. That's the time I feel like you need to try that try, fail, learn, repeat method, where you make it personal. Create a personal project. I created my personal project right in the very beginning. So remember those 30 days I talked about? I created my personal project during that time. When I realized the way to create a Ember project, all you need to type is Ember new in the app name. I'm like, all right, cool, Ember new med reminder. And the reason why I created this was for a special guy in my life. It's my dad. And my dad went through a few things growing up. When he was in his 20s, he basically met up with some police brutality. And he was hit in the head by a baton so hard to split his skin. And if you take a look at the actual skin, you can tell that someone stitched it up really badly. So that means that either he went to jail and they stitched it up any way they wanted to. And I don't know what happened after that. I don't know whether he sat in the jail cell. I don't know. I have no idea. But he survived it. Later on, had me. And now, as a 50-year-old, 60-year-old person, he's having issues with his brain, with remembering, with dementia. There was a time where he would get severe headaches and he would be like, hey, I gotta pull over on the side of the road. And I always questioned it, but I didn't really understand. I was a kid, so I didn't know. But it wasn't until one day in 2006, where he actually passed out. And when he was rushed to the hospital, they found an aneurysm. And if you know anything about aneurysms, aneurysms are extremely deadly. 60% of people survive. Now 60% is very close to 50%. So that's like half of the amount of people survive this thing. And 66% of the survivors have permanent neurological damage. Well, that's my dad. He has extreme short-term memory. I'll tell him something today and he'd be like, wait, what did you say? The next second. So he can remember things that happened long ago, but he can't remember what happened today. And that creates a problem when it comes to him taking his medication and taking it on time and remembering to take it. So I created a personal project to help this special man of mine remember to take his medication. So basically, it's an Ember app. It has a daily tracker. And right now, he's on track. He has taken his medication alone by itself without needing any assistance. And basically, my dad is young. He's not like in his 70s or 80s or 90s. He's young. He's like, I don't want you to keep coming here to like give me my medicine because you think I'm gonna overdose. And I'm like, okay, well, would you take this app? Just so you can keep track of it, and so I can also keep track of it without like bugging you or calling you every day. So this app will allow me to peek in on what he's doing, but also allow him to remember if he already took it. So there's dashboards all over the house, or he'll be able to see, hey, yes, I did take my medication already. All right, cool, I won't take it again. So this is how it works. I kind of guess I didn't really explain that. So it sends him a text message in the morning. Hey, did you take your epilepsy medication or whatever other medication he has? Did you take it? And if he presses number 1 or if he sends 1 as a response, it'll basically send back to Ember, letting them know, hey, perfect. This person took their medication on time if it was within that time gap. And they'll give us a check mark. If the person did take the medication but it was late, it will put on the right side, taking epilepsy medication, but it was late. Just to let me know what's really going on, and if I really need to talk to the doctor or let them know, hey, he took it, but he still had a seizure later on that day, or he took it and he didn't have a seizure. I want to keep track of those things. So with that police brutality moment, later on he started to occur seizures, severe seizures, and my dad has catatonic seizures, so you don't even know that he's having a seizure. He's just quiet. And you just assume, well, what's wrong with you? And then you realize, oh my God, he's having a seizure. So I wanted to create a app that helps with that. So in my perspective, I feel like if you make something personal and you pull at your heartstrings, you will learn. There's plenty of times I put this application down because I couldn't figure out how to get Twilio to talk to Ember data. I'm like, all right, I'll put it down for now. And then when I learn something new at work, I'm like, oh, cool, I got it. I can go back to my project and add that piece, that missing piece that I was looking for. So my advice is when you're learning something new, create a side project, create something personal, and that will keep you going when times are low. So if this inspired you in any way, here are some action items. If you are a newcomer to Ember, I would like you to be welcomed into this space. I want you to join the Discord community. I want you to contribute to the open source projects. I want you to create your own curriculum. And if you do not know how to create it, I would love for you to go to my GitHub. I'll have a starter pack there where you can just quickly fork down a Ember learning resource or a learning plan and go forth. Learn, my love. If you are a mentor or coach, I would like you to let your mentees know how to learn deliberately. I want you to navigate them and tell them, hey, no, don't learn Ember concurrency. Learn about templates. Learn about functional helpers. Learn about other things, but not this just yet. I want you to put them on a path of success. And I feel like if you do that, it will help them create an environment where they are challenged, yet they can still achieve the tasks you're asking. If you are an Ember community leader, I would tell you to encourage newcomers as much as you can. If you're on social media and you hear about someone saying they want to learn Ember, encourage them. Bring more people in. There's so many people that's ready to learn a new language, and honestly, the community will be the it factor. Our community at Ember is, in my opinion, the it factor of what made me stay. I could have gone to any community, but the Ember community was so welcoming, and I was so about it. And honestly, that's the only reason that I stuck so closely. How to contact Lenora? So if you want to contact me, here's my Discord. It's Lenora Porter, Twitter, Lenora Porter, Instagram, Lenora Porter, GitHub, Lenora Porter, Twitch, Lenora Porter, YouTube, Lenora Porter, and my website, lenoraporter.com. Basically, everything is Lenora Porter. So if you do want to reach out to me, I am at Lenora Porter. If you need any more helpful guides, how to learn coding or how to learn during a pandemic, let me know. I would love to be a resource to you. Thank you so much for listening to my talk. See you later.
Hello, EmberConf. How's it going? My name is Chris, but you might know me better by my online handle, Xeroc. And I work at LinkedIn, and I'm a member of the Ember Framework core team. Normally, I work on the rendering layer. I work on Glimmer VM and components and auto tracking, that sort of thing. But today, I wanted to talk about something a little bit different. I wanted to talk about a data layer, specifically Ember M3. M3 is a data layer that we developed at LinkedIn to handle some of the problems we were dealing with at scale with vanilla Ember data. And you might be thinking, if Chris is getting up here to talk about this M3 thing, is this the future of Ember data? Should I switch over to it immediately? The answer is no, actually. Ember data and M3 are built on the same common core and share most of the same infrastructure. M3 is really just a different take on the modeling layer in Ember data. And they can actually be used side by side. The modeling layer in Ember data. And they can actually be used side by side. If you wanted to use M3, it actually has trade-offs. And there are situations where it makes sense, but there are also situations where it doesn't. So we'll dig into that a little bit more as we go on and see if it really would be the right solution for you. I personally started using M3 in some side projects alongside Firebase. And part of the reason I wanted to do this talk was just as I was using it, I found out that it was one of the most fluid, flexible, and fun data experiences that I've had in my 10 years as a front-end web developer. Huge thanks to Chris Thoburn, Runspired, for showing me this combination and showing me just how powerful it could be. So yeah, today we'll be talking about what M3 is and what problems it was built to solve, how it works, what Firebase is, and why it's a good match for M3. And then we'll actually see the combination in action, so you don't have to take my word for it. First off, what is M3? Well, I think it's best to understand M3 by understanding the problem that it was trying to solve. At LinkedIn, we have a lot of data. We have thousands of models, and those models are very complicated with nested fragments within them, leading to tens of thousands of different models and fragments all over. That is very difficult to keep in sync in general with our ever-changing API layer. So our first solution was actually to generate the models. Our API layer is highly conventional, so we were able to build tooling that did just that. This helped with the issue of keeping things in sync, but we still had this problem of shipping tens of thousands of generated models and fragments to our clients. And that added up. That was hundreds of kilobytes of code that was having an impact on our customers. So enter M3. the idea with M3 was rather than have a class for every single model and fragment, we would have one class that could represent all of them, and it would do that dynamically. The way M3 does this is it really just understands a model to be a blob of JSON. It can have JSON values of any type. So for instance, here we have a name, an object that has a name, which is a string, and it has a chapters array, which is an array of objects. And these could be updated to be Booleans or, you know, any kind of value. You don't have to specify what the shape of your model is ahead of time. Now, this is still better than using fetch because M3 does understand that each model has an ID and a type, and so it'll deduplicate them and make sure you're using the same reference to the model everywhere that you're using it. And this is also very important for M3's other major feature. It also understands relationships within that blob of JSON. It understands them based on conventions. So in this API response, for instance, we are representing a reference to another object as an object with a type and an ID. M3 will see this, and based on that convention, it will load those models and replace them in the actual model itself, so that when we access them, we're accessing the instance of the relationship rather than the type ID thing. So we don't have to figure that all out ourselves. This can be configured with the M3 schema. So you can make this work with any kind of convention for your relationships and with any conventional API. It can work with JSON API or RESTly, which is our LinkedIn spec, or GraphQL, so on. Anything that has strong conventions for relationships. This allowed us to go from tens of thousands of models being shipped to the client to just one. In our single largest refactor, we removed over 64 kilobytes of generated code after min and gzip, which is absolutely enormous. So it's had a huge impact on our code. Now, is M3 the right choice for you? As I said before, there are trade-offs. On the pros side of things, we have the fact that it handles these complex nested models of JSON very fluidly. This also works really well with strong and conventional APIs, and it requires less maintenance to keep things in sync between your front end and back end. Finally, for very large apps with hundreds or thousands of models, it definitely can help to improve performance. The cons are your front end no longer has your model definitions. So you really have to have like good API documentation in order to make sure that your code doesn't get out of sync and that everybody understands what the models should look like, what the API should look like. It also really requires a conventional API. It can't work with one-off or bespoke APIs, although you could use vanilla Ember data alongside it for that. Finally, M3 really expects to load relationships synchronously when you access them. What this means is that there's no promise API for loading a belongs to or has many only when you need it. If you want to do that, you have to make sure that those relationships are loaded ahead of time yourself. So you either have to include that logic in your routes or you have to absorb it somewhere else yourself. And that can be a little bit of complexity to add to your data layer. So M3 is really great for large apps that have conventional APIs and will definitely benefit from the decreased maintenance and payload size. But it's not as great for small to medium-sized apps that won't benefit as much from that decreased size and may have more trouble with the dynamic models and the sync relationships and so on. That said, I can guarantee you that the personal projects that I've been working on aren't the size of LinkedIn, and the whole premise of this talk is that Firebase plus M3 is absolutely an amazing combination. So why is that exactly? Well, to understand that, I think we need to dig into Firebase a little bit. What is Firebase? Firebase is a backend as a service, which basically means it provides everything you need to write an application and just focus on the front end. Firebase provides a database, and it provides things like push notifications and so on. And this can be really helpful if you're like me and you only have a few hours on the weekends to work on some idea and you just want to get it out there really quickly. Firebase's database is Firestore. And the difference between this database and other databases is that it's a document-oriented database. And what that means is that rather than representing data as tables, it represents it as objects, and specifically as JSON. So you can write any record into your database as any arbitrary JSON value. And this has a number of advantages. It means you can represent really complex models very easily. There's no need to have 10 tables and 20 joins to represent something that's conceptually simple, like a object that has an array with a couple of nested objects in it. It also really means you can think about your database and application in the same way as you're developing them. And that can be really helpful for making application development more fluid. The cons are it has very limited query capabilities. It's hard to query arbitrary JSON objects in general. And because of that, it also has no concept of relationships. Relationships really have to be managed manually. So it means that there's a lot more boilerplate there. You have to do the work yourself to figure out what related values are and to load them. So right off the bat, we can see the similarities between Firestore and M3. Both of them think about models or records or documents, whatever you want to call them, as JSON values. They're just data that has any kind of JSON object within it, or array, or any other value. The key thing that M3 adds here is those relationships once again. M3 is able to understand what the relationship looks like when it reads that JSON value and replace it with an instance of that class, of that model. So you don't have to do all of that boilerplate to figure out what the relationship is yourself and load it yourself from Firestore. M3 handles that for you. This means you get all the advantages of a document store database, but you have conventions around your relationships. And that is what makes it such an amazing development experience, in my opinion. But you don't have to take my word for it. Let's dig right in. It's demo time. Okay, so for today's demo, we'll be working on a simple meal planning app called Ember Meal Plans. And the concept is pretty straightforward. You'll be able to add recipes and then use those recipes to create meal plans. And I've already actually created the recipe portion of the application. As we can see here, we can add a new recipe. We'll call it cookies. And it'll serve 12. It'll create 12 cookies. And let's say 200 calories a cookie. And the most important part, bake it with love, the most important ingredient when baking cookies. And as we can see, if we reload, that all persists and everything, so it's already hooked up to Firestore. What we're going to do is create the meal planning portion of the app, which so far all I have here is an outline made with HTML, but no actual JavaScript hooking it up to Firestore. So we can see we have our index page that shows the total list of meal plans, and then if we go into our meal plan, it has a name, it has a number of days, and each day has a number of meals, which we can add to and do things like track our total calorie counts and so on and so forth. So let's get started. First up, I just wanted to have a real quick note. I'm actually using Canary versions of Ember Data and Ember M3 because I wanted to show a Canary feature that is coming soon, which is native proxy support. And that allows us to not use Ember get and Ember set, and rather instead use native access and native methods like push instead of push object on arrays and such. This is a sorely needed feature because otherwise M3 definitely still feels like it's a little bit pre-Octane, but I'm really looking forward to it, and I wanted to show you what the development experience is with that enabled because, as I said, it should be here sooner rather than later. So first off, I want us to start by thinking about the model itself. So I like to document my models in my code base, and I use TypeScript interfaces for that. We don't actually have to create any files or interfaces or any TypeScript to work with M3 models because they're dynamic, but I find it really helpful if there's some clear, concise documentation of what we actually expect them to look like. So I already created one for recipes, and we can see here that recipes have a name, which is a string, instructions, another string, number of servings, and total calories. So let's go ahead and create an interface for meal plans. Interface meal plan, export default meal plan. It's a quirk of TypeScript. And first off, our meal plans definitely have a name, as we can see here. And then they have a number of days, and those days are actually going to have a lot of their own properties. So it's a list of objects, an array of objects. And we'll actually go ahead and create another interface so we can document that, that object and see what it looks like. Within that, we can see days have a number, but that's honestly just the index in the array where the day is, if it's the first one, second one, and so on. So we don't need to store that. And they also have a total calorie count, but that's also derived. So the only thing it really has per day is a list of meals. And meals are also objects because each meal has a number of properties. So we'll go ahead and create another interface for meals. And meals have a name as well, name string. And here's where we start to see some of the power of M3. Meals have a recipe, which we can just import the interface from that file and use it here. And this is really where we see some of the power of M3 because we can just place this relationship on this nested object within this model. We don't need to create any other model classes or intermediate steps like we would with Ember data. This whole model here is pretty complicated. It's got several layers of nesting, and in Ember data that would have to be a few has many relationships and belongs to relationships and so on. But with M3, it can just be a JavaScript value, a JSON value with the nested relationship in it. So that really helps to clarify everything. And I feel like this interface helps us to kind of see what we expect our data to be, and of course, to document that. Okay, so now moving on, let's actually hook up the index route here. So I've got my index route set up, and I've already injected the store into it, and I'm going to do model. And for the model, I'm just going to return this.store.findAll meal plan. And that is basically the same as Ember data there. We can just find all the meal plans and use them. And we'll actually use them in our template here. Each model as plan. Each. We got this link to here. We're going to have to pass the model to it as well, equal plan.id, so that it triggers the logic within our show route, which we'll see in a minute. And we'll use plan.name for the title of that link. All right, so now we don't have anything because we haven't created a plan yet. So next up, we're going to add an event listener to our template on the button for new plans, create plan. And then in our controller, we are going to add an event listener here for creating that new plan. And we're going to make that an async function. And I've already injected store here as well. It's kind of like I planned this out or something. And then we're going to create a new plan. Let plan equal this.store.create record meal plan. And we're going to pass in a name to that, just a default kind of generic name new plan. And we're also going to pass in an array for days. And it's just going to be an empty array for now. So this is, again, basically the same as what you would do in Ember Data. Just store.create record, and then we can do await plan.save. And then we'll do, we'll transition to the plans.show route using the plan ID. Perfect. And if we press the button, we see the plan. We don't actually transition to it, though, and I think I know what that is. I think we need to figure out what to do with, first off, we need to add the dynamic segment to our link to. So plan ID. And then we need to actually add some logic to our show route to handle loading the data, loading the model. Otherwise, there's some default logic that happens, and that's not what we want. So let's do that real quick. So we have our model function, and like before, we have our store already injected, but we also get plan ID now. And I'm also going to import hash from RSVP because I want to return a couple of promises here. So the first one I want to return is the plan. We're going to do this.store.find record. And that's going to be meal plan. And we're going to pass in plan ID. So the meal plan that we actually want to load. But then we're going to load all of the recipes that go along, that exist in our store. Because we want to be able to select from our recipes within our meal plan editor. You could do this dynamically in one of your components, but for now, just to keep things simpler, I'm doing it here. And I'm going to do this.store.query recipe because I also want to pass in an extra parameter here. I want to pass in subscribe, which is going to subscribe us to updates for those recipes. This will help to demonstrate some of the reactive features later on. And this is something that is special to, unique to Firestore in particular. It's not an M3 feature in general. All right, cool. So now if we click on that, okay, our route is working again, but nothing is hooked up, of course, yet. So let's go to our template and start doing that. We'll do at model.plan.name, but that's not actually going to update anything. That header is just there for accessibility and purposes. The value that we actually need to hook up here is this input. And I have an add-on that I'm using called xinput that we're going to use for that. So we're going to pass in value. This is going to be at model.plan.name. And then on input, we're going to set at model.plan name. So this is using Ember set helper. This allows us to update the value without actually having to define a JavaScript handler, which can be really nice when you just want to update a value. So we'll do that and look at that. That works. It updates here correctly. But if we reload, it doesn't persist because we're not actually saving it. So next up, we are going to, I actually don't think I need store in this one. We're going to add save to our controller. And this is going to take our model, this.model.plan, and call save on it. So then we can use that in our template. I'm going to use Ember composable helpers here to queue up a few different actions to happen together. So we're going to do set model plan, .name, and then we're going to call this .save immediately after that. So now if we update this to be my plan and we reload, well, that did not work. Oh, got to save. My plan, and everything persists. Awesome. Okay. Next up, I'm going to actually extract out a component here because the rest of this template is a little bit complicated for my taste. I don't think we should do this all in one spot. So I'm going to generate a component, then I'm going to copy that code over into this component. And then what I'm going to do is we're going to actually loop over model.plan.days as day. And we are going to invoke our component, meal plan day. We're going to pass it day, which will be the day. We're also going to pass it day number equals, and we need our index here from our loop. And we're going to increment it with Ember composable helpers, inc index 1. And for now, that's all we're going to pass it. So internally in our component, we can do at day number. Okay, cool. We go back. Of course, there aren't any days yet because our meal plan started off with no days. So let's also add the logic for adding a day. We on click this dot add day, and then add day equals this dot model dot plan dot days dot push. We can just push into the days array like it's a normal array. And we're going to push a new day. It's going to have a meals array, and that's all it has. And I also think we can add a default model here. We'll have name, new meal, recipe, null, and servings, 1. Because I think, honestly, if you're creating a new day, you probably want to have a meal in it, just for starters. So then we'll do this.model.plan.save. And now in our app, we can add a day. And if we reload, that day is still there. Perfect. So next up, we are going to hook up the meals form within our day. We're going to add an each loop because we're going to each over the day.meals array as meal. Each. And then within that, we're going to use our X input again. I'm just going to copy that over from over here, put that in. So the first one, also updating a name, but of the meal instead of model. Oh, I have to put it inside the li up here as well. Okay, cool. Perfect. So new meal is updated. Foo. Cool. That won't persist yet, though, because we need to also queue in save. And save is not this.save. We have to actually pass it in as an argument here. So let's pass that in. At save equals this.save. Perfect. Now that should update. And if we reload, awesome. We're still having cookies for breakfast. That's the way I like to start my day. All right, next up, we're gonna do the select here. I'm using xselect, which is an add-on for selects. And I'm gonna do value equal meal.recipe. And here's where we update and change our relationship. So we can just pass in the recipe, set meal recipe, and at save, similar to the input. I'm just going to quickly copy over some template for the options themselves. But as we can see here, we actually pass in the recipes themselves into each option and then set them directly on that on the meal. We don't have to do anything special. We can just add the relationship to the JavaScript value, and M3 figures out all the details for us. And of course, we have to pass in the recipes to our meal plan day component. So we'll go to model.recipes here. And if we go back, now we can select a recipe. Still doing cookies. All right. Finally, we'll do the servings input there. Just copy our logic here. Type equals number because it's a number input, and set meal.servings. And I want 2 cookies for breakfast. Oops, added another day there. Okay, cool. So everything appears to be working. Last thing we need to do is add the logic for this add meal button. So let's do that real quick. We're actually going to need a event handler. So we'll do that. And it's going to need to receive the day that we're adding the meal to as an object, because otherwise we wouldn't really know. That's going to be day.meals.push. We'll just copy the template here for a empty meal. And then this.model.plan.save. Perfect. And then now we can use that within our template. Add meal equals this.add meal. And in our component, we can now add it to this button. On click this dot, well, it's not this, sorry. And we actually need to use fn because we need to pass in the day as well. So now we should be able to do, yep, and we can add meals. I'm gonna add lunch, and we're gonna go with French toast because, you know, I really am enjoying sweets today. Cool. Finally, let's do these calories counter things here. We want to actually be able to show some derived state. So I'm going to generate EmberG some helpers to help us out with that. Meal calories. And then EmberG helper day calories. All right. And then in day calories, we're going to receive our day. Actually, I'll start with meal calories. Meal calories, we're going to receive our meal. And I'm going to have to reuse this logic in day calories. So I'm going to export this function. And then return, let's see. We're going to want to do let recipe and servings from our meal equals meal. And then if we have a recipe, it could be null. So if so, we're going to just return 0. But if we do have a recipe, we're going to want to do math.floor of recipe.total calories divided by recipe.num servings. Got to find out how much an individual serving is. And then we'll multiply that by the number of servings that we're having. And we do math.floor just to make it a little bit nicer in terms of displaying. So we can use that in our component here. We'll go meal calories, meal. And that looks about correct to me. We add another cookie that increases the overall calories. And then for day calories, I'm actually going to just copy paste that over here real quick. But you can see the gist of it. We import meal calories, and then we have our total, and we add the meal calories for each meal to our total for the day. And then I'm going to use that in our template real quick. And the important part about these helpers, day calories dot day, is that they're all just plain JavaScript. We're just using a meal with properties that have recipe servings. The recipe relationship is just treated like a normal object, even though it is a relationship. And for the meals themselves, we can for each over it just like it's a normal JavaScript array. So all of our derived state as well, especially with this new proxy feature that I mentioned earlier, is really intuitive and easy to use overall in my experience. And yeah, now we have a meal planner that can show us the calories that we're eating on our every day. And I'm going to just go ahead and show off a little bit more here. Let's say that you wanted to, edit those recipes. Maybe we decided, what, our cookies don't need that much sugar. We can just go ahead and do that. And we can see the impact that it has in real time on our meal plan, because our meal plan is represented in this very straightforward data structure that allows us to create all of this derived state based on it. And we also have all the real-time capabilities of Firebase. So that, to me, is something that is pretty amazing and one of my favorite features about Firestore overall. All right, so that concludes our demo. Thank you so much.
Hi, my name is Robbie, and I'm the head of infrastructure here at Flatfile. I'm here to save you from ever building your own CSV importer ever again. Think of the last time that you imported a spreadsheet to a web app. Did it work correctly the first time? Chances are you ran into an import error similar to what's seen here. Importing data can go wrong for a ton of reasons: incorrect column naming, special characters, encoding differences between operating systems, the list goes on. Our flagship product, Portal, embeds into any application and provides a production-ready import experience for you and your customers in just minutes. Portal auto-maps columns, validates data on import, and turns messy CSVs and Excel sheets into structured JSON, freeing engineers like yourself from sitting in Excel fixing data for hours or dealing with customers thinking your product is broken because they didn't format the data the way you were expecting. Flatfile also provides data hooks, which can be customized to validate any type of data on import automatically. Zip codes, dates, countries, you can even split fields up. Today we're announcing version 1 of our Ember add-on to make adding Flatfile to your Ember application faster. With just a little bit of code like this, you can throw your CSV and Excel importer in the trash. We have a special offer for EmberConf attendees through the end of the month if you're interested in getting Flatfile into your product. If you'd like to get the discount, just sign up on our website, flatfile.io, add a credit card, and fill out the form at is.gd/ff_EC. That's is.gd/ff_EC. We'll take it from there. Thanks so much for watching, and have a good time at EmberConf.
The prize-winning author Maya Angelou once said after publishing her 11th book that every time she wrote another one, she'd think to herself, uh-oh, they're going to find out now. I've run a game on everybody, and they're going to find me out. Even Maya Angelou experienced imposter syndrome. But to call it a syndrome is to downplay how universal it is. To that end, the psychologists who first described this experience didn't call it imposter syndrome. They called it imposter phenomenon. You will find imposters in all facets of society, regardless of culture, gender, age, or occupation. In fact, psychologists estimate that 70% of people will experience this feeling at least once in their lives. And you can be sure that 70% of people are not incompetent. So it's not an issue of competence, it's an issue of confidence. I am one of these imposters. I'm a programmer from a non-traditional background. My first career was as an architectural designer. I designed buildings and urban landscapes for tech companies in Silicon Valley. You might even recognize my work. When I left architecture, I attended a code school here in Portland where I learned Ember, among other things. It was awesome. I was so stoked to get my new career started. One evening, I recruited some code school colleagues to join me at the local JavaScript meetup. The meetup turned out to be a bit of a dud, but by stroke of good fortune, in walked a crowd of people, all clad in Ember gear. It turned out that an EmberConf happy hour had arrived. Despite being super nervous, I did my best networking and met a crowd of very nice folks. But one conversation stuck with me the most. After bragging about having graduated with his computer science degree the year I was born, a man tried to convince me that code school is a bad idea because the market was oversaturated with junior developers. He then proceeded to give my male code school colleagues sage career advice. I started to think, maybe I don't belong here. Later, at our school's showcase demo day, I presented my hobby app to potential employer after potential employer, but one interaction in particular stuck out.
I recognized Yehuda Katz from across the room. He's like the guy that wrote the thing, right? I stumbled through my presentation, and less than an hour later, I had a very flattering email in my inbox, and I've been working at Tilda ever since. And yet, I still felt like an imposter. Mr. CS degree was still in my head. 3 years into my journey at Tilda, we decided to finish converting our app to Octane. Since we were already refactoring our entire app, we figured we might as well convert it to TypeScript at the same time. Godfrey gave us a TypeScript demo, and we were off. At first, I felt a little overwhelmed, but eventually, as we worked our way through the app, I started to really see the benefits of TypeScript. I found myself drawn to working on more complex, sometimes crufty areas of our code base, code that had intimidated me before. Beyond transforming our code base, I myself was starting to feel transformed, from a competent but hesitant mid-level engineer to a competent and confident senior engineer. I was starting to feel less like an imposter. Imposter phenomenon is talked about quite a bit in the programming community, and there's lots of wonderful advice to be found. Everything from surround yourself with supportive people to just decide to be confident. Rarely are technical and tooling solutions offered. Based on my experience, I propose adding one more item here. Convert your app to TypeScript to foster confidence in your engineering team. Now, the last thing I want is to imply that converting your app to TypeScript is going to be a piece of cake. And if you don't agree with me, you must be, well, an imposter. So we're going to start with the basics. What even is a type? What is TypeScript? Then we'll look at what TypeScript looks like in an Ember app before circling back to the benefits of TypeScript in the context of developer confidence. You've likely come across the concept of types before. A values type tells us what type of data it stores and what you can and cannot do with that data. There are 9 types in JavaScript. The most basic types are called primitives. JavaScript's primitive types include number, string, boolean, big int, symbol, undefined, and null. You can check a value's primitive type by using typeof, with the exception of null. In addition to primitives, JavaScript has more complex structural types. An object is a mutable collection of properties organized in key-value pairs. Arrays, sets, maps, and other class instances are all objects under the hood. Now, because typeof will return the string object regardless of the class, instance of and other checks are more useful here. The other structural type is function. A function is a callable object. You may have heard that JavaScript is a loosely typed and dynamic language. Loosely typed means that every variable has a type, but you cannot guarantee that the type will stay the same. For example, you can change the type of a variable by assigning a different value to it. Even stranger, in some instances, JavaScript will implicitly coerce your value to a different type, sometimes in unexpected ways. For example, you can add the number 2 to the number 2 as expected, but JavaScript will also allow you to add any of the other JavaScript types to the number 2 without throwing an error, leading to a variety of not so useful results. JavaScript is also a dynamically typed language. This means that you never need to specify the type of your variable. Instead, the JavaScript implementation determines the type at runtime, and it will do the best it can with that knowledge at runtime. Sometimes that means coercion, as we just saw, and sometimes you get dun dun dun, the dreaded type error. What could go wrong? It turns out quite a bit. In 2018, the error monitoring company Rollbar analyzed their database of JavaScript errors and found that 8 of the top 10 were some variation of trying to read or write to a null or undefined value. Furthermore, because of type coercion, it's possible you might have additional type-related bugs that don't even cause errors to be thrown in your app. All of this leads to uncertainty, and uncertainty is the enemy of confidence. Fortunately, TypeScript is here to help. TypeScript is an extension of JavaScript. When writing TypeScript, you can use all of JavaScript's features plus additional TypeScript features. The main difference, syntactically, is that TypeScript adds type annotations on top of the JavaScript you already know and love. When the compiler turns your TypeScript into JavaScript, it determines the types of the values in your code and checks the validity of those types in the context in which you used them, before outputting standard JavaScript with the type information removed. If you've used a value incorrectly, you get a type checking error, alerting you to the issue before you ship your code. Also, because our text editor can run the TypeScript compiler in the background, it can integrate the type information and other related documentation into the editor user experience to give you, for example, code completion, hover info, and error messages. VS Code gives you these features out of the box, no installation required. And because TypeScript comes with all of JavaScript's built-in types baked in, such as DOM types, you have a ton of information at your fingertips. It's basically like having an answer key to your code. Having an answer key available to you at all times not only reduces your cognitive overhead, but it makes you feel like a rock star. And it's hard to feel like an imposter when you feel like a rock star. So, how does TypeScript get the answer key? Because TypeScript is a strictly and statically typed language. Statically typed means that TypeScript checks your code for potential type errors at compile time. For all of this magic to work, TypeScript needs to know the type of your values at compile time. Sometimes TypeScript can infer the value of a type from its usage. Other times, you may need or prefer to declare the value to the type of the value with a type annotation. It's worth noting that unlike some other statically typed languages, TypeScript will still compile even when you have type checking errors. In other languages, the type system can feel like a gatekeeper. In TypeScript, it feels more like a messenger. While type checking errors can be frustrating at times, they're almost always telling you useful information. TypeScript is also more strictly typed than JavaScript. Once a variable has a type other than undefined or null, TypeScript will not allow you to change that type. Also, TypeScript disallows a lot of implicit type coercion. For example, you can add the number 2 to the number 2, but you will get a type checking error if you try to add, for example, an array or a set to the number 2. Interestingly, TypeScript will still allow you to add a string to a number. The compiled JavaScript will implicitly coerce the number to a string before concatenating the two strings. In my example, this might seem a little ridiculous, though you might be able to imagine it happening in the case of, say, an input value. In the real world, however, adding a number to a string is a common enough thing to do intentionally that it's considered idiomatic. The TypeScript team decided not to make TypeScript too strict in this case. If you disagree with them, you can enable an ESLint rule to forbid this. This is one example of how TypeScript's strictness is configurable. You can also increase or decrease the strictness via a file called tsconfig. Strictness helps you to achieve something called type safety. This means that TypeScript will help you avoid those pesky type errors. In fact, researchers found that TypeScript detected 15% of public bugs. Shipping fewer bugs helps you to become a more confident developer. TypeScript has all of JavaScript types. Here are examples of explicit type declarations for each of JavaScript's primitives, represented in TypeScript. Because Because TypeScript can infer the type of your value from its usage, these explicit annotations may not always be necessary. The annotations for structural types, however, start to get a little more complicated. The array type is an example of a generic type, a reusable type that takes another type as an argument, denoted with angle brackets. In this case, the array type takes the string type as an argument, and TypeScript knows that our variable is an array of strings. To declare the type of a function, declare the type of each variable and the return type as so. For an object, use an interface to represent each of the properties and their types. In addition to JavaScript's basic types, TypeScript provides even more types. Let's go over a few types you might need to understand this talk. The void type is the absence of a type. The void type is most commonly used to specify that we don't expect this function to return anything. The unknown type is useful for when you don't know the type of a value. When you use unknown, you can narrow the type of the value using typeof or other comparisons. The any type can also be used when you don't know the type. The difference, though, is that when you annotate a value as any, TypeScript will allow you to do anything with it. Essentially, when you use the any type, you are opting out of static type checking for that variable. Proceed with extreme caution. All right, let's convert an app to TypeScript. We'll use the Super Rentals app from the Ember guides as our example. Super Rentals is a website for browsing interesting places to stay during your post-COVID vacation. Super Rentals is a very modern Ember app using the latest and greatest Ember Octane features. Admittedly, using TypeScript with pre-Octane Ember was clunky. With Octane's native classes, however, using TypeScript with Ember is pretty straightforward. The first step is to run ember install ember CLI TypeScript. Installing this package adds everything you need to compile TypeScript. The TypeScript package itself, types packages for each of Ember's modules, a default TS config, and some utility types and directories. While Ember itself isn't fully written in TypeScript yet, there's a project called Definitely Typed that acts as a repository for types for hundreds of libraries, including Ember. You can install these types as packages, then import them the same way you would a JavaScript module. Now that we've installed TypeScript, we can start converting files. Fortunately, TypeScript allows for gradual typing. This means that you can use TypeScript and JavaScript files interchangeably, so you can convert your app piecemeal. Of course, many of your files might reference types in other files that haven't been converted yet. There are several strategies you can employ to avoid a chain reaction resulting in having to convert your entire app at once. TypeScript declaration files are a way to document TypeScript types for JavaScript files without converting them. Alternatively, you can sometimes get pretty far just by annotating types as unknown. Or you can opt out of type checking for a value by annotating it as any. A better strategy than any, however, is to mark offending parts of your code with the TS-expect error directive. This comment will ignore a type checking error and allow TypeScript compiler to assume that the value of the type is any. The value is of the type any, sorry. If the code stops triggering the error, TypeScript will let you know. You can also gradually increase TypeScript's strictness. There are two ends of the spectrum here. On one end, start with all of the checks disabled, then enable them gradually as you start to feel more comfortable with your TypeScript conversion. I do recommend switching to strict mode as soon as possible because strictness is sort of the point of TypeScript to avoid shipping detectable bugs in your code. On the other end, start in strict mode. This is the strategy we will use for converting super rentals since I want you to see the full power of TypeScript. In fact, I want my TypeScript even stricter. I'm going to also add the TypeScript ESLint plugin, which adds additional checks. So, which file should we convert first? Here are 4 strategies to choose from. 1. Outer leaves first. Models likely have the fewest non-Ember imports, so you won't have to use as many of our gradual typing hacks. This strategy is best if your app already uses Octane, since Octane getters might not always be compatible with computed properties. 2. Inner leaves first. This strategy is best if you are converting to Octane simultaneously with TypeScript. You will need to make heavy use of our gradual typing hacks. 3. You touch it, you convert it. Whenever you are about to touch a file, convert it to TypeScript first. This strategy is best if you don't have time to convert everything at once. And 4. Most fun first. Pick the files you are most curious about. Refactoring to TypeScript is an awesome way to build confidence in your understanding of a chunk of code. This strategy is also great for onboarding new team members. The Tilde team tried all of these strategies for our elderly half-classic, half-Octane app and settled on a mix of you touch it, you convert it, and most fun first. For our super rentals conversion, however, we're going to approach the conversion outer leaves first. Our outermost leaf is the rental model. In JavaScript, it looks like this. The rental model keeps track of various attributes about our vacation rentals. It also has a getter to categorize the type of the rental into either community or standalone. Step 1, rename the file to TypeScript. And we're done. Congratulations, you've just written your first TypeScript class. Because all valid JavaScript is valid TypeScript, any JavaScript code will still compile as TypeScript code. But we've got some type checking errors. It looks like we have a little bit more work to do. These squiggly lines indicate type checking errors. Let's start from the top. Member title implicitly has an any type. This error is telling us that we need to annotate the title attribute with the type. We can look at the seed data from the Super Rentals app to figure out what the type should be. It looks like the title is a string. Let's add the type annotation, and we get a new error. Property title has no initializer and is not definitely assigned in the constructor. This message is a little confusing, but here's what it means. TypeScript expects properties to either be declared with an initial value, be set in the constructor, or be allowed to be undefined. TypeScript doesn't really know that the adder decorator is making the property exist, so TypeScript thinks that this property will never get set. In this case, we can tell TypeScript something external is setting this property by marking the value with the declare property modifier. Let's go ahead and resolve the rest of the squiggly lines on the attributes. The last error is coming from ESLint, asking us to provide a return type for the type getter. Because we know that the type getter will always return either the string community or the string standalone, we can put string in as the return type, or we can be extra specific and use a union of literal types for the return value. All right, we're free of squiggly lines. Let's commit. One more thing about models before we move on. The rental model doesn't have any relationships on it, but if it did, we would use a similar strategy to what we did with attributes, the declare property modifier. Also, the Ember data types give us handy types that keep track of the many intricacies of Ember data relationships. Cool. The next leaf in includes routes. Let's convert the index route. It's pretty simple, with a model hook that accesses the Ember data store and finds all of the rentals. First, we'll rename the file to TypeScript, and once again, we have some errors. The first error is member store implicitly has an any type. we know that the type of the store service is a store. We can import the store type from Ember data and add the type annotation. And because the store is set by the service decorator, we need to use the declare property modifier again. And the last squiggly line is again the linter telling us that we need a return type on the function. But how do you know what that return type is? Here's a little hack you can use to check the return type. Pop void in as the return type. This gives us a type checking error, as expected, because we know the model hook does not actually return nothing. Promise array makes sense, but I wouldn't expect an array of any values. It should be a more specific type. Something seems wrong here. We've run into one of the first gotchas of using TypeScript with Ember. Ember makes heavy use of string key lookups. For example, here we look up all of the rentals by passing the rental string to the store's findAll method. In order for TypeScript to know that the rental string correlates with the rental model, we need to add some boilerplate to the end of the rental model file. The Ember CLI TypeScript installation added a model registry for this purpose. And we just need to register our rental model with the registry. And now we get a much more useful error. It looks like our return type is a promise array of rental models. We can add the appropriate imports and the type annotation, and now we have no more squiggly lines. Let's commit. Next, let's try converting a component, the innermost leaf of our app. The rentals filter component filters the list of vacation rentals based on a passed-in search query. When we rename the file, we see some squigglies. The first squiggly is the linter reminding us to add a return type to the function. From reading the code, it looks like we are expecting results to turn an array of rental models. So let's put that for now. The next squiggly says, property rentals does not exist on type empty interface. We are destructuring the args, but it looks like TypeScript has no idea what properties the args object should have. We need to tell TypeScript what the component arguments are. Fortunately, the Glimmer component type is a generic. It takes an optional type argument where you can specify your args, like this. Now, TypeScript knows about our component's arguments, but it's complaining that the rentals argument type is unknown. By doing a little sleuthing, tracing the component invocations back to the route template, we discover that the rentals argument is the resolved model from the index route. We can extract the model type from the index route by using the model from utility type that we can borrow from the Ember CLI TypeScript documentation cookbook. And now we have some new squiggly lines. This lengthy error is telling us that the rentals argument returns an array proxy of rental models, but filter is coercing it into an array of rental models, which has slightly different behavior. For example, array proxy doesn't have push or pop methods like an array does. This could cause a bug in our future. We always want to return an array, so we can resolve this by first converting the rentals argument to an array before using it. Bye, bug. The last error is argument of type unknown is not assignable to parameter of type string. TypeScript is telling us that the includes method on the rental title string expects a string to be passed to it, but we've passed an unknown. Let's find out what that query argument type actually is. Just like with rentals, we want to extract the type from the calling component if possible. In this case, query is a tracked property on the rentals component. We can get the type of that property by importing the rentals component type and looking up the type of the query property using a similar syntax to what we'd use to access a value on an object. Phew, we're done. Let's commit. Let's take a look at one more component. The map component displays a map of the given coordinates retrieved from the Mapbox API. First, we'll rename the file to TypeScript, and we see some errors. Let's start by adding our arguments interface and resolving the return type lints. And look at that, all of our red squigglies went away. For your first pass converting your app, I think it's totally fine to merge the unknown types like this. But I have a few more things I want to show you, so we'll add the real types now. We'll reverse engineer the types from one of the invocations. With the actual types, we still don't have any type checking errors, all good. But I wonder if there's anything we can do to make this component easier to reuse. For example, is there a way to throw an error anytime an engineer forgets to pass in one of these arguments? It turns out there is. We can use a union type to tell TypeScript that the longitude and latitude arguments might be undefined. Then we can use getters to alias the arguments, but with an added check using Ember debug's assert. The assertion will throw an error with the provided message if the condition is false. Also, the type for assert is written such that TypeScript now knows that the condition must be true for all of the following lines. This allows us to drop the undefined type from the argument before returning it as a number. Thus, we can use this.longitude and this.latitude elsewhere in our code without having to worry about the possibility of them being undefined. Also, the best part is that the assert code and its condition are stripped from your production builds, so you haven't added any production overhead. All right, let's commit. And we're done converting our app. If you don't want to switch to TypeScript, you can get some of TypeScript's benefits, such as code completion and documentation on hover, by using JSDoc documentation in your JavaScript along with the VS Code text editor. JSDoc allows you to document types, though it doesn't have all of TypeScript's features. VS Code's JavaScript features are powered by the TypeScript compiler under the hood, so you even get access to TypeScript's built-in types. You can also add types packages from definitely typed, and VS Code will use those types as well. Once you've documented the types in your JavaScript files, you can even add a TS-check comment to the top of your file to get type checking in your JavaScript files powered by TypeScript. If you Google why use TypeScript, you can find all sorts of blogs about the technical benefits of TypeScript. And sure, there are many. But to me, where TypeScript really shines is not its technical, but its personal benefits. Many legacy code bases have code that people are scared to work on. I found that refactoring to TypeScript makes understanding these crafty spots so much easier, and sometimes even fun. Once you've added types to a significant chunk of your project, you will really start to see the benefits. Type annotations, coupled with JSDoc, are a place to pool the knowledge of every engineer that ever worked on that code. Eventually, you start to notice that you don't have to refresh your development app so many times to experiment because your code just works the first time around. I used to be scared to open pull requests on open source projects because it felt too public and unsafe. Opening PRs on the Ember types on definitely typed was a great way to get started in open source, and I've since moved on to opening PRs on other projects too. I've been to RustConf like 4 times, and each time I take the beginner and intermediate trainings and still feel totally overwhelmed. After using TypeScript for only a few months, I was able to transition to writing Rust, and it made so much more sense. I will forever refer to TypeScript as baby's first type system. TypeScript's answer key gives me confidence. So much so that I signed up to do this talk after years of saying, maybe one day. And now you all have to listen to me. And for that, I thank you.
Hello and welcome to my talk about waiting and things not working. So before we begin, this is me. When I'm not working, I often fly these weird little planes that don't have engines. And it turns out if you don't have an engine, there is no engine that can fail. When I'm not flying, I do a lot of open source development, usually in the Ember ecosystem. If you want to know more about me, you can find me on GitHub and Twitter. Sometimes I even get paid to work on Ember projects. I've been working for Simple Apps for about 4 years now. And you may know Simple Apps from popular Ember add-ons such as Ember Simple Auth, Ember Test Selectors, and QUnit DOM. We're a small consultancy agency in Munich, Germany, but we're working with clients all over Europe and sometimes also the US. But let's get back to the talk. This talk could have also been called Loading States and Error Handling, but that doesn't sound quite as catchy. The third topic we will talk about is testing, because we need to make sure that our loading states and error handling code doesn't break 6 weeks from now. Let's start by looking at a simple example application. This is a button. If we click it, a network request will be triggered. That sounds easy enough, right? This is the template of our button component. There are no surprises here. We have a plain button element, and that has an onClick modifier. Clicking the button will call the like action on the component class. This is the component class, and it's not too complicated either. We have a like action, and that triggers the network request. And that's basically it. But as you can see, there is no loading state, and there is no error handling yet. So let's change that. In this first chapter of the talk, we will look at implementing loading states. And more importantly, I will also show you how to write tests for them. So back to our example button. What we want to implement is a loading state. And it can look roughly like this. The button should be disabled, and the text of the button should change to please wait. So how can we do this? We can implement this in our component template by introducing an in-progress property. We directly assign it to the disabled attribute of the button, and we will use a condition in the button to change the text if the property is true. On the JavaScript side, we will implement that as a track property, which we set to false by default. Calling the like action will set it to true before starting the request. After the response comes back, we will finally reset it to false. But what happens when fetch fails? In that case, the like action will stop running and our property will never be reset. That is not what we want. We want to always reset it. We can fix this by using the try finally pattern. We will put the fetch call in the try block and reset our property in the finally block, which always runs, whether fetch fails or succeeds. Have you ever seen an assertion message that reads calling set on a destroyed object? This is related to another problem that we have in our code here. If the component is already destroyed when the fetch response comes back, we will set the track property on the destroyed component, because we can't cancel the async function. We can work around that assertion by checking the isDestroying and isDestroy properties before running any more code. But we will have to do that after every single async step. And this is easy to forget and not really ergonomic, right? So what we can do instead is we can use the Ember concurrency add-on. It is a good alternative that fixes this automatically. We can replace the action decorator and async function with the task decorator and generator function, as you can see on the slide here. We have changed the like action to a like task. The advantage is that generators can be cancelled and tasks will automatically be cancelled when the component is destroyed. We can also use the derived state that each task provides so that we don't have to manually keep track of our in-progress property. This change simplifies our code quite a bit. I would strongly recommend to give this add-on a try if you've never used it before. If you want more information, the add-on has excellent interactive documentation page on EmberConcurrency.com. Before we get to the error handling part of this talk, let's talk a bit about writing tests. So to get started, we will write a simple happy path test for our component. First, we call the setup rendering test helper function. We create a new test, we render our component, we click it, and then finally we assert that the counter shows the expected number of likes. Can you see the problem in this code? The problem is here. When we click the button, it will cause a real API request. And unless we are explicitly building end-to-end tests that involve a real backend, we should mock our API requests in some way. Mocking the request helps us build reliable tests that can be repeated many times without having to worry about the state of the backend database. Luckily, there are plenty of solutions for mocking API requests. The three most popular ones in the Ember ecosystem are Pretender, Mirage, which is built on top of Pretender, and Poly.js from Netflix. If you want to see other options, you can take a look at the Ember Observer website. For this talk, I've chosen Mirage, since that is what I'm most experienced with. To use it, we first import the setup Mirage test helper. We call it right after calling the setup rendering test helper. That allows us to use this.server in the test code to set up route handlers, for example. In this snippet here, that means that each post request to /like will return a JSON object with 5 likes in it. And then finally, as the last step, we adjust our assertion to match our mocked API response. Now let's look at the loading state tests. We can pass a timing option to Mirage, which will tell it to delay the response for a number of microseconds. In this example here, we've chosen 500 milliseconds. We've also changed our assertion to check that the button is disabled and that the label has changed. The problem is this doesn't work. The assertion fails. But why? The reason is that Click and other test helpers implicitly wait for network requests to finish before continuing with the test code. That means our assertion runs after the loading state is already gone again. We can solve this by removing the await from our Click call and don't wait for it to finish. Instead, we use the wait for helper and wait for the button to be disabled. At this point, we can run all of our loading state assertions. Finally, we wait for the app to settle, which means network requests and rendering are finished, and then we can check that the loading state is gone again. But now we have a slow test, and this doesn't really scale if you do it for every loading state in your app. If we decrease the delay, we might introduce a race condition that happens if the rendering of the loading state takes too long. We want to tell Mirage to continue immediately after the loading state assertions have run. A nice solution for this problem is using the defer function from the RSVP library that Ember apps ship by default. We first call defer to create a deferred object. We then pass the deferred promise to our route handler, and after the loading state checks have run, we call deferred.resolve to tell Mirage to continue. The result is a much faster test without any race conditions. Let's summarize this first part of the talk. First, make sure to use library or an add-on to mock your API calls. When testing loading states, make use of the wait for test helper and remove the await in front of the regular test helper. Use await settle to also check that loading states are reset correctly. And finally, use the defer function to avoid race conditions and to speed up your tests. Now we know how loading states work and how they can be tested. It's time to talk about error handling. And let's start with writing tests. When we pass a number as the third argument to Mirage, it specifies the HTTP status code that will be returned. We can set it to 500 here to return an internal server error, for example. At the end of the test, we can then assert that an error message popped up. And the error message we obviously haven't implemented yet. And how do we implement it? Should we add a place for error messages to every template in our app? That seems like a lot of work, and that can make the app look inconsistent to the users. A good solution for this is using a global notification system. This means having a service that displays notifications at a single location on top of the app. As you can imagine, this is much less work than having a dedicated error element in each of your templates. Here's a small list of add-ons that provide such a system: Ember CLI Flash, Ember CLI Notifications, and Ember Notify. For this talk, I've chosen to use Ember CLI Notifications, but the others all work roughly the same way. And it looks like this. First, we inject the notification service. Then, if the request fails, we call the error method on the service to show an error notification. By default, these notifications stay on the screen until the user explicitly closes them. But for most cases, we want to hide them after a few seconds. And we can use the auto clear option of EmberConf notifications for that. But if you use that, make sure to disable this behavior for testing. If you don't, the tests will wait until the notifications are hidden, which leads to very slow tests again. Let's go back to our error handling code. There's another problem here. Fetch can actually fail in two ways. The case that we have covered here already is an HTTP response with a non-200 HTTP status, for example, an internal server error. The other case is an actual network error, for example, when going into the subway. In this case, fetch throws a type error, and we haven't handled that one yet. The solution is to make non-200 status responses throw errors too. We can then wrap everything in a try-catch block, and we can move the notification into the catch block. Now we have a single place that handles both kinds of errors. To test this, unfortunately we can't use Mirage, because it does not appear to have the functionality built in to test network errors. But we can override and mock the fetch function manually instead. Here we override it with an async function that throws a type error, just like the real browser would. But we need to make sure that we reset this mock after the tests. Otherwise, all following fetch requests in other tests might also fail, and that's not what we want. We can solve this by implementing a small test helper. Let's call it setup fetch restore. It saves the regular fetch in a variable before the test, and after the test it resets it back. In our test module, we can use it similar to how we call the setup mirage function. This should make sure to always reset the fetch function, even if a test happens to fail. Let's move to a slightly different topic, error reporting. And by that I mean systems that let you know when your app fails in production. And it can look like this, for example. This is how an error report looks like on Sentry.io, which is one of the popular error reporting services. You can see that it displays a lot of different data about the error. The most important ones are the error message and the stack trace at the bottom. But it also shows us the browser and operating system of the user. And if you set it up correctly, it even shows you the git commit revision that your app was built from. As I said, Sentry is just one popular example of such a service. Other services like this are Bugsnag, Track.js, Rollbar, and there are plenty more available. I have the most experience with Sentry, so that is what we will be using for the following examples. We don't have too much time here, so I will not get into the details on how to set up Sentry. We will only focus on how to use it. If you want to know how to set it up, I will refer you to a blog post on the Simple Apps blog that explains it in detail. I've put the URL in the slides here. The following examples will assume that we've already set it up correctly. Let's look at how to use it. By default, all uncaught errors and promise rejections will automatically be sent to Sentry. But we can explicitly send errors to Sentry too. We first import the @sentry/browser package, and then we call the capture exception function and pass in an error object. But do we really want to send all of our errors to Sentry? This can create a lot of noise. Let's go back to our subway problem. When network errors happen, there is not much we can do about it on the app developer side, aside from showing an error notification, obviously. So we should probably not send these issues to Sentry because we can't do anything to fix these. Let's look at the different types of errors that can happen. As we discussed, network errors can basically always happen. Server errors are similar and also something we can expect to happen from time to time. For client errors, it depends. Sometimes a 404 error is legitimate, sometimes it tells us we're doing something wrong on the client side. We need to figure out what errors are actionable from the developer side and only send those to Sentry. We want to make sure to display error notifications to the user for all types of errors. But to reduce the noise on the error reporting system, we should only send unexpected or actionable errors to a system like Sentry. We can do this by checking the error type before sending it to Sentry. And as we discussed, we don't want to send network errors or server errors because those are not really actionable for us. But these kinds of functions don't exist yet. So how can we implement them? As mentioned before, fetch throws a type error for network problems. And we can use an instance object to figure out if the error is a type error. But unfortunately, we have no way of telling if it is an actual network error or if it is a different type error. We could check the error message string, but obviously all the browsers use different strings for that. We could do nothing, or we could wrap the fetch in a function and throw a custom error class instead. In the end, it is a complexity trade-off, and I will let you decide how strict you want to be with that. For the server-side error case, we will make a small adjustment to our response.ok condition code. Instead of throwing a regular error, we will throw an HTTP error instead. And you may wonder, what is an HTTP error? HTTP error is a custom error class that we can implement ourselves. In this case, the constructor here takes a response object, and it will automatically generate an appropriate error message for that. It also saves the response status as a property on the error object itself. This allows us to implement an isServerError function that checks if the error is an HTTP error and that the status is in the 500 range. To summarize, I recommend to use a notification system to make displaying errors easier for yourself. You should also use some kind of error reporting service to not run blind in production. When dealing with fetch, it can be useful to throw custom error classes like our HTTP error here. And finally, you should only send actionable errors to your error reporting service. And that's it. Thanks for listening, and I hope it was useful to you.
Hello, Ember people. I'm Michal Brixey, preferred pronouns he, him. I'm originally from Czech Republic, currently living in Edinburgh, Scotland, UK, and I just wanted to say hello. My favorite activities include running, mainly trail running, climbing, preferably sports, but I also like bouldering and lately getting into a little bit of trad climbing. Never tried winter really. I'm not good with cold. I have a black cat, which is snoring just here. This is Menda. Say hello. Meow. She's sleepy. She just woke up. Hello. I do front-end development for a living. I've been working with Ember for 5 years now, and I really like it. One of my secret superpowers is that I can break anything. And by breaking, I don't mean by hammer, but software. Basically, give me something, I will play with it for a little bit, and I guarantee you that I will find some bugs. Let's see. What do I do? What's interesting about me? Sell yourself. Also, I produce a lot of bugs thinking about it. So cute.
Hello, my name is Steve Cezina. I live in Colorado and I'm a UX engineer at CrowdStrike. This is a talk about memory leaks, specifically memory leaks in JavaScript single-page apps, like the kind of apps that we write with Ember. And I'm going to talk about how we, as a community, can put an end to them. First, I want to make sure we're all on the same page by defining some terms and concepts. First is the heap. Every physical device has a certain amount of RAM. The device allocates this memory to the browser, which then allocates memory to the JavaScript engine. So the heap is what we call this finite chunk of memory that is dedicated to the browser tab running our app. This determines how much memory our apps have to work with, and it varies by browser, OS, and device. So how do our apps use this memory? Well, every object in JavaScript is automatically stored in the heap as your program runs. This includes objects, functions, arrays, strings, numbers, booleans, and DOM elements. These things all take up memory while they are in use by our app. DevTools provides us the heap snapshot tool for visualizing the memory allocated in the heap at any given moment. You can see here that after capturing a heap snapshot of this chess app, we can see the heap size measured in bytes, and we can search the snapshot to see various classes from the app that are currently present in the heap. Although we can see what's in the heap, we have basically no control over memory management. Memory is automatically allocated by the JavaScript engine. So if memory is automatically allocated, that means memory must also be automatically freed up. Otherwise, we would eventually run out of memory. Garbage collection, or GC, is this process used by the JavaScript engine to free up memory. It does this by removing objects from the heap once they are no longer in reference. And it does this as your app is running. As soon as the JavaScript engine decides it needs to reclaim memory, it will briefly halt the execution of your program to run a GC. We can see this visualized here using another dev tool called the memory allocation timeline. As we use the app, we can see memory that is allocated, represented by the blue bars, and memory that is reclaimed by the garbage collector, represented by the gray bars. Normally, we don't have to think about this process. It just works. Well, most of the time. The rest of this talk is about the times where we do have to think about it. All right, so if the JavaScript engine automatically reclaims memory, how does it know what it can reclaim and what our program still needs? Well, GC roots are objects that the JavaScript engine uses to determine what can safely be reclaimed. Each JavaScript environment has its own set of GC root objects, but you'll probably recognize them. Node.js has the global object, the browser has the window object, and the document DOM tree. And DevTools also creates a GC root when it is active. These GC roots are separate, but they're all part of the same heap. When a GC needs to run, the garbage collector begins at each GC root and recursively traverses all the objects in reference, and it marks everything it finds during this traversal. Then it sweeps back through the heap and reclaims anything that wasn't marked. So you can imagine we might end up in a situation where we have object references that hang around unintentionally, preventing garbage collection from reclaiming objects that our program is done using. This situation is called a memory leak. When this happens, the leaked memory stays around in the heap indefinitely until the object's dominator is garbage collected. Dominator is just a scary word for some other object in the heap that's still holding reference to the leaked object. Now imagine that the dominator is a long-lived object, like an Ember service or controller, or worse, one of our GC roots, like the window object. Since this dominator will stick around for the life of the app, so will the leaked object. And if a memory leak is exercised over and over, say like a leaky component being rendered many times, the heap will fill up with these objects that we're no longer using, reducing the amount of memory available for our program to use. And this is a problem, because as the heap grows, GC will begin to take longer to execute and it will begin to run more frequently. Longer, more frequent GCs will cause poor perceived performance for the users of our apps, because more time is spent paused for GC and less time is spent running our code. Given a bad enough leak, the heap can also run out of memory, causing the app to crash. And all of this varies based on the device, browser, and OS. Devices with lower overall memory or lower CPU speeds will experience memory issues much sooner, and mobile browsers will often aggressively kill tabs that begin using too much memory. So hopefully you have a basic understanding of how the browser manages memory and how things can go wrong. Now I'm going to share a story about memory leaks and me. Before CrowdStrike, I worked on a very ambitious Ember app. It was the kind of app that users leave open in a tab for days on end. The app had a lot going on. Hundreds, maybe thousands of components on screen at a time. Drag and drop, keyboard shortcuts, in-app video recording, real-time data updates. These sorts of apps are sometimes called productivity apps or workspace apps, and they can be especially sensitive to memory issues. Apps like this often deal with lots of data and components, meaning lots of objects in the heap, and long sessions, meaning lots of time for memory issues to compound. So out of the blue one day, our customer support team began receiving reports from users that the app was randomly crashing. The crashes were unpredictable and there were no clear reproduction steps. At first, it was just a few customers reporting this, but after a few weeks, the volume of complaints grew. Users were experiencing multiple crashes per day, often losing work that they were in the middle of. They began to perceive the app as unreliable and unstable. We even began to see people complaining about this issue in our NPS surveys, and our NPS scores were being dragged down. NPS is a measure of customer satisfaction, and everyone in the company paid attention to it. As you can imagine, fixing this issue became a top priority for engineering. There was high pressure to fix the problem, but no reproduction steps. No clear indication of what the problem was or whether it was even a problem with our app. This was a recipe for disaster. We had a vague idea that this might be a memory-related issue, but it just as easily could have been an issue with an add-on, with Ember, or even with Chrome. And no one on our team, including me, was an expert in memory. I was like Ed here. I knew some of those words, but I had never faced down an app-breaking memory leak before. But we had to do something, so our team decided to dedicate 2 developers, I was one of them, for a full sprint to do whatever it might take to fix the issue. So we read up on memory leaks. This repo, Memory Leaks Examples, became our guide. If you're not already familiar, it's a great resource and goes into more detail on how to actually find and fix memory leaks than I have time for today. So without reproduction steps or a clear root cause, we set out to fix every memory leak we could find in our app in hopes that that would fix the problem. We captured countless heap snapshots. We recorded countless memory allocation timelines. We would run a test. We would open DevTools, capture a heap snapshot. Then we'd search the snapshot to see if that part of our code had caused a leak. Then we'd fix whatever code we suspected was causing the leak. And then we would do it over and over again. This is all a very manual, slow process. And heap snapshots are definitely not easy to interpret and make sense out of. And once you find the leaky code, it's not always immediately obvious what's even causing the memory leak. But we were making progress in fixing leaks, so one sprint turned into several. We merged PR after PR, hoping that each memory leak fix would be the one to finally fix our problem. But every time we fixed a leak, we would uncover another. This process led us to find and fix memory leaks in some of the add-ons we used. We even found a leak that was introduced by a recent upgrade of Ember itself, which fortunately had already been fixed in a newer release, so we just had to upgrade. But after all of this, we were still getting reports of the crashes. We had ruled out third-party browser extensions as a cause. We had ruled out low-end devices as a cause. We even watched customers use our app over Zoom, hoping to see it happen, but it never did. And we even thought about just giving up and engaging a consultant. Eventually, though, we realized that continuing without finding a reliable reproduction and root cause would continue getting us nowhere. So our last idea was to install a session recording tool in our app in hopes that we could capture a recording of a session that crashed and finally get something to go on. So a couple of weeks go by and nothing. No crash sessions had been captured, and we had stopped receiving complaints from customers about this issue. Months after we started fixing memory leaks and weeks after our last memory leak PR had merged, the problem just mysteriously went away. We suspect the issue was probably a bug in Chrome that had been patched in a recent release. So what's the point of all this? The point is memory management, when it goes wrong, is hard to deal with. All of the memory leaks that we fixed were very subtle. They were easily introduced by well-meaning, talented developers. They snuck through PR reviews and QA. They were present in our app, our add-ons, and even in Ember itself. And we as a community don't have a good way to detect memory leaks, find them, fix them, much less prevent them in the first place. And until a user complains that the app is slow or randomly crashes, we might not even know that there is a memory leak in our code. So what do we do about it? Well, we start by using Ember. Ember happens to give us a lot of tools to avoid memory issues. And although I happen to run into a framework level memory leak, they are actually very rare, and the core team cares deeply about preventing them. In fact, Ember is one of our best tools for avoiding memory leaks. There are entire classes of memory leaks that Ember developers just don't even have to worry about. For example, Ember's declarative template rendering system means that we pretty much don't ever have to think about leaking DOM nodes. The elements we render in our templates are automatically torn down by Ember once we are done with them, and we never have to think about it. These days, Ember isn't unique here. Other frameworks have the same benefit, but this hasn't always been the case in past eras of JavaScript development. Similarly, Ember's on modifier, used for adding event handlers in our templates, automatically takes care of removing event listeners. Forgetting to remove event listeners is one of the most common sources of memory leaks, and Ember handles this for us. And even when using our own custom modifiers to interact directly with the DOM, we are given a nice API to clean up after ourselves. So good memory management hygiene is built into Ember's common constructs, like components, routes, controllers, templates, and services. And the same memory management tools that Ember uses internally are now available via the Destroyables API, introduced in version 3.22. Destroyables give us a robust set of APIs for managing object lifecycles and cleaning up objects once we're done using them. So, Ember does a lot for us when it comes to memory management, probably more than most of us realize. But as we saw earlier, there are still opportunities to introduce memory leaks in our code. Here are some of the most common causes. We won't be covering these in detail, but it's likely that you have one or two of these occurring in your app right now. Once these issues find their way into our code, we're pretty much on our own as developers when it comes to dealing with them. Manually capturing allocation timelines and sifting through heap snapshots is basically the state of the art for finding and fixing memory leaks in our apps, assuming that we even know we have a leak in the first place. Like pretty much any other bug, memory leaks are much easier to introduce than they are to find and fix. And it's best if we can just avoid introducing them in the first place. That's why we have tools like automated testing, TypeScript, and linters. These tools have eliminated entire classes of bugs from our code bases. But this sadly doesn't exist for memory leaks. We often leave it up to our users to tell us that we have a memory leak, although they don't know that's what the issue is. We can do better. So out of frustration with the experience I just shared, and after some long thoughts in the shower, I realized that all of these problems could be solved. Thanks to Ember's strong conventions around testing and some open source packages from the Chrome team, I realized that we have the technology. So I wrote an Ember add-on called Ember CLI Memory Leak Detector that solves some of these challenges. It works by recording a heap snapshot after your test suite finishes running and the application has been torn down. The heap snapshot is searched for any retained instances of ES classes defined in the host app or add-on, and if it finds any retained classes in the heap snapshot, we know we have a memory leak. And the test suite fails, and a report of the retained classes is logged in the console output. This tool can be used after a full test run via Ember test, for example in a CI environment, ensuring that you never introduce a new memory leak in your codebase. It can also run on smaller sets of tests via Ember test --filter or repeatedly while you're actively writing code via Ember test --server. This means you can quickly tell if a test module or even an individual test exercises leaky code. This dramatically speeds up the developer feedback cycle when you're fixing memory leaks. The process of running a test, opening dev tools, capturing a heap snapshot, and searching it for your code now takes seconds instead of minutes. And it's integrated right into Ember's test harness. Since the add-on tells you which classes have leaked, you are able to narrow down to a set of test modules, then a set of tests, then a single test. Then you just change code in the leaky class until the test passes. It's like test-driven development for memory leaks. I'm really excited about this tool and the potential it has to benefit the Ember ecosystem in a few ways. One, it gives every Ember developer, including you, the tools to find and fix memory leaks quickly without needing to be an expert in memory allocation or heap snapshots. Second, it gives add-on authors and users of add-ons a shared way to understand, report, and fix memory leaks in add-ons. And third, it can prevent Ember developers from introducing new memory leaks into their apps. I would love to eventually get this add-on added to the default blueprint for new Ember apps. Between Ember's strong memory hygiene and Ember CLI memory leak detector, the Ember community has the tools to work toward a future where every Ember app is free of memory leaks. There's still work to do here, so let me know if you're interested in helping out. Before I end, I want to say thanks to Alex Ford and to TrueCoach for making development of this add-on possible. Thank you.
Hi EmberConf, I'm Pat O'Callaghan and I'm an engineer at Intercom. If you're not familiar with us, Intercom is a conversational relationship platform and our mission is to make internet business personal. We do this by helping businesses build better customer relationships through personalized messenger-based experiences. You may have come across our business messenger on your travels across the web. We are now in our 7th year of using Ember to build Intercom. We adopted Ember all the way back at version 1.4 with a small team of 15 engineers, and today we're running 3.21 in production with over 150 across our engineering org. Ember's promise of stability without stagnation and bringing the community along has meant we've never been left behind, and we've been consistently able to adopt new features like Ember Octane from day one. Thousands of our customers use Ember-built applications daily to connect with billions of their customers across the globe. I'm 100% certain if we had to make the same decision again, we would bet on Ember. I'd like to give a heartfelt thanks to everyone in the Ember community, from those that work on the core teams, the add-on maintainers, the bug fixers, the documentation writers, to those in Discord that have helped unblock us along the way. Ember enables us at Intercom to build from the 20th floor and focus on delivering value to our customers every single day. We've another big year ahead of us at Intercom and are planning on hiring lots this year, especially in R&D across the UK and Ireland and some roles in San Francisco. We have roles of all levels open across all our teams, including engineering and product design, with there being options of 100% remote work within the UK and Ireland. If you're interested, my DMs are open either on Twitter or Discord, or you could view our open roles at intercom.com/careers. Thanks and enjoy the rest of your EmberConf.
We celebrated some birthdays last month. I had a big one, and Square turned 12. Now you might know Square as the little white card reader that plugs into cell phones that lets you take payments on the go. But we've actually developed a suite of hardware solutions to help merchants take payments and a suite of software to help merchants manage their business. And that software is called Dashboard. And this is what Dashboard looks like. Merchants use Dashboard to keep track of their business. They can see their payment activity, they can send invoices, and they can run payroll. Dashboard is the home base for Square sellers. And Dashboard is an Ember monolith. Today, I am here to talk to you about modernizing our massive Ember monolith dashboard. My name is Aubrey Knudsen, and here I am at EmberConf in 2018 with Tomster and Zoe. I have been working with Ember for about 5 years, 2 years in our dashboard application and 3 years in a separate application that was a greenfield app and is a little more modern because it was newer. I have been participating in code upgrades and migrations and dashboard, and have recently been driving engine adoption from a product team, not an infrastructure team role. And I'm here to convince you that you can build ambitious web applications with Ember that stand the test of time. Today I will convince you that with Ember you can build for the long term. Ember apps can be used for years, almost a decade in our case. This is important because time is a finite resource. When we at Square have done the analysis in the past, a rewrite is always more expensive than the proposed upgrades. By spending less time on total rewrites, we're able to spend more time working on features for our customers, and there's less chance of regression. And finally, when we stick with Ember, we're able to build knowledge and expertise in our engineers that is long-lasting, rather than changing frameworks every couple of years. Our engineers become fluent in Ember, which makes them more productive over the long term. Today I will convince you that with Ember you can build resilient apps. Ember apps can be used by tens of thousands of people every day and have hundreds of developers contributing, because we've seen this in our app. And today I will convince you that with Ember you can build apps that evolve. We built an app in 2011, and now in 2021 we are using 2021 web technology in fundamentally the same app. So long as you're on the standard Ember path, Ember makes upgrading easy via documentation and semantic versioning, long-term support or LTS releases, which are versions of Ember that receive security updates for an extended time after their release, and code mods and lints. Code mods are tools that automatically make the tedious syntax changes to your code that you would normally have to do manually. Code mods can help ensure that you are using the latest patterns and platform features. And lints are static code analysis tools used to flag programming errors, bugs, stylistic errors, and suspicious constructs. And they often use code mods to automatically fix violations in code. But even in applications with weirdware, which I define as deprecated packages or experiments in code where we've strayed from the standard Ember path, those times, when we've decided to roll our own, it's possible to stay current with some effort, even in a massive application. We've done this over the last 10 years. Our app has a dedicated team that runs most of our upgrades, which helps a lot, but they do it in conjunction with product teams because they don't know how everything in the app works. But upgrading is possible even without a dedicated team, though it will be easier if you don't use any weirdware. In a much smaller, more standard app, I was the dedicated upgrade team, in addition to my product feature responsibilities. So this is the story of Square Dashboard. To give you some context, this is the commit visualization over the last almost 8 years that Dashboard has been in its own repository. And to give you a sense of scale, in 2020, we had an average of 140 developers contributing every quarter, with an average of 1,500 commits per quarter. And by my count, we've had over 600 individuals contribute to this code base at one point or another in their careers at Square. But this isn't 100% my story to tell. I joined in 2016, and then I switched to a non-Dashboard Ember team for about 3 years and came back to Dashboard in 2020. Several of my coworkers helped me write this talk, and I want to thank them for that. So let me take you back now to 2010. Wow, do you remember what the web looked like in 2010? I honestly didn't until I saw this screenshot. At this point, for Square, our main product was swiping a card on your phone and emailing or texting a receipt instantly. In 2011, we have a slightly newer looking website. It's still very simple though. You can take a payment, you can see your balance, and you can see when your balance will be paid out to your bank account. And in November of 2011, we introduced Sprout Core 1, which was a precursor to Sprout Core 2, which was later renamed to Ember, in our Ruby monorepo next to our ERB templates. And the commit message for this says, first day of hacking, and that's exactly what it was. It was basically 100 lines of script tags. In 2012, we had what we considered sort of our logged in web payment experience. It's so cute, right? The buttons have shading and depth. This is the view layer of our original Square Rails app. There's a simple tab of transactions, and you can click to view your receipt details, and you can filter your transactions by date. In 2013, we started to break up our web properties into separate apps. Dashboard was already getting too big and slow, and early code sharing via gems and Git submodules didn't work well. And so we moved Dashboard into its own repository, and it was a Rails app, and we were using Ember Rails, and we added Ember version 1.0.0.rc3.4. How's that for a version number? And in 2013, our app has some tabs across the top, adding more functionality as we are developing more features. In 2014, we did a total redesign and CSS rewrite, and now this is where it starts looking much more like the modern web to me. And as you can see, we continue to add features across the top. In 2015, in January, we upgraded to Ember 1.7, and for reference, 1.7 was released in August of 2014. At this point in time, upgrading wasn't a big priority for Square, and we didn't have a team primarily focused on doing it. This is also where we decided to start looking at our dashboard navigation project and figuring that out. But other than that, there's not a lot going on at the moment with the Ember framework and dashboard. We're busy building features. For example, we built and launched Square Payroll. Ember wasn't being super high maintenance, and it just kind of faded into the background. In 2016, in January, Ember is still on 1.7 in dashboard. And then in June, Ember 1.13 lands, and that was launched to the community in June of 2015, so we're about a year behind. But luckily, we didn't get stuck on 1.12. So when I joined in August, we were on Ember 1.13, and I'm told I dodged a bullet because I showed up late enough. Or maybe I showed up right on time. In any case, a lot of people had a bad experience upgrading to Ember 1.13 because it was really painful. And the Ember maintainers learned from that experience, and they try not to do that anymore, and they try to make upgrades a lot easier. 2016 was a year of more features. Everything at this point was written in CoffeeScript. That's because when we started Dashboard in 2012, JavaScript was a very different language. ES5 didn't exist. ES6 was introduced in 2015. And so CoffeeScript was created as an attempt to expose the good parts of JavaScript in a simple way. And the code compiled one-to-one to equivalent JavaScript, and there was no interpretation at runtime. And so CoffeeScript was the way to write web applications easily, and that's what we were using. But by 2016, we have ES6, and so we're starting to add new code in JavaScript, and at the same time, we were encouraging component use in Ember. Components had been available starting in 1.0, but we Sprout Core folks held on to the MVC structure a little longer. So for me in 2016, I was learning Ember, I was learning ES6 syntax, and I built this cute component that shows you your subscriptions and your monthly charges. And in December, we upgraded Dashboard to Ember 2.0, which had been released in August of 2015. That brings us to 2017. And I am dubbing 2017 the year of upgrading. This is where I think our dedicated team really shines. They were the ones driving this upgrade timeline, so product engineers didn't need to know how to upgrade our app. But they still worked with the product teams to verify that the features were still working. And so this verification process and requiring many teams to work together means that our upgrade timeline is a little slower than you might expect. So in January, we upgraded to Ember 2.1 and 2.2, which had been released in the fall of 2015. In February, we got to 2.5, which was released in April of 2016. In May, we got to 2.7 and 2.9, which had been released in July and October of 2016. So at this point, we're about 6 months behind. And in September, we got to 2.15, which was released that month. And so we're all caught up. And in December, we moved to an Ember CLI app, and we had to rename hundreds of components to match Ember CLI conventions, which we did with a code mod. And we also upgraded to Ember 2.16.2, which had been released a couple months earlier. Around this time, CoffeeScript was deprecated in favor of ES6 and JavaScript. And so we decided to do a CoffeeScript migration using a tool called Decaffeinate, which is a code mod that converts your CoffeeScript to JavaScript. And it was written by one of our developers and is an open source tool. We had coffee and donut parties, and we would be hanging out in a conference room, running the code mod all together. So it was like a really great bonding experience for dozens of engineers helping out with the migration. But now my name is on thousands of lines of code that I didn't actually write. At this point, we also have a team effort to manually eliminate partials. Components were becoming, and now are, the preference in the writer front-end community, and this was an effort to move our code to match the current Ember path to make upgrading easier. In August of 2017, we figured out what we were going to do with our navigation structure, and we split out this navigation into a separate Ember app. And so now, even to today, we have 2 Ember apps running on the same page. And one of our developers actually updated the Ember inspector to support 2 Ember apps. And that was pretty painful, but we got it working, and now you can choose which Ember app you want to inspect. But this is actually a much less active repository, and actually RenovateBot, which updates dependencies, is contributor number 2. In 2017, we also created something that we called sub-apps. They weren't in repo add-ons, but for simplicity, you can think of them as in repo add-ons, and we did later convert them to be in repo add-ons. And we used a code mod to move all of our files around, and this decomposition let us run fewer tests in CI, which made builds faster and less prone to dealing with flaky tests, which was a good thing for developer experience. It also gave us better code organization because each product team had their own sub-app that they owned, but it also created a lot of weirdware that we had to maintain over the years, and we struggled to maintain isolation between our sub-apps. So when the isolation wasn't perfectly enforced, developers could break our main branch by changing code that another sub-app relied on without knowing that the sub-app was going to break because CI wouldn't run the tests for that other sub-app. And so their PR would pass and go green, but then the main branch would fail. And we used linting to help maintain isolation, but it definitely wasn't perfect. In any case, I think people tend to underestimate how much experimentation you can do in Ember. We were experimenting with our dashboard navigation and with sub-apps. At this point, we have 2 Ember apps running on the same web page. And I think that Ember gives you more flexibility than you might think. And you'll see that as I keep explaining the next couple of years in dashboard history. But I think you also have to balance that flexibility with your tolerance for weirdware. In 2018, in January, we created a first version of our CSS library that was released as an Ember add-on, and we had extracted common styles and components from dashboard to be used across many of our Square Ember apps. And then we also upgraded to Ember 2.18, which was released that month. In April, dashboard got its first engine, and in August, we upgraded to Ember 3.1, which had originally been released in April earlier that year. In 2018, we also added a package called Wire.js, and this is based on Square's open source package called Wire, which is designed to incorporate protocol buffers in Android and Java. We use protobufs for a lot of our service-to-service communication, and it's often easier for developers to create APIs for our dashboard front end using protos. But protobufs are the worst on the front end. And so Wire.js is what we built to make it a little bit better. One of our developers built this tool to make it easy to consume and use protobuf APIs in dashboard. And it also let us do a little bit of modeling without using, Ember model or Ember data or some other structure on the front end. But this is definitely a weirdware alert for you. This package hasn't been open sourced, and I think we'd like to find a better solution, but it hasn't been top priority. But other than that, in 2018, we just keep building features, and we never really hit sort of a cliff of we can't keep going because of the framework or whatever else. And that momentum is important because it helps our engineers trust Ember as a reliable, stable framework, and they continue building up their fluency with the framework's patterns, making them more efficient. In 2019, we rewrote the dashboard homepage and we added these widgets, and you'll notice that the navigation looks different. We ended up writing the homepage as an Ember add-on, which is starting to modernize our dashboard even more. In March, we upgraded to Ember 3.2, which was originally released in July of 2018. In April, we got to 3.6, which was released in December of the prior year. And in August, we upgraded to Ember 3.12, which was released that month. So we were again caught up, and that is an LTS version. We also started doing more with Yarn workspaces. So Yarn was released by Facebook in 2016, and we were actually pretty early adopters in Dashboard and brought it in. And then Yarn workspaces were released with Yarn 1.0 in 2017, and we added them to Dashboard shortly thereafter. But we didn't start using them earnestly until 2019 because workspaces were buggy for many of the first releases of Yarn, probably until about 1.12, which was released in 2018 at the end of the year. And we actually ended up contributing a fix to Ember CLI so that it could find Ember add-ons in a workspace. And what we had experimented with and discovered was that, in-repo add-ons work, and you can do that, but for us, workspaces were a better solution. We had learned with our sub-apps that when you use in-repo add-ons, you don't really know where the boundaries are between add-ons and the app code and between individual add-ons. And Yarn workspaces let us keep our add-ons in the dashboard monorepo, which improves dependency management, while also delineating boundaries using standard Ember add-on patterns. And then at this point, my team restaurants started moving our sub-app code into a real add-on, which is an important move towards app decomposition with engines, because engines wouldn't have access to sub-app code or in-repo add-on code. At this point, we also added React running concurrently inside of Ember in Dashboard. There was a team that needed photo editing capabilities for a feature they were building, and that allows merchants to insert their own images into marketing emails that they send. And they decided they wanted to use a package called Photo Editor SDK, which was a React app. And so we ended up packaging the React app into an Ember add-on so that we could use the Ember asset loader to asynchronously load and execute the entire React framework and app code. And we did extra work to make sure that React would be lazy loaded only when you visit that features page. So you won't always be loading React. And it's important to note here, though, that we're not actually sharing any merchant context with the React app. In 2020, we upgraded to Ember 3.16, which is another LTS, and we opened the PR in May, and unfortunately, it's still open because we had too many observers in Ember model that broke when we tried to get to Ember 1.13. But even though we're behind, we're feeling okay because we're on an LTS. And for a little background, Ember Model is a lightweight modeling library for Ember with a limited feature set. And it was released as an open source project in 2013, and we started using it in Dashboard around that time. And its last release was in 2018, and we had continued to maintain a special Square branch to patch problems as we continued to encounter them. But we had ended up using Ember Model for several years, and in 2020 it all came to a head and we came to this crossroads. Ember Model was weirdware, and it was breaking Dashboard. So like we had before, almost annually, we asked, is this the breaking point? Is this where we decide to toss it all and rewrite it? And if we do that, should we rewrite it in React? And the answer was no. We decided that though the upgrade path was costly in the short term, there were so many benefits in the long term that it was worth it to migrate from Ember Model to Ember Data. We'd get rid of the Ember Model weirdware, and there would be better documentation and more community support for using Ember Data. And we would also get more extensive functionality for the models that we migrated. We also realized that we'd be able to upgrade Ember more quickly in the future. And finally, rewriting in any other framework we knew would be at least an order of magnitude more difficult than the proposed migration, although we didn't know the exact difficulty. The established Ember path has a lot of value, and so we decided to stick with it. So we started an Ember Model to Ember Data migration, and to give you a sense of scale, we've converted over 800 models in about 500 files off of Ember Model, and we're well on the way. We're not done yet, but I'm really excited about Octane features to come that we'll be able to get once we're able to upgrade past 3.12 and to be more on like a standard Ember path again and Ember infrastructure, so we won't have to go through this kind of painful migration again. In 2014, Square open sourced a package called QUnit BDD, which stands for Business Driven Development, for testing, which we used extensively in Dashboard. But in 2017, Square deprecated this package, recommending that folks use Mocha instead for BDD-style tests. However, we continued to use this package into 2020. And we knew that it was weirdware, and so one of our developers wrote a code mod to switch from QUnit BDD to more regular QUnit modules. And another developer wrote a code mod to remove some custom assertions that we had built into Dashboard's QUnit in favor of QUnit DOM. And I really like QUnit DOM. I had used it on my other team and was excited to have it back. And I think it's important to recognize that the Ember open source community has a lot to offer, and I'm excited that we're going to continue incorporating more of it into Dashboard. In 2020, we also had a push for more engines. We created a generator for conveniently setting up add-ons and engines in our Dashboard monorepo. I wrote my first Ember engine in the monorepo, and I ended up writing a lot of documentation about how to do it. And since then, I've taught a class on how to build engines internally, and we've seen an uptick in teams interested in building their own engines. And we've also started a TypeScript conversion. So you may be asking, why engines? We have decided that engines are the future for Square Dashboard because they improve development for hundreds of our engineers. They give us better code organization, like sub-apps did, and better understanding of what product teams own, which parts of code. Engines are a new and, for us, a better isolation primitive because it makes it less likely that we're going to collide with other teams because our engines own their namespaces. Engines also let us share code between Ember apps, so we can have it running in multiple places with a single source of truth, which saves time for our developers while giving our customers a better product experience. Ultimately, we hope that with enough lazy loading of engines, that the customer experience will be faster when loading Dashboard because they'll only have to load the pieces that they need when they need them. And engines and their dummy apps make iteration much, much quicker for developers. Running the Dashboard app or tests locally can take anywhere from 30 to 60 seconds to do a full rebuild after making changes. Ember dummy apps and tests can rebuild in 3 to 5 seconds, and this makes developers feel more productive, and it just feels better. And in the future, we're looking forward to hopefully be able to deploy engines individually instead of requiring a complete deploy of the entire monolith when changes are ready to go out. And this will make it easier for teams to own their production code and not be blocked by other teams. And here we are in 2021, and we have come a long way. So what made this possible? I think number one is all of the tooling. We used code mods and lints extensively. And lints were especially important because they let us make sure that during migrations, we aren't regressing and we aren't introducing a now bad pattern. Another thing that was a lot of time. Upgrading requires attention. We had a dedicated team that was anywhere from 3 to 8 engineers, so it wasn't too big to maintain our app, and it has gotten smaller and more focused over time. And we also have an internal community of developers that are encouraged to work on these sort of platform features inside of Dashboard in addition to their product work. Another thing that made this possible is Ember's stability. Upgrading and doing this over the last 10 years is part of Ember's philosophy, and that this is a good idea and a good path. Ember doesn't say start over, which is good because we've considered it a Square and we can't afford to start over. And upgrade paths are helpful, and LTS versions are, the backstop when we can't upgrade quickly enough. And if you stick within the standard path and patterns, you can leverage Ember for a long time and still have room to explore. And finally, the open source community. So Ember is opinionated, and the patterns are widely used, which make it easy to Google and easy to transfer knowledge between Ember apps. I left after 3 years and ramped up to Dashboard at the beginning of last year faster than my manager was expecting because I was fluent in Ember. But also I think it's important to note that weirdware is part of the Ember ethos, and it's a sanctioned enough path that so long as you periodically revisit your decisions to see if you should change them, it's okay. Ember doesn't want stepping off the path to be a full eject. But I will say that it's the weirdware that makes updating and maintenance difficult. But upgrading and reversing weirdware decisions is possible, and we are proving that even today. So today I hope I have convinced you that with Ember you can build for the long term, with Ember you can build resilient apps, and with Ember you can build apps that evolve. We've used Ember for 10 years for our main front-end project at Square, and we have chosen to stick with it. Looking ahead, we want to continue decomposing our monolith into engines, and this is going to require that we finish the Ember model upgrade and that we move those models then into add-ons that the engines can access, and also that we move global values into services for the engines. We're also looking forward to upgrading to Octane, and good news, you don't have to get rid of jQuery to upgrade to Octane. But we are actually already using some Octane features in Dashboard despite still being on 3.12. Things like angle bracket components, native classes and decorators, the on and function modifiers, and splattributes. Currently, we are not able to support Glimmer components and the @tracked property. We're going to have to continue removing deprecations to get to 4.0. We've essentially silenced a lot of deprecations instead of doing the work to remove them, to fix them, so we'll have to do that. We're going to continue upgrading our test syntax, and we're going to write more TypeScript. And yes, we're hiring.
Hi, I'm Casey. Good to see you. I have a short story. So 9 months ago, there were protests happening outside my window here in DC. There were low-flying helicopters and sirens constantly, and I couldn't sleep all week. On top of that, I got a furlough notice. And even worse, it got postponed and postponed and postponed. It was a looming dark cloud over everyone's head. It was just not a good summer or fall for a lot of people. I ended up furloughing myself so I'd have some certainty. I took time off of work, paid leave and unpaid leave, and I used that time to write my book, Debugging Your Brain. I've been working on that for years, and I just finally had coherent time to sit down and turn it out. It's based on my background in psychology and software development, and there's a workshop here at EmberConf if you're interested. After that, I left my job permanently to become an independent consultant so I can spend my time helping teams be happier and more effective, which is what I always do everywhere I work anyway. That's my favorite part of any job. I'm also working on a board game version of the book, and people like the prototype so far. That's been a lot of fun designing. So I guess I did my best to find the positive in the negative situation, like the pressure helped me change my trajectory in a really important, powerful way. I'm glad we'll be out of the woods this summer, hopefully. See you soon.
Hello everyone and welcome to our talk, Fast Track Ember with FastBoot and Embroider. I'm Suchita.
Hi there, I'm Thomas. So first let us do a little bit introduction for ourselves. My name is Thomas. I work at LinkedIn web framework team. And during my work, I interact a lot with Ember, and I also enjoy contributing to the Ember community. Outside my coding life, I enjoy making espresso drinks at home, and I'm also practicing latte arts. I also love playing games. My all-time favorite is the game Transistor, and I'm currently playing Final Fantasy VII Remake and has been loving it. And next, I'll hand it over to Suchita.
Oh, thank you so much, Thomas. I'm definitely going to ping you after this for the latte art. And hi everyone, I'm Suchita. I'm a senior engineer at LinkedIn. And I'm also working with the web infrastructure team like Thomas. And outside of work, I'm a core member of the FastBoot working group. And in my free time, I love playing cricket. It's a game very similar to baseball and super popular in India. And I'm a huge mechanical keyboards fanatic. And here is my latest creation where I switched my Gator and Brown switch to Holy Pandas and updated with new keycaps. And also during the pandemic, since we all were working from home, I uncovered a newly found passion, which is gardening. Let me share a few creations of mine that I did last fall. I sliced up the tomato and planted it. And on day 67th, I started seeing the first blooms of tomatoes showing up, and rest is history. We had so many tomatoes that we had tomatoes in almost all of our recipes. And I also grew some Thai chilies in the last fall. So this is about us, what we do and what we did in our free time. So now let's get back to our main topic, which is fast tracking Ember with FastBoot and Embroider. So last year, I presented the journey of Ember from 1.x to Octane, where we saw the paradigm shift that Octane introduced in the Ember community. This year, we will take you through a story of a team that migrated to Octane and are now looking to further improve their app with various aspects. We will first get to know the team and their requirements. We will then move on to understand how FastBoot powers the server-side rendering experience for the users.
And then we will talk about how we can optimize at the build time with Embroider to further improve the user experience and also developer experience. And last, we'll talk a little bit on what is on the roadmap for FastBoot and Ember. All right, Suchita, should we get started?
For sure. So now let's begin the story. So Zoe is an Ember developer who is super enthusiastic about Ember and is leading the web team of an awesome team at an awesome company that uses Ember.js as its framework. The current status of this team is that they recently migrated to Ember Octane and are super happy with it. However, soon after they got a few new requirements, which is very normal in our industry, right? Once we finish one feature requirement, we get a new one. So that's what happened with these people, and let's see what were the requirements. So first requirement was to deliver faster content to the page. The next requirement is to improve the user engagement, especially for the countries with slower networks. The last requirement is to improve the SEO or the search indexing factor for a specific route. So looking at these requirements, the first thing that comes into our mind is server-side rendering. So what is server-side rendering? To give you a brief overview, let's take a step back and see how client-side rendering works. So when a client makes a request or when a browser makes a request for a page to the server returns the HTML shell along with the JavaScript and CSS tags. Like you can see here, the body of the HTML returned by the server is empty. And once the JavaScript executes on the client side, it renders the HTML on the client. On the other side, with SSR, when a user makes a request for a page to the server takes in the request, runs the app in the server, builds the HTML, and returns the HTML to the client as a byproduct. Hence, instead of an empty HTML shell or empty body shell, you will see a page source filled fully with a statically rendered HTML. In Ember, this is possible with a library known as FastBoot. So FastBoot has been there for a while, and most of us know that it provides an SSR solution for Ember apps. But today, let me showcase what makes FastBoot so special and fast. So you can imagine the Ember application container as a stateless container that does not contain any specific data, user-specific information. Instead, it only contains the parsed classes, components, routes, registry information, etc. of your app. So when a user request comes in, it is associated with an application instance. So what is an application instance? You can think of an application instance as a stateful container as opposed to the stateless one that contains information like user data, services, models, etc., which is very specific to the user request or this request that came in. In the meanwhile, if there are other requests coming in, then instead of blocking the entire thread for serving the initial request, we put this app instance in the background using the async IO and spin up new app instances using the same app container that you see in the background. This is huge since we are cutting down the cost of reevaluating the whole app for every request. Instead, we are just reusing the same application container. And that is how we can serve multiple requests at the same time for different app instances concurrently. And once a request has finished serving, we destroy the app instance and the state itself. But one thing to note here is because these app instances are running inside of a sandbox, we prevent the state leakage between the app instances, which is great. But with that being said, one thing to be mindful about is since the application instances leverage the same container, we should avoid putting anything on the global scope or on the class scope because it might end up leaking in between the instances otherwise. So that's one thing that we should be careful about. So now that we understand the mental model of how FastBoot works and what are its benefits and how fast it is, let us see how we can measure the success of leveraging FastBoot in our app. So Google recently announced a few core web vital metrics that provide the guidance around determining the quality of user experience on the web, where LCP, which is the largest contentful paint, is used for measuring the loading performance. FID, which is the first input display, is used for measuring interactivity, and CLS, which is cumulative layout shift, which is used for measuring visual stability. So for the purposes of this talk, we will be focusing on the LCP metric since that's where FastBoot really helps. So what is exactly LCP measuring? It basically measures how much time it takes before the user sees the most important content on their screen, or you can say the hero element of the screen. Anything that is not in the viewport will not be a part of the calculation. So if you see the scale carefully on the left that measures this metric, anything above 4 seconds is considered to be poor. Now just imagine if a user has to stare at a blank screen or a loading screen for more than 4 seconds, it's certainly not ideal and not a good user experience, and it might potentially lead to the user abandoning the page. But if we could improve the time it takes to paint the content, then we can certainly improve the user experience and give them faster feedback and of course better experience. So now let's see the role that FastBoot plays in improving the LCP metric and connect these two aspects together with a side-by-side comparison of a world before FastBoot that you can see on the left and after FastBoot that you can see on the right. And here, for demonstration purposes, both of these apps are simulated on a slower network just to show you the impact. So let's see what happens when the user hits the same route at the same time before and after FastBoot. So here you can see on the right that clearly that the FastBoot enabled app is already showing up the content, whereas we are still waiting for the non-FastBoot app to show up. Now it is showing up. So the LCP measurement for the after FastBoot use case was 2.9 seconds, whereas in opposition the non-FastBooted case is 9.5 seconds. This clearly shows the value that FastBoot brings to the table. This would not only give users a better experience, but will also help retain the number of users who left the page due to seeing a blank screen. So now let us understand why did we see such a shift of amount of time taken before and after FastBoot to load the initial paint. To do that, let's see the timeline of the before FastBoot world first. Before FastBoot, it first waits for the HTML and CSS required for the page to load. It then loads the JavaScript required for the page. And then it makes any required API requests, here the articles call, like you can see in the example, to make the first page load. And that's where you see the LCP or the first content showing up on the screen. However, with FastBoot, the timeline is a little bit different. Here we can see that as soon as the HTML and CSS is loaded and the browser has finished the parsing, that's where immediately you'll see the content showing up on the screen or the LCP is marked. This is happening while the JavaScript files are still getting loaded. This means that we are not blocking on the render until the JavaScript loads, but rather we are showing the content or flushing out the content as soon as it is available. Since we now know how FastBoot is so beneficial, I would specifically want to highlight one aspect of FastBoot which helped with this demonstration very much. To do that, first let's see the before FastBoot use case. Here, if you see carefully, we are making two XHR calls, namely articles and tags, where the articles call is required to display the list that you can see on the left, and the tags call is required to show some data at the bottom of the screen. So this is normal, right? You make API calls and then render its response on the screen. This is a normal scenario. However, after FastBoot, I'll show you something different. So here you can see, surprisingly, we are not making the articles call, but you're still seeing the data on the screen. And just so you guys know, for the purposes of this demo, we have deliberately added this tags call as lazy loaded, just to show that FastBoot gives the developers a choice whether they want an API call to be made on the server side or they want to lazy load the network call just on the client side. So, okay, coming back to our example, like we can still see the articles list showing up without making the XHR call. What is making this happen, or what's enabling this? That's where the concept of ShoeBox comes into the picture. So let me walk you through how ShoeBox works, and then I'll show you an illustration of how it looks like. So when a user makes a HTTP request, FastBoot receives the request, it runs the Ember app on its side, and then it begins the process of serving the request. In the meanwhile, if the app has any API calls needed to be made for serving the initial page, which is articles in our example, then FastBoot will make that call to the data center, and the data center will respond it back with the data. And here is where the real magic happens. Now FastBoot will also store this API response in something called as ShoeBox. So now on the client side, when the app again loads and the time has come to make the API call for articles again, instead of making the XHR call, the client will query the ShoeBox instead and say, hey ShoeBox, do you have the matching response to this particular API request? And if the ShoeBox has a matching request, then it's just going to return there and there itself. So you can see the clear advantage here that instead of making an extra network call, we are eliminating that. Not only that, we are also responding with the data as soon as possible, like almost immediately. So the render time also improves. So now let's see, where do we store this information and how does the client get this information from? We basically embed the API response inside of the index HTML itself so that the client can later query. And this is stored inside of a script tag named ShoeBox, which you can find here on the screen. So this was a little bit about what ShoeBox is and how it works in the nutshell. And all of this is great, right? We saw all of the awesomeness that FastBoot has to offer, but now we come to the main question. How hard is it to adopt FastBoot? Or how hard is it to adopt all of the concepts that I just showed you before? Do we need to make a lot of changes in the app? Well, good for you. It's super simple. All you need to do is run this simple command, Ember install Ember CLI FastBoot, and boom, your app is FastBoot enabled. We also have an opt-in feature for smoother rehydration on the client side. So what I mean is, currently when you run this command, when server side responds with the HTML, Glimmer VM will re-render the whole DOM tree on the client side again. However, if you enable this experimental rehydration feature, which is experimental render mode serializes true, then Glimmer will only update the parts of the HTML that requires any correction that needs on the client side. which means things will be faster if you start using this experimental feature. Now to leverage ShoeBox, you can add a package called Ember Data Storefront and extend it in your application's adapter layer, which will do all the wiring required for your app to be ShoeBox ready. So this is everything is awesome. And now let's see if the use cases or the requirements that the team had, if we were able to match that and address those. So let's do a quick recap. So the first requirement was that they needed fasted content to the end user, and by improving the LCP factor, we were able to achieve that. So that's great. Next, by displaying the content sooner on the page, it showed better engagement from the users due to early rendering, which addresses the next requirement. And finally, since SEO is supported by FastBoot inherently, the search indexing requirement was fulfilled as well. So now everyone is happy.
A few moments later.
Surprise! Some new requirements coming in after a few moments. So this time, the good news is the company and the product is doing great, and now we're going to build more features and more pages. But the problem for the team is, since we will be building more pages and writing more code, that means we will have more code going into the JavaScript bundle, which will ultimately be delivered to every user's browser. So the time to a fully boot up client-side Ember app will increase. So the team is thinking about, can we ship only the JavaScript needed for the initial page that the user is requesting? Therefore, when we are working on some new pages, we won't negatively impact the performance of our homepage. And there is an answer from the Ember community that is to optimize the build of the Ember app. So let's introduce Embroider, a modern build system for Ember.js applications. So there are a lot of optimizations Embroider provide to your Ember app. Let's talk about some of the features. The first thing I want to highlight is code splitting. So traditionally, Ember CLI build pipeline, what it does is it will look at all the Ember code in your application and all your dependencies, and Ember CLI will transpile those code and ultimately build into two separate JavaScript files. One is for your own applications, and the other one is for all your dependencies combined together. What Embroider does is it starts to taking advantage of the long-adopted ES module syntax by the Ember community, which is the import and export syntax you have in your components and helpers, all the files. So what it does is it starts a static analysis for all those modules and figure out what are the exact code that you needed for a specific route. For example, for our homepage, we have the application route, the index route, and the services and the templates for it. And for an article route, which the user won't necessarily go into for the initial visit, we can put it in a separate chunk, and all the components that's only used by the article route will go together into that chunk. So this time, when the user is visiting the initial homepage, we won't be delivering all the code for the article route to the end user. And you can also choose to include any route together with the initial bundle if that route is important and the user might go to it immediately. So the benefit of doing the route-based code splitting is we can deliver a smaller initial JavaScript asset to the end user, and when we are working on another route, we won't concern about impacting the performance for the homepage. The other thing I want to call out is tree shaking. So imagine you are using an Ember add-on which provides a lot of useful helpers or components for your Ember app, but the problem is not everyone is going to use every functionality provided by the Ember add-on. If you are only using two of the helpers provided the add-on, traditionally the Ember CLI will bundle all the helpers into a single JavaScript asset, which you won't necessarily need it. What Embroider does is it will analyze the import, what exactly are the methods, helpers, or the components you're using, and only package those into the final chunk, and only deliver those to your end user. So this is great. So now you may be wondering, how would I use Embroider? So let's see how you can enable Embroider to your Ember app. The first thing you need to do is, of course, install the packages from yarn or npm, and then you can start leveraging Embroider in your Ember CLI build.js, which is everything the build happens for your Ember app. What Embroider does is it starts a multi-stage build, and the first two stages is to make sure all your Ember add-ons are compatible with the new build pipeline, and it compiles out all the Ember specific code. Then it can really start leveraging all the benefits from a wider JavaScript community. In this case, we're using the Webpack bundler to bundle all our JavaScript asset files. You can use the options provided by Embroider to progressively opt in to all the optimizations Embroider provides you. You can turn on the static, add-on, and helper component options to tell Embroider that you're not using the dynamic component syntax, so Embroider can safely perform the static analysis and build out all the chunks for your files. And then you can start enjoy the route-based code splitting by using the Embroider router. What it does is it will read what are the routes you want it to split away. And then when the Ember router is running, when it enters a new route, it will fetch those routes from the server. You can choose which route to split or which route to not split, so you will have the full control. And the benefit of enabling Embroider also provides you the ability to use dynamic import. So comparing to the static import, which is all the import statements you write at the very top of a JavaScript file, you can use an import that returns a promise everywhere in your component or any other JavaScript code. Once the promise resolves, you get access to the module you want to use. So you may, during the runtime, you have the full control of the exact timing you want to import that module, fetch the module, the JavaScript file from your server, and start using it later. And now you might ask, can I use it today for my Ember app? Will it break anything? So the question is, yes, you can start using it. And we have been using it at LinkedIn for a while. And we can share some of the benefits we are seeing when enabling Embroider on a large LinkedIn application. And we are really seeing Embroider start to bring faster speed to our end user. For when Embroider is enabled, we are seeing a 35% reduction on the initial JavaScript size reduction. And when the JavaScript is delivered to the end user's browser, the final parsed size of all the code combined is almost half of the original size. The reduced JavaScript bundle size translates to a faster page load time. So what we are seeing is from the beginning to a fully boot up client-side Ember app, there's a 6% reduction for the page load time, which is roughly 200 milliseconds on a simulated slower network. And most of the benefit are as expected coming from a faster download and parsing time. That's where the Embroider's code splitting and all the static analysis bring us. All the metrics we are seeing are collected by TracerBench, which is a controlled performance benchmarking tool we use a lot at LinkedIn. We use it to ensure we don't have any performance regression. And under the hood, it runs the initial page visit multiple times and give us a statistically confident result. In this case, TracerBench tells us it has more than 95% confidence that Embroider is indeed making the app much faster. And the benefit for the developers is also obvious for us. After enabling Embroider, we're seeing the code build has dropped by 58% of the original 100-something seconds. And the most impressive is the library load has dropped from 3.5 seconds to less than 1 second. So our development speed is also skyrocketing. So to recap, after enabling Embroider, we're shipping less code to the end user, which translates to a faster page load time. And as a bonus, our developer experience is also improving because of the faster build speed.
This is awesome. I think I can see the team already celebrating. They seem to be super happy with the FastBoot and Embroider adoption. So Thomas, let's talk about a little bit more of what's next in the world of FastBoot.
Sure, there are a lot of things we can do to make FastBoot and Embroider experience much better. So for a few things in my mind, we have a FastBoot app server, which is a production-ready, out-of-box server-side deployment option for people using FastBoot, and we want to add worker threads to it so we can further improve the server-side throughput. And we also want to support streaming back the initial HTML so people don't wait all the HTML get generated on the server side and start shipping it back to the browser, which will bring us a better, faster Ember app. We also want to make the faster and Embroider combined experience a bit better. Right now, if you load not the home page, but another page from the browser, what Embroider do is it will fetch the JavaScript file for a separate chunk after the Ember app boots up. What we want to do is we want to do this part in the FastBoot world as well, so that when the user gets the HTML, it can in parallel fetch all the necessary JavaScript for the Ember app to boot up.
Awesome. And just to give you guys more information, we are also planning to stabilize the rehydration feature and enable it by default for all the users, and also have a better testing infrastructure just to make it easier for the apps to test against FastBoot. And of course, we want to continue the effort of improving the developer experience. For example, adding more instrumentation in place, enhanced documentation, etc.
Cool. And here are some more resources for folks to check out. You can learn more about FastBoot at its homepage and Embroider at its GitHub repo. There are a lot of instructions and more details about it. And all the code we use for the demo app we showcased today, you can access on GitHub to see it yourself. And we really hope FastBoot and Embroider, these modern toolings, can provide better Ember developer experience and real value for our end user. And we really hope you are as excited as we are for the future of Ember.
Oh wait, but that's not all. We have one more thing.
What is that?
As a bonus, we are hosting a virtual FastBoot meetup where we will do a deep dive on FastBoot and its various concepts and aspects. Please feel free to sign up for the meetup on amberfastboot.com, and we can't wait to see you all there. Thank you very much, everyone.
Thanks.
We've just heard about the incredible gains made by LinkedIn using Embroider in production. And that's just where Embroider is today. For our closing keynote, Ed Faulkner looks towards what comes after Embroider within the Ember ecosystem.
Welcome, EmberConf. All right. So a fun thing about pre-recorded talks is that this talk is really being given simultaneously by me here in the past and present me, who's available to heckle myself in the chat and answer your questions. But you should listen to that guy. He knows things I don't. All right. I want to motivate this talk by starting with a side-by-side comparison. The scenario is this. You just joined a new team. You clone their Ember app for the first time. You've got no cache, no dependencies. You've just got the source code. You probably got Node, but that's about it. So on the left, we're going to watch as you follow today's normal steps to launch into development. And on the right, you should use a new approach that I'm going to go into in this talk. So let's let that play. So we'll watch as we do yarn install on the left, and we do a new thing on the right. And the app is ready on the right. It's already fully booted in development. It's working. We can get a really fast reload of it. And we're off to the races. Meanwhile, on the left-hand side, we are waiting for yarn install. Let's let that catch up. Now we're compiling some native packages. Okay, we're ready to start Ember CLI. Our app is available. It's self-reported about 9 seconds, but that's not really the full cost. And we made it. We are now also up with a fully running development environment, and it also has very fast reloading. Okay, so that was our summary of the two scenarios, and here's our waiting time. So here I was careful to measure the waiting time and not the interactive bits. The point, of course, is that there's a big difference, right? For some weird reason, the new scenario didn't even have to do a yarn install. We'll get into why that is in a second. That was a huge win. But even setting that aside, even if we just look at the actual build times, we were still significantly faster. What's going on there, right? So that's what I want to intrigue you with for this talk. We're going to get into, when your development tools respond instantly, software development's not just faster, right? It could be more fun and qualitatively more creative, right? So this is a talk about how the tools we use to do web development can be fast and fun without sacrificing the features we need to build reliable, long-lived, stable software on teams that are small and teams that are big. All right, so let's start with some fundamentals. All right, so the fastest build tool is no build tool. Right? You don't really need anything more than a text editor to develop for the web. And of course, this is how most front-end development was done for a long time, and some people still do it that way when they can. Ember first got started in this era, right? You would wire apps together entirely. You could do it entirely in a single HTML file, right? This is an Ember 2 app being developed with no web server at all, just serving the files right off disk into the browser, right? And the simple setup and the immediacy are nice, right? But in practice, this gets tedious pretty fast, right? As apps and teams grow, and you want to keep the code well organized into modules and packages and test suites, browsers just couldn't help you with that very much, right? And plus the desire to make apps run faster, boot faster, pushed frameworks like us toward ahead-of-time compilation and bundle optimization, right? And so even around the end of the Ember 2, the very early Ember 2 era that this is demonstrating, this was already on its way out. It was already becoming much more favored to use build tools, right? And that turned out to be the right call, right? Ember was among the first projects to really commit very strongly to requiring a build tool. And that was not a decision without controversy, right? Because the elegance and immediacy with having no setup and just working in the browser was really nice, right? There's a trade-off. We made the right call, right? And in the era that followed with Ember CLI and other frameworks too doing the same thing, everybody basically accepted that they needed build tools because it gave them a lot of power to develop apps that could just go much beyond what apps could do before that. Build tools and package managers, right? Gave a lot of power and a lot of sharing of code. So Ember CLI does a lot for you. There's a lot of great docs teaching how to use it. That's the current standard. That's what you should be doing if you're starting a new Ember app today. But I want to talk about what comes next, right? Here in 2021, browsers and web standards have come a long way since then, right? So it's worth re-asking the question, right? How far can we push in browser development now? How much can we do in the browser by itself, right? So let's take a quick tour together and see what breaks. So you probably already know that browsers support ES modules natively, right? So here we're going to put a script in type module, and we could just import some stuff into it. In this case, we're going to import off a CDN coming from Skypack, and we're going to use that code, and it will work, right? And so this works in browsers, like all modern browsers already, and tools like Snowpack and Vite take advantage of that fact to do a lot less work in their build server and more in the browser, and that's a positive development. Right? But here I'm asking a more radical question, right? Can we stop doing anything on the server? Other than maybe just serving up our files and telling us when they change, right? So how far can we push that, right? For example, what about package management, right? So package management isn't really important, right? It's deliberately indirect, right? When you want to keep your package versioning choices all together in one place, in a package JSON file, accompanied by a yarn lock file or a package lock JSON file, right? And then you want the code you author to not worry about that stuff. You want to be able to use abstract names for things, right? That keeps your code much more long-lived, right? It's more maintainable, it's more robust to have a real package management system, right? Browsers don't support bare imports like this, right? So maybe we've hit the dead end, right? Maybe it's time to say we need a server to rewrite this stuff. Well, maybe, but something you might not realize is that browsers are already shipping some features that get around this problem. Now, this particular one is new and not very stable yet, and you shouldn't really rely on it, but it works today in Chrome, and it's called import maps, and there's a draft proposal for a web standard that's not yet really a standard. And it works today, and it's cool, right? It lets us say where we're going to get our libraries from. Again, caution, it's not really a standard yet. Some folks at Chrome are trying to make it V1, and maybe they'll succeed. It has a bit of details to figure out yet. It has a bunch of good ideas in it, and we're going to use those ideas in this talk. Even without relying on having it natively in the browser, we're going to use the good ideas from here. The in-browser implementation that works in Chrome right now, it makes this example really does run. It doesn't support all the features in the draft spec. One of those is called scopes. It's a really important feature. So scopes is the idea that you don't just get to say what your own imports mean or where they come from, but you get to say that about your dependencies too, right? So you get control over your transitive dependencies. And that's a really critical capability that we've never had on the web before. NPM can do it, right? Like somewhat, right? We wish it had maybe better control and better optimization, but it does it, right? Real package managers have to solve this problem, right? You don't want your packages to be statically linked. You don't want all your libraries always statically linked. This is a general concept for all software engineering, right? Not just JavaScript. The idea of static and dynamic linking is the idea that if you statically link things, you're basically building them together into one piece, and then they're going to be one piece forevermore. When you dynamically link them, you're leaving the choice till later, right? What libraries your libraries are using is something that you can swap out. You could patch a security vulnerability in one of your deeper dependencies without the intermediate libraries having to act first, right? Or you can deduplicate the choices among transitive dependencies so that they can all share one version, right? That's really critical stuff that you need from package management that you lose when you're trying to get dependencies like completely pre-cooked, statically linked off of places like Unpackage or Skypack. So let's set aside import maps though for a sec and talk about another problem with our little setup here if we're developing in the browser, right? Let's move our JavaScript into a separate file, a separate module, right? Which is more realistic anyway. People don't want to put everything in line in one HTML file. So we're going to make a separate file. And we're going to continue trying to develop the way we were, which is just We're loading things off disk. So let's load this file. And uh-oh, it doesn't work. It turns out you can't load modules from file origin. So I guess we're up at the limit here, and we can't serve off disk anymore. So we really need a web server. So let's start one up. And I don't think this is a big deal. I think we're still true to our basic story of let's just do in the browser development, because web browsers need web servers. And a static web server is a very simple thing that runs, it boots up instantly. It's very easy to get and set up. It's basically not a big deal. I still think we're still on our path here of doing pure browser development if we just need a static web server. And that's going to unlock our access to several different browser features anyway, because there's a bunch of stuff like this that just doesn't work with file. It's just weird. Browsers want to be speaking HTTP, right? So let's move on to the next reason people think they might need a build server. Languages, right? People like TypeScript. We like handlebars, meaning Glimmer templates in Ember, right? Lots of people like Sass. And this is not Ember-specific problem, because people like Vue templates and people like JSX and people like Svelte, and browsers don't understand any of this, right? So I guess that's it, right? If you want to use any of these nice things, I guess you can't develop in the browser. I guess we need a build tool. Well, let's just see how far we can get, right? Let's take our little toy app and convert it to TypeScript. So let's rename our file from JS to TS. Let's add some TypeScript typed annotations that are just not valid JavaScript. Right? Let's change our import of it. And of course this doesn't work, right? In fact, our little web server we started thinks that TS files are MPEG-2 video. So bad guess, web server. No. So it looks like this is the end of our little adventure of in-browser development, right? It's really too bad that we can't just like ask the browser really nicely, like, please browser, please understand TypeScript. Wouldn't it be nice if that worked, right? Alas. Oh, well, it does work. That's the punchline. What's going on here, right? We're not cheating. There's nothing going on in this tab that is running that is doing anything weird. Right? If we try to load up the source, we see JavaScript. We don't see TypeScript. Where did the TypeScript go? Right? Somehow, in between our completely ignorant web server and our plain browser tab, our TypeScript's going away. Right? How could we possibly do that? Let's go look at the implementation of this library. Do you see the magic word? Service worker. Service worker is the key. So I bet you didn't think this was yet another service worker talk, did you? Right. That's because most people think service workers are only for offline apps. You've probably sat through talks before called offline apps with service worker. Right. But service worker is not about offline apps. Right. Service worker is a fully programmable place inside the browser, and you can put whatever you want in there. Right. People usually put in offline app support, but instead you could put in a TypeScript compiler. It turns out Service Worker is an excellent place to put development tools. Right? Dev tools play directly into Service Worker's strengths. Right? Service Workers are persistent. Right? Across page reloads, all your stuff is still there. Just like Ember CLI, just like your dev server is persistent no matter how many times you reload that tab. Right? They're excellent at caching. Right? Far better than anything you're going to be able to do in Node. Browsers are just the best at caching, and nothing's going to get stuff into your browser faster than the browser's own cache. Service workers, when you're doing them with dev tools, actually also avoid service workers' biggest pitfalls, right? Which is things like they're not available on the very first page load. In dev, that doesn't matter. It just means you get to see a couple seconds of loading screen while the tools boot up. Right? If you're managing version skew in a deployed application with service workers all across the web, that's hard. But that's not the case here. It's just on your machine. You could shut it down when you're done. You could kill it and start it again. And service workers don't support legacy browsers, but that's not such a big deal either. Right? The whole current crop of development tools in the web, in JavaScript, like Vite and Snowpack, all of them are all in on modules, all in on ES modules and modern browsers. And it's really where things are going. Right? This is very much in line with that. You can, of course, take the output of these apps and run them through a slower production build that brings them down to working in all browsers. But that's not where you do your development, your daily work. Right? You can do that in a browser that supports modules without loss of generality. So that's the core idea in this talk, right? Having build tools in the service worker feels magical. Right? It's like we just taught the browser to natively understand TypeScript, and from the app's perspective, it really does. Right? So that's the core idea. I think the next stage in JavaScript tools is service worker based. Right? So how do we bring that to Ember apps now? That's where Embroider comes in. Right? I'm pretty sure at this point in the conference, you have already heard some success stories about apps going to production with Embroider. So I'm not going to spend a lot of time trying to prove that it works, telling you that it's real. I expect by the time you're watching this, there's probably already an official flag in Ember CLI for generating new apps with Embroider out of the box, and a plan for making that flag become the default. Right? So Embroider is real. It is not future tech. It's now. I'm already looking forward. I'm moving on. All right. Here, I do want to explain, though, that Embroider is not, strictly speaking, a new build system for Ember apps. Okay. Incorrect. This is not about replacing one idiosyncratic Ember-specific build system with a new one. Right? There's a different story here. This is the more nuanced picture. Right? Embroider is really a combination of two things. It's a spec for how to share well-behaved JavaScript packages, even when those packages want to do ambitious things, like be a fully featured Ember add-on. Right? And it's a compiler for converting our large existing ecosystem of add-ons and apps into that spec, so that you get the benefits today without waiting for anybody else to rewrite anything. We've been working to make sure that everything you do in Ember has an underlying vanilla representation as standards compliant JavaScript that could be understood by a browser, understood by an arbitrary build tool, and basically making sure that all of the secret sauce or special semantics are all things that you could just say in JavaScript, right? Let me give you an example, right? So you probably know that when you have a JS file and HVS file side by side in your components folder, Ember mashes them together somehow and makes a component for you, right? Well, this is the vanilla representation of that, right? And this is not even Embroider specific. This is a thing that's core in Ember already. This is stable and shipped, right? Under the hood, this is what Ember is doing. This is what it looks like to put together a template and a component, right? And the fact that this exists as a kind of intermediate step in your build, whether or not this file ever actually gets written or whether it kind of gets glossed over in some build tool, is really important, because it means we're designing a system that is understandable in terms of nothing but web standards, right? You could give these things on this screen, including the template compilation and the component template. They can have runtime implementations or not, right? They can have compiler implementations, and that's fine too. The point is, though, that this makes sense as JavaScript, right? And a general JavaScript tool understands it. Right? One such tool is Webpack, right? And so if you've already been using Embroider, you've probably been using the Embroider Webpack package. So Embroider Webpack takes care of automatically setting up Webpack for you in a way that's most compatible with Ember, and takes care of like lots of the little details of making sure that your app is going to do all the things you want, right? Your test suite's going to work right, your FastBoot server-side rendering is going to work right, etc. Right? All that, though, is just a convenience, right? You could just run Webpack separately. Let me show you what that looks like. So this is an example of the changes you'd have to make to go from delegating to Embroider Webpack to doing it yourself. So here we're just going to drop Embroider Webpack as a dependency. We're going to stop setting up a final stage packager in Embroider, telling it to just leave things alone. We're also going to customize where Embroider is doing its work, because this is where we want Embroider to place the vanilla application for us. Now that we're not getting Embroider Webpack to set things up for us, we're going to have to set up a few things on our own. So we're going to add a Webpack loader for handlebars. We're going to add a Babel loader so that we can transpile stuff doesn't work in browsers, particularly things like decorators. We're going to be able to drop Ember CLI live reload, because we're going to get the native live reload out of Webpack. And of course, we need a Webpack config, right? It's not that big. You can see the scale of it. It's not that complicated. Certainly, it's nice to not have to write it at all if you use Embroider Webpack. The point here, though, is that if you needed to go down a level, if you needed to try something out, or you just wanted to experiment, you could, right? And it works. You can see here setting up the basics of template compilation, Babel, making sure our index.html file has the right references in it, and then we're off to the races. That one screen full of code is all it takes for Webpack to understand arbitrary Ember apps now. Let's see how you would run this. All right, so we would still tell Ember CLI to start up And it's going to do a relatively short build because it's only doing the translation from all traditional semantics, all legacy behaviors of all add-ons, up to the vanilla spec. Right? It's going to output that for us, and then we can take it forward from there with whatever we want, in this case, Webpack. So here we're booting up Webpack. I had to type the full path out just because there's a weirdness going on with no yarn symlinking right there. And then we can boot it up. And here's our app being served natively by Webpack's dev server, right? Works fine. And we can make some edits. And notice we're editing here the original source, right? We're not editing that vanilla app because we can make a change to the original app and it'll flow very quickly and incrementally through both systems. It'll get translated from the, classic to vanilla, and then Embroider picks it, and then Webpack picks it up, and we're off to the races. So it works, and we aren't limited to Webpack, of course, because there's lots of other build tools. Let's try to swap into something like Snowpack. Snowpack's different, right? Snowpack's newer, and it goes all in on native modules and modern browsers, and it does less work in the build server and more in the browser. And let's watch what that looks like. So here I didn't share the setup piece. I'll share some links with it. There's a small number of bugs I had to fix to get this all working. This really does stress that all of our stuff is truly following the module spec, because here it will really run as modules in the browser. So where you were cheating or using compatibility doesn't work here anymore. And there's just like a handful of places in the ecosystem where that pops up, just because nothing was checking it before. Even Webpack is more permissive than a true browser running modules. So here you can see the build output of an Ember app built with Snowpack. You can see we still have all our imports there. The browser's natively doing the imports, file to file, one at a time. Our dependencies are getting rewritten by, all of those import statements are being rewritten by Snowpack to point at its pre-bundled packages. And it all works pretty good, right? One thing you might have noticed is that the initial page load here was a little slow, right? And that's actually just because work is being moved around, right? The starting of the Snowpack server is basically instant because it doesn't have to do that much. And then that work is moved here into the browser. So the very first time you load the page in the browser is when Snowpack is discovering files one by one and transpiling them. So it's a trade-off that ends up being worth it, and one we'll see again. So the point is not that to make every new Ember user choose their own toolchain, of course, right? We always want to ship with a great out-of-the-box experience. That's just a given. That's basics of why Ember is Ember and what we're trying to achieve here. It's having a really community-curated bunch of things that work well together, right? But it should be possible for people to experiment and for the community to shift naturally over time as new things become possible, right? So that brings me back to the service worker-based build stuff, right? Just like we can swap in Webpack or Snowpack, we can swap in something entirely new, right? So the thing I demonstrated in our opening comparison is a tool I wrote that is brand new, not really production ready yet, but I'm really excited about how much it can already do, and I'm excited to show it with you. I'm calling it Mo, and that's the symbol of a Mo, actually. Mo is a kind of not very much used anymore unit of measurement for the opposite of resistance. And I hope that's what Mo is in your development, right? It's something that is the opposite of resistance, stopping you from what you want to do. Mo is not for building Ember apps. It's a general purpose tool for building JavaScript apps, right? Just like a Webpack or a Snowpack. It just so happens that it's also great at building Ember apps because Ember apps are good web citizens post-Embroider. All right. Let me switch into my demo of Mo. So just like we did in the little comparison video, we're going to boot it with npx. And that was it. That's the whole booting. And even if it would download it, it's basically imperceptible because the whole package is one file. That one file is a web server, a pretty small web server, written in Rust. It's pure Rust. And all it does is HTTP, and it's very good at HTTP, and it doesn't understand a thing about JavaScript. Right? It does have embedded inside of it some pre-baked JavaScript files that it can serve, and that's what lets us bootstrap up to the next phase of capability. Let's oh, and so the one other thing it can do though, right, is other than just serving our files, which of course it can do. So if I wanted to look at a file, I could. All right, there's my application template. It serves a manifest of all my files. And very, very quickly, it can crawl the files in my project and give me versioning of them. And so the idea here is this really becomes foundational tech within the build tool to do really efficient caching, really efficient interdependent builds, and even efficiently query things like, tell me about all of the templates, or tell me about all of the files in this subdirectory, right? We can do that very, very effectively with something like a manifest. So let's take a look at what happens when we visit the root index.html page. And I'm actually going to disable JavaScript here because otherwise it'll happen too fast for us to talk about it. So when you ask this web server for index.html, you get really just a script, one page that says launching service worker with a script tag, right? And this is the client side library of Mo client. And there's not much in it, right? It's really just the beachhead. All it's here to do is to cause the service worker to load, and then wait for it to load, and then refresh the page. And that's all it has to do. So most of the interesting stuff is going on here in the worker. And the worker is about 9 megabytes of JavaScript, which sounds kind of big if you're used to shipping apps on the web. But it sounds kind of small if you compare it to all of to what it's replacing, which is all the development tools that you have in Node modules, which add up to megs and megs of stuff. It also only downloads once, caches forever, and it doesn't even have to reevaluate when you refresh the page because it's living in the service worker. All right, so it's extremely efficient. Let's actually let this boot now. And we'll turn JavaScript back on. We will let that code run. And we'll see actually how long it takes for that tool to load in. It's not very long. Now we're already in the initial page load of the Ember app. And just like in the Snowpack case, you can see that the very first one takes a little while. Right? That's because we made a similar trade-off, actually even more extreme trade-off, right? Which is that we're doing nothing in terms of transpilation or package management on the server. Our server is just a dumb web server that knows nothing about JavaScript and only serves files, doesn't transpile them at all, right? All of the work of discovering the files in our app had to happen here in the browser, right? And so let's look at, all of a sudden, we're still on index.html, the same page we were on before, but now it has different content, right? So what's going on there, right? Now that the service worker has taken over, it can intercept that request for index.html and decide what to put there. And in this case, Mo has an Ember plugin that knows, oh, I'm going to put an Ember app here. I see that you have an index.html file. I see that I need to compile your JavaScript and make sure that I have an entry point module that I'm going to insert in right here where your other JavaScript used to be and serve that back. Right. So let's take a look at some of our specific files in this app. Right. They're all still here. So app templates application HPS, we can go see it. What we see when we load it is the compiled version of it, right? Because this is what our app will see when we load it. The service worker has compiled this template into the compiled form for us. Mo has a little option we can include for debugging where we can ask it to please lay off and let us see what's actually going on the network. And this lets me see what is really coming off the web server before it has been transpiled. Here you can see the raw HTML, raw HBS that's being served into the browser. Right. Let's do the same thing for a JavaScript file. We have a sample Ember data model here. Let's look at the network version first, because that's the simple thing that we authored. So here we've got an Ember data model with one attribute. We've got a bunch going on though, because we're importing things from a library and we're using a decorator, right? So when we look at what that has turned into, well, it turned it into a bit. Babel had to get rid of things like decorators for us because this app's configured to transpile those. Well, every app has to transpile decorators. They're one of the things that browsers really can't do yet because we're really hoping those will standardize. We got some new imports because Babel has implementation that actually is coming from a library. All of a sudden we see that our libraries are now coming from the web somewhere out on an S3 bucket. We'll talk about that in a moment, about how we're controlling that. But here's Ember data too. Here's our Ember data import. Notice it's still a real import, right? The browser's doing the modules for us. We never had a step where we had to crawl all the modules and find them all because browsers do that, right? They're good at it. And when those modules are being served out of a service worker cache, it's so fast that it's fine to let the browser do it. So in this case, we're getting Ember data off of this S3 bucket. Let's go see what it looks like over there. All right, here we can see, well, untranspiled stuff. We're seeing bare imports. These aren't going to run, of course, if we try to run them. So what's going on, right? Well, what's going on here is that I've just left my service worker's scope, right? My service worker does not have permission to rewrite everything coming off of AmazonAWS.com. So we're seeing the raw network version of the thing here. But when my app asks for it, it's going to go through that same translation process. And that translation process includes an import map, right? So even though this is a third-party package coming off of, I depend on a certain version of Ember data. This is part of Ember data. Once it loads into my app, it's going to run through my import map. The service worker takes care of that for me so that by the time the app sees it, these are turned into URLs. Let's take a look at that import map. Again, it's just a normal file sitting in here. So when you would develop an app this way with Mo, the import map is really the equivalent of yarnlock. And in fact, this one was generated by translating yarnlock into the new thing. This is the secret to why was I possibly able to skip running npm install or yarn install to get the app booting. The idea is that when your team is working this way, your team only really needs to do that step once. When you get a new dependency, somebody's got to npm install it, run the importing tool, get the packages published to your S3 bucket, or eventually, we hope, to a publicly shared one, so that you can skip the whole npm stuff entirely, right? With a little bit more package management stuff around this, we can get to the point where all of this is native all the time and nobody has to stop and run npm install, right? We could really use a package manager that's native to the web. That's a bigger project. Keep an eye on this space. The folks at CrowdStrike are doing interesting work on this area with kind of trying to take on the whole package management problem that would interact well with, that would integrate great with this build tool. Let's also take a look at, I mentioned the entry point file. This is an example of a file that is totally made up, right? And it's Ember specific. So of course, what's going on here is there's an Ember specific plugin to Mo that knows how to synthesize the entry point to your JavaScript. And in an Ember app, that means we've got to do things like register with Ember a bunch of stuff that is just Ember expects to exist. So add-ons, for example, can stick stuff in here. So Ember data is registering things into our app, right? This is the tree for app feature that add-ons use. How can that possibly work on the web, right? Add-ons need to stick things in here. Well, all of our packages up on that S3 bucket, they still have their package JSON files. And critically, all of them have already run through Embroider, right? Embroider turned them into spec compliant packages. And Embroider v2 packages have to declare explicitly in package JSON in a very static and easily defined form exactly what features they're using, including their app.js exports, right? It means that we can very cheaply in the browser crawl those package JSON files once and then cache them and know exactly what features all of our add-ons are using. So for example, how does our familiar Topster graphic work here, right? That's coming out of an add-on. How does it boot in my browser here? I can go to this URL and have an image, but why, right? This is that kind of feature, right? The Ember plugin to Mo knows how to find all my add-ons, find their package JSONs, see what features they're using. In this case, Ember welcome page, right, is an add-on that we're using. We know that it's in our list of add-ons. Our import map can resolve where do I find out about Ember welcome page. It's here. If I go there, here's the package JSON. I can look very statically. This is a v2 Ember add-on. Embroider has converted for me. And when we did that, as part of that build, as part of the import step, when this package was first sucked into this new world of how we do development, it did have to run all kinds of compatibility code to get it up to this point. From here forward, it's all legible and static and easy to find, right? And in particular, this package declares that it has a public asset we need, right? It says, I contain this particular file and I want it to be mounted at this URL in the app. And so that's what we do in our build, and that's why it works, right? So we can do lots of those kind of features, very ambitious features of automatically integrating stuff, all done here in the browser. And rebuilds, of course, work great. You know, if I come and rewrite this page and I save, I get a very fast rebuild. And if I open up the DevTools here, we can actually see we got a single cache eviction for that one file. And if we looked at our web server, we would see two requests, right? We fetch the manifest, and the manifest would reflect one changed file. And then the service worker is going to fetch that one file, transpile it, serve it back to us, and that's it. That's all the work that has to happen. Everything else in this app, when you look at the network tab of loading this app, right? Everything's location is service worker, service worker, service worker, service worker. Right? We download nothing to boot this app. Right? That's what keeps it fast, despite having so many independent files. And of course, having the independent files is great, right? Because we can debug them the same way we authored them. We don't need a source map to tell us what file something came from. It's still in that file. Right? It's very nice. So the last thing I'll say about it is that service workers can get real confusing if you forget they're there and you stop doing development. So this one makes it sure that if we shut down our web server, the service worker code will pretty soon realize that its server has gone away and shut itself down and unregister itself, after which point our browser is back to normal. And all of that magical rewriting of our stuff goes away, right? Because otherwise it could be very confusing. If you switch to a new project and it was still there, it's a mega troll. So one of those little niceties you really want to get right with service workers. So that concludes the demo piece. And just to wrap up, the key takeaways I have for you is really that, you know, the future of web build tooling is exciting and very bright, and we're going to make it it's good now, and it's going to get even better. And that Embroider is the Ember community's bridge into that future, right? And we're going to keep shipping, keep stabilizing, keep making it even easier and more default until every Ember app just works with all of these things I'm showing you without extra effort, right? That's the goal. So thank you all for your attention. I will make sure that I have supporting materials and links during this talk at this permalink. Even if you're viewing this far in the future, you could check in here to see what was the next step in the story. And so I'll leave that on the screen in a sec. EAF4.com, EmberConf 2021. And that's it. Can't wait to see you all next year. Thank you so much. Goodbye.
Thank you so much to everyone for attending this year. And thank you to all of the speakers for inspiring us with your insights and knowledge. If this was your first time participating in the Ember Discord server, please don't be a stranger. It's been a long year, but the energy from this conference and the solid community we have here is really something worth celebrating. Bye, everyone.